Hey guys, welcome to this course on Python programming for beginners. So why learn Python? Because using Python, you can build almost anything. Python can be used for web development, game development, computer vision, robotics, graphical user interface development, and also Python is the #1 language of choice for machine learning, data science and artificial intelligence. So the goal of this course is to provide you the working knowledge of Python programming. We will start with the basics, starting from the installation of Python on your operating system, and then we will learn all the basic concepts in Python programming like variables, data types, operators, control statements, loops, strings, functions, and also Python collections like lists, tuples, sets, and dictionaries. Then we will move to the object-oriented programming concepts in Python. So in this section, we will start with what is object-oriented programming, what are classes and objects, and then we will cover the concepts like encapsulation, inheritance, polymorphism, abstraction and access specifiers. Also, we will see some advanced object-oriented programming topics like abstract classes and compositions. Next, we will see how we can handle exceptions using Python programming. Then we will move towards some advanced topics like Python iterators, generators, decorators, and also we will cover some functional programming concepts using Python. I will also cover how you can debug your Python code, and also we will see how to use pip, which is a Python package management system, to install and manage your software packages written in Python. Now, if you want to see the whole list of topics which will be covered in this video course, then you can see the description of this video and you will be able to see all the topics which will be covered in this video. So by the end of this course, you will be able to apply whatever you have learned in this course in your own projects or for applying for a Python programming job. So what are you waiting for? Let's get started. In this video, I'm going to give you a brief introduction about Python. So let's get started. So first of all, what is Python? So Python is a high-level dynamically typed programming language. Python supports multiple programming paradigms including object-oriented, imperative, functional, and procedural styles. Now Python is an interpreted language. So what do we mean by interpreted? To understand this, we need to understand the difference between the compiled languages and the interpreted languages. So some languages like C, C++, Java are all translated by running the source code through a tool called compiler. This compilation of source code results in a very efficient bytecode that can be executed any number of times. Now, interpreted languages like Python, in contrast, must be parsed, interpreted, and executed each time the program is run, thereby greatly adding the cost of running the program. So a compiled language takes the entire program as a single input and converts it into machine code or byte code, which is stored in a file called a binary file. On the other hand, interpreted languages like Python takes the single instruction as single input and execute that instruction. Now, compiled languages run faster because compilation is done before the execution. On the other hand, interpreted programs run slower because compilation and execution takes place simultaneously. In case of Python, even though it's an interpreted language, but it's really fast. Now, Python supports dynamic data types. And to understand this, we need to understand the difference between statically typed programming languages and dynamically typed programming languages. So, at statically typed programming languages do the type checking at the compiled time as opposed to the real time. And dynamically typed programming languages do type checking at runtime as opposed to compile time. So let's say you declare a variable x is equal to 9 in Python. Python will do its type checking at runtime, whether it's an integer or a string or a double value. All will be done at the runtime. Now Python is independent from platforms. That means it's a cross-platform programming language. That means you can run your Python code on Windows, Linux, Mac, or on any other Unix operating system. Now Python focuses on faster development time. So Python code has a very natural style to it, which makes it easy to read and understand thanks to the lack of semicolons and braces. So we don't use semicolons or braces in Python. That means faster development time, especially when you are doing some prototyping work. Python is a highly readable language and has a clean visual layout. So if a developer writes a very efficient Python program, it's like reading English language. Now Python have high level internal object data types and have automatic memory management, and at last Python is free and open source. That means you don't need to pay anything to start learning Python. Now let's talk about some history about Python. So Python was conceived in late 1980s and its implementation began in December 1989 by a developer called Guido van Rossum in Netherlands as a successor of a programming language called ABC. Now Guido van Rossum worked at Google from 2005 to December 2012, where he spent half of his time in the development of Python programming language. And nowadays Van Rossum is working in a company called Dropbox. And from where this Python name come from? Rossum chose the name Python since he was a big fan of Monty Python's Flying Circus. So Python was first publicly released in February 1991, and python.org, which is the official website of Python, was released in the time period between 1996 and 1997. In the year 2001, Python Software Foundation was created and Van Rossum remained the principal author of Python. His continuing central role in Python development is reflected in the title given to him by Python community, which is Benevolent Director of Life. Now what is a Benevolent Director of Life? This is a title given to small number of open source software development leaders, typically the project founders, who retain the final say in the dispute or arguments within the community. So why learn Python? Because Python is fun to use scripting language. And as I said, Python is a multi-paradigm programming language which supports object-oriented, imperative, functional programming and procedural styles. That means it's highly recommended for the educational purpose. So majority of educational institutes use Python as the first language which they teach to their students. And why it's the first choice of educational institutes? Because it's very easy to learn and it runs on any platform. Now Python is very powerful, scalable and easy to maintain programming language which enables high productivity, and it has lots and lots of inbuilt libraries which a developer can use. Python is also used as a glue language which acts as an interactive front end for the languages like C and C++. So when you develop in Python, it reduces the development time, it reduces the code length, it is easy to learn and use as a developer. It is easy to understand codes, it is easy to do team projects in Python, and it's really easy to extend to other languages if you are using Python. So where can you use Python? So because Python is a general purpose programming language, it is used in many web development frameworks. For example, Django and Flask recently became very popular for web development. Now Python is also widely used in scientific computing, data mining and machine learning, and continued growth and demand for machine learning developers may be driving the popularity of Python. Now as I said, Python is used as a scripting language. That means if you are doing prototyping, it's really efficient to use Python. Python is also used in the development of graphical user interfaces, embedded applications, gaming, and DevOps tools. And at last, as I said, because Python is really easy to learn, it's used for educational purposes as the first programming language for teaching programming. Now the question arises, which version of Python should you learn, Python 3 or Python 2? So I would recommend Python 3 since it's more modern and it is a more popular option at this point of time. So I will be teaching this course in Python 3. So this was a brief introduction about Python. From the next video, I'm going to show you how to install Python and how to use Python as a programming language. In this video, I'm going to show you how to install Python 3 on your Windows 10 operating system. So let's get started. So first of all, open your favorite browser on your Windows 10 operating system and then search for Python. And the first link which will appear here will be from python.org. So we are going to click on that link. And once this python.org website is open, you just need to scroll down a little until you see this downloads section. And you can see at the time of making this video, Python 3.7.0 is the latest version of Python available. So we are going to click on this link which says Python 3.7.0 and you will be redirected to this page which says Python 3.7.0. And now I'm going to scroll down until I see the files here, and you will see there are various kinds of installer available here. We are going to install the Python using the executable installer. So we are going to choose this option which says Windows x86 -64 executable installer, and now I will wait for this executable to be downloaded. And once this executable is downloaded, you just need to click on this exe file, and I'm going to minimize the browser here. So you can see Python's 3.7.0 setup window has been started, and on the first window you will see two options here. One is install now and other is customize installation. So what we are going to choose is this option which says customize installation, because when you choose this install now option, Python will be installed at this path which I don't want to use. You can see it's a long path which I don't want to remember. So I will use this option which says customize installation, and I will also check this option which says add Python 3.7 to path. So now let's click on customize installation, and next you will see this optional feature window, and you can see there are some optional feature which this Python installer will install. For example, documentation, pip it will install, which is a Python package manager, idle IDE, Python test suite, and other feature it's going to install. So I'm going to leave everything as default, and then I'm going to click next. And now this next window will open which says advanced option. Here I'm going to check this option which says install for all users, and I'm going to leave other check boxes as checked. And then you will see this section here which says customize install location. So I want to install Python on my C directory. So what I'm going to do is I'm going to open the Windows Explorer, and I'm going to go to the C directory here. And once the C directory is open, I'm going to right click here and I'm going to create a new directory, and I'm going to name this directory as Python, and then I'm going to press enter. And this path I'm going to give here in the customize install location. So I'm going to just give this path which says C:/Python and then \Python 3.7. 3.7 here means that we are going to install 3.7 version of Python. So now Python will be installed at this location on my computer, and then I'm going to click on the install button here, and then you will see the installation will start and it will be finished in a few seconds. So just wait for the installation to complete, and after some time I can see this message which says setup was successful. So I'm going to click on this close button which is going to close this installer. So now in order to check whether Python is installed on our Windows operating system or not, we are going to search for Python here, and you will see few options here. One is this Python 3.7 terminal, other is idle IDE. So first of all, we are going to click on this option which says Python 3.7 64-bit, which is going to open this kind of terminal. So this is a Python terminal, and here we can for example print something. So I'm going to just write print, and in the parentheses and in between the double quotes I can just write hello world, and then press enter, which is going to in return print hello world. That means Python 3.7 terminal is working. So I'm going to close this terminal now, and once again I'm going to search for Python here, and this time I'm going to select this option which says idle. Okay, so just select this option which says idle, and in the parenthesis Python 3.7 64-bit. So this idle is an IDE which comes with Python installation. At the time of installation we have chosen this option to install idle. That's why we can see this option here. And also this is an interactive shell, so you can once again write print, and inside the parenthesis you can just write, for example, once again hello world, and then press enter, and it's going to give you this kind of output here. So now Python interactive shell is working and idle IDE is also working. So I'm going to close this idle IDE, and now I want to check whether Python is working using my command prompt or not. So I'm going to right click on this Windows button, and then I'm going to click on command prompt, and here I'm going to first of all write Python and then press enter. And you can see this Python option is working now even on your command prompt, right? So here also you can just write print, and inside the parenthesis you can just print hello world, and then press enter, and it prints hello world in return. So now we have successfully installed Python on our Windows 10 operating system. In this video I'm going to show you how to use mathematical operators and how to do basic math in Python. So first of all, we will open the idle IDE. So just search for Python once again. I have shown you this method in the last video also. So just search for the Python once again. And in the last video, I have shown you how to install Python. And with the Python installation, this idle is also installed, right? So we are going to open this idle IDE. Now some of you who are familiar with Python and have some experience with Python may think that why am I using this Python idle IDE? Because there are many better IDEs and editors available for the development of Python. So don't worry, I'm going to show you everything how to install other IDEs which are preferred in the development of Python step by step. But for now we will start with this idle IDE. So the first thing which I want to do here is I want to increase the font size first of all in the idle IDE, because this may be not visible to some of you. You can change the font size by just changing this number, and I'm going to change it to, for example, 18 and bold. So we will be able to see our fonts in a better way. So now everything is set. So let's get started with the programming. So let's start with the basic math operations. So let's say I want to add something. So I can just write number plus, which is an operator, and the other number, and then press enter, and you will get the result of this expression. Now let's try the subtraction. So let's say I want to subtract 60 minus 50, and then press enter, and it gives the result. Let's do the negative subtraction. So I'm going to just write 60 plus 50 and then press enter, and it's going to return me the negative value. Now let's do the division. So for example, I want to divide 50 by 3. I'm going to press enter, and you can see it gives me a float value or a decimal value. And if you are familiar with other languages like Java or C++, this may appear a little bit strange to you, because when you do the same operation in Java or C++ with this division operator, you will get the different answer, which is 16 and not these decimal float value. So if you want to just get an integer value and not the decimal value out of the division, then you can write this expression, which is 50 /3, okay, and then press enter, and now you get 16, which is a whole number or an integer. This type of division is also called the floor division, in which you get the whole number as the answer and the decimal value is truncated out of your answer. So if you want to get the exact value out of the division in decimal values also, then you can use this expression, which is single forward slash operator. And if you want to do the floor division, then use these two forward slash symbols. Now it's also possible to divide two decimal values. So decimal values in Python and most of the other languages are called the float values. So here instead of 50, I can just write 50.0 divided by 3.0, which is also valid. Or I can write 50.0 divided by 10 and then press enter, which gives me 5.0. And when I write the integer, which is 50 divided by 10, it will also give me this value, which is 5.0. Now let's try some multiplication. So if you want to do multiplication in Python, you use a number and then this asterisk symbol and then second number and then press enter, and this is going to multiply these two numbers. So this is the multiplication operator, which we can use to multiply two numbers. Now this is what we are doing here is, for example, multiplying two numbers or dividing two numbers or addition of two numbers or subtraction of two numbers. In Python it's called expression. Okay, so 50 multiplied by 10 is an expression, and I have already told you that these symbols for multiplication or division are called operators. Now the number on which you are doing these mathematical operations are called operands. So 50 here is an operand, 10 here is an operand, or 3 here is operand, and 50 here is operand. Now here 50 and 10 are also called literals because they are constant values. So what we have learned till now, this is an expression, this is an expression, or 50 divided by 3 is an expression. The number on which you operate on are called operands, and these symbols which you can use to multiply, divide, add or subtract are called operators, and these numbers are also called literals when they are constants. Now let's try some modulo operations. So for example, I'm going to just write 10 modulus 3 here. What it's going to give us is the remainder of the division of these two values. So 3 multiplied by 3 is 9, which leaves the remainder 1, and that's the result we are getting. Okay, let's try it once again. So for example, I will divide 21 divided by 5. It will give me the answer 4.2, but when I do 21 modulo 5 and then press enter, it's going to give me the remainder of the division of two values. Now there is another interesting operator which is called exponent operator, which you can use for the exponent values. So for example, I want to get the result of 2 to the power 5. How can I do it? So I can just write 2 and then double asterisk and then 5, which means 2 to the power 5, and then when I press enter, it's going to give me 32. Or I can just write 10 and then I can just write double asterisk and then for example 10 once again and then press enter. It's going to give me the result of 10 to the power 10. Now it's also possible to do these mathematical operations on more than one number. So for example, I can write 5 plus 5 plus 6 plus 9, and it will give me the result of the addition of these four numbers. And it's also possible to use different type of operator in one expression. So I can write 5 plus 9 minus 6 multiplied by 10, for example, and it's going to give me the result of this expression. Now there is one question which may arise here is, for example, once again I'm going to do 5 plus 9 minus 6 multiplied by 10 and divided by 20 and press enter here. It's going to give me this value, but how this value is calculated? What operation is executed first? Is the multiplication is done first, or is the division done first, or the addition took place first, or the subtraction took place first? So I have this table, and here you can see the precedence of these operators. So in this table, highest precedence is at top and lowest is at bottom. That means parentheses have the highest priority, and then the exponents have the priority, and then the multiplication and division operators have the same priority here, and at last the subtraction and addition have the same priority. But whenever you use these operators which are in the same box in a same expression, then whatever operator you use on the left have the highest priority, and whatever operator you use on the right have the lower priority. So in this table, parentheses have the highest priority and the addition and the subtraction have the lowest priority. And for example, if you use multiplication and division in the same expression, then the priority is decided which operator is appearing on the left. So if the operator is appearing on the left, it has the highest priority than the operator which are on the right side. So let's take an example of that. So for example, so first the addition of these two numbers will happen, and then the division of these two numbers will happen because parentheses have the highest priority. And then the result of these two numbers will be multiplied by 6 because multiplication have the highest priority out of these two operators which are minus and multiply. So multiplication operator have the highest priority. And at the end, the subtraction of the result will take place. So let's press enter and let's see what's the result. So the result here is 11. And how we get this result here? So 5 plus 9 is 14, and the division of these two numbers is 1 by 2. So 6 will be divided by 2, which is 3, and then at last 3 will be subtracted from this result, which is 14, which will give you 11. Once again, for example, you use 60 multiplied by 20 divided by 30 and then press enter, it will give you 40. But in which order this calculation will happen? First of all, this multiplication will take place because in the table we have seen that multiplication operator and division operator have the same priority, and that's why the priority will be decided from left to right. Now if you want to learn the order of precedence between the operators, then you can use this keyword, which is PEMDAS. P stands for parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. Okay, so you can either remember this name, which is PEMDAS, or you can use this sentence which I have written here. So please excuse my dear Aunt Sally, and you need to remember the first letter of each word here. And the first letter of every word, for example, P here stands for parentheses, E here stands for exponent, M and D here stands for multiplication and division, A and S here stands for addition and subtraction. So for remembering, you can either use this sentence or you can remember this keyword. In this video, we will talk about Python variables and types. So first of all, what is a variable? So according to Wikipedia, in computer programming, a variable is a storage location paired with an associated symbolic name, also known as variable name or identifier, which contains some known or unknown quantity of information referred to as value. Now in simple words, a variable is a named place in the memory where a programmer can store data and later retrieve this data using the variable name. Now the programmer gets to choose the name of this variable which is declared, and programmer can change the content of this variable in the later statements. So let's see how we can define a variable in Python. So you can define a variable using any name. For example, you can give my int as a name, and then using an assignment operator, which is this equal to symbol, you can assign some value to this variable, for example 9, and when I press enter, this value 9 is assigned to this variable, which is my int, and now on I can just get the value of this variable using the variable name. So when I write my int and then press enter, it gives me the value which is assigned to this variable. Now, as I told you in the first introduction video of this course, that Python is completely object oriented and it's not statically typed. So you do not need to declare the variables before using them, or you do not need to declare the type of the variable. And further, every variable in Python is an object. So if you have learned some other languages like C, C++, Java, or other statically typed languages, you may have observed that before writing the variable name, they give the type of the variable. For example, in other languages, for defining integer, they have to first define the data type of that variable, and then they define the variable name, and then they assign any value to it. But in Python, you don't need to define this data type here. And whenever you define a variable, you need to assign some value to it so that Python will be able to understand the type of data you want to store in this variable. So this type of notation, when I press enter here, it's going to give me error which says invalid syntax, because this type of variable declaration is not allowed in Python. Now there are some rules which you need to follow in order to declare a variable in Python. And these rules are: a variable must start with a letter or underscore. Okay, so you cannot start the variable name with a number or some unknown symbol. The second rule is a variable must consist of letters, numbers, and underscores and no other special symbol. And the third rule is variables are case sensitive. So let me show you the demo of all the rules which are related to declaration of variables in Python. So let's say we have defined this variable my int. I cannot get the value of my int when I write, for example, my with capital letter and then int here. And it's going to give me an error because variables in Python are case sensitive. So this variable name is different from this variable name. Now, as I told you, you can define a variable starting with the letter. It's totally valid. So let's define this variable. Age is equal to 10, which is valid. You can also define a variable with the combination of letters and numbers, and it's also totally valid. But a variable name cannot start with a number. So when you write something like this and assign some value to it, it's going to give you an error which is a syntax error. So a variable name cannot start with a number. A variable name can start with underscore and it's totally valid. But apart from underscore, when you use some special character, for example, hash age is equal to 10, it's not valid. So whenever you try to get the value of age, it's not going to give you the value which is stored inside this variable. Also, you cannot use any other special symbol between the variable names. So for example, I can write age.22 here is equal to 22, which is not a valid syntax because we have used this dot symbol in between the variable declaration. So these are some of the ground rule in order to declare a variable in Python. Now, apart from that, there are some reserved words in Python which also you cannot use in order to declare a variable. For example, these are some of the words which you cannot use in order to declare a variable. For example, and, del, for, is, raise, you cannot use to declare a variable. So let's say I'm going to go to idle once again and I declare a variable called for is equal to 10. It's not valid. It says it's a invalid syntax because for is a reserved word in Python. So now we have learned some rule about declaring the variables. So let's declare some variables in Python. So first of all, I'm going to declare an integer variable which takes an integer, and then I'm going to declare a float variable which takes a decimal value. And then I can also declare in Python a complex value. For example, my complex is equal to 1j, and then press enter, and it's also totally valid, where j in this value is the imaginary part of this complex number. Now you can also use e to indicate the power of something. So for example, I declare a variable my num, and you can write this notation like this. So 10 to the power 10, it's totally valid. Okay, and when you try to access this value of my num, it's going to give you the value of 10 to the power 10. You can also write the capital E here. So when I write my num is equal to 10, capital E 10, and then press enter, and I try to access the value which is stored in this variable, you can see it gives me the same result. Now in order to declare a string variable, for example my string, I can use double quotations. For example, I want to write some name here. It's totally valid, so I'm going to just get the value which I stored inside this my string variable, and it gives me this name Max. I can also use single quotation in order to assign string to the variable. So I will use now single quotation, and this time I just change the name to Tom. It's also totally valid. So when I write my string once again, it gives me the value Tom. Now you may have noticed one more thing here is reassignment of the variable is possible. So first I have assigned the value Max to this variable my string, and then I have reassigned some other value Tom to the same variable my string. So reassignment is possible. So for example, let's say what I'm going to do is I'm going to take my float variable, and then what I'm going to do is I want to assign in this variable the value which is stored in my int variable. So I'm going to just write my int here and then press enter, and let's see what is the value inside my float now. And you can see it gives us the value 10. But you may ask that we have declared this variable name as my float, so we are expecting the float value inside this my float variable name, but it's giving me the value 10. So in order to convert an integer value into a float value, you can use typecasting. So I can just write my float here is equal to, then you write a keyword float here, and then inside the parentheses you can write the name of the variable which is my int. And then when I access the value of my float here, it's going to give me 10.0, which is a float value. So in order to convert integers into float, you can use this keyword float here. Now if you want to convert a float value into an integer, you can just write, for example, my int is equal to int, and then inside the parentheses you can write the variable name, for example my float here, and then press enter, and then I can see the value which is stored inside this my int variable, and it's an integer. Now let me show you one last thing, which is to find out the type of any variable. So you use a keyword called type, and in the parentheses you use the variable name, for example my int, and then press enter, and it will give me the type of the value which is stored inside this variable. So you can see integer is stored inside this variable my int. Once again, type and then parentheses, and now I want to know the type which is stored in the my float variable, and you can see it will give me float as an answer. So we know that in my float variable, float value is stored. Once again, we will see what value is stored in this my num, which is an exponent value, right? So I'm going to just write type, and then I'm going to just write my num now, and then press enter, and it gives me a float value. And at last, I want to see what type is stored in this my string variable. So I can just write my string here and then press enter, and you can see the value which we get here is str, which stands for string. That means in my string value is stored. Now it's totally possible to use the operators with variables. So I want to add the value stored in my int plus my float here, and this will give me 20 because my int have the value 10 and my float have the value 10.10, so the result is 20.0 here. So this is how you can use variables and types in Python. In this video, we will see how to use print function in order to print output on the console in various different ways. And I'm also going to show you how to take user input using Python. So we have already seen that in Python, we can use this print function in order to print something. And we have already printed hello world at the time of installation, right? And when I press enter, it's going to print hello world on the console. Now, some of you might wonder, what is this print? So print is a inbuilt function in Python. So Python has a number of inbuilt functions, and print is one of them. So here print is a function, and then inside the parenthesis, what you give here is called a parameter or an argument. Okay, so hello world is an argument, which is a string argument, right? So let's try to give in this print an integer argument. Let's say I just provide 25 here, and it will print this number once again. Let's say I'm going to write print, and then I want to execute some expression 50 multiplied by 60, and then press enter. Print function is also able to do this. Now let's say I want to output some more complex formatted string. So let's say I want to print on the console 50 multiplied by 10 is equal to 60. How can I do this? So let's see how we can do it. So I can write print here, and then inside these double quotes, you can write your string, for example, 50 multiplied by 10. And then in print function, you can give multiple arguments using this comma separator. So here I can just write 50 multiplied by 10, and let me put equals symbol here inside this string, and then press enter. And now it prints 50 multiplied by 10 equals 500. And you can also provide more than one argument to this print function. So for example, I can just write hello here, and then in the second argument, I will just provide the space between hello and world. And in the third argument, I will just say world here. And this print function will concatenate all these string values and give you the output in this format. Now let's say you want to also provide this value here, which is 50 and 10. Instead of string, you want to provide some value which you take from a variable. So for example, you declare a variable x is equal to 50 here, and then y is equal to 10. And you want to use these two variables instead of this static string. So how you can achieve this? You can achieve this in various different ways. So let me show you the first way. So I can write print, and then in the double quotes, this is your string. So whenever you use this double quotes, and whenever you write something in between this double quotes, it becomes a string. So after this string, I will provide a dot here and wait for some seconds. And as soon as you do this, you will be able to see various different hints here which are provided. So these are all the inbuilt methods which you can use with the string. So you can use find method, you can use format method. So for now, we are going to use this format method with strings. So you can just click on this format method. So let's say I will provide x as the first argument, y as the second argument, and I want to see the output of x multiplied by y in the third argument. Now, how you can print the value of x, y and the multiplication of x, y using this blank string? So it turns out that you can use these curly brackets inside this string, and you can give some index here. So index starts from 0. So this index is index 0, and then I'm going to provide space and then this asterisk symbol to provide this kind of format. So we want to achieve this format here, right? So just write 0 in the curly bracket, space, asterisk, and once again curly bracket, and this time we are going to provide the index 1, and the result will be transferred to index 2. Why? Because here the index starts from 0, so x will be transferred to the index 0, y will be transferred to the index 1, and the multiplication of x and y will be transferred to index 2 here. So let me press enter here, and you can see it prints the string which we desire. Now once again I'm going to write this print function, and once again I'm going to give this parenthesis, and you can see the hint here. So I want to use this SEP keyword now inside the string. So how can I use this? So I will just close this parenthesis, and once again I want to print hello world. So I will just write hello, and then I'm going to provide the comma, and inside the double quotes I'm going to just write world here, and then in the last argument you can provide this keyword SEP is equal to, and inside the double quotes you can provide some separator to separate the hello from world. So I want to just give this string to separate hello from world, and now I'm going to press enter, and you can see this string is separating the keyword hello from the world. Now in Python you can also use C style string formatting to create a new formatted string. So let me show you how we can do it. So I'm going to declare a variable called name, and I'm going to assign some value to it, for example max here, and then press enter. And now I'm going to just write print function, and in the parenthesis I want to just greet this name, so I can just write double quotes hello here, and then if you are familiar with C style string formatting, then you may know this modulo s symbol which is used to print strings, right? And then after this double quote you just need to provide once again this modulo symbol, and then you need to provide the variable name which you want to replace instead of this modulo s. So in our case we want to replace this modulo s by name variable, and I'm going to press enter, and you can see it prints hello max. Now let's say I also have the age of this person. So the age is, let's say, 22, and once again I'm going to use this print function, and inside the parenthesis I want to say hello to the name including the age. So I can just write hello and then modulo s here, and then I'm going to print the age of this person. I can just write ru modulo d, which is used to print the integer values, and then I'm going to just write years old, and after the double quotes I can just write modulo. And this time I cannot simply provide this name argument like this. I must provide the name in the form of a tuple. And what is a tuple? A tuple is a fixed sized list. And we are going to see in the future videos how to use tuples. But for now, just remember that a tuple is a fixed size list. Okay. So inside these parentheses, once again, I can provide first of all the name, and then as a second value in the tuple I can provide the age variable. And now I'm going to press enter, and now you can see it prints hello max, are you 22 years old. So this is how also you can use these C styled string formatting in Python. I want to give you one more example of float here. So I can just write for example this person's marks. So I'm going to just write marks is equal to, and let's say I want to provide these marks in the floating point, so I can give this modulo f here, and then after this modulo I can just give the marks, so 92.5, and then press enter, and you can see it prints the marks. Now one more little thing which we can do here is we can limit the number of decimal values which we want to see after this point. So we can write the same printf function and same argument, and in order to limit the number of digits after the decimal, you just need to write after f dot and some number, for example 2. Oops, I don't want to see this output. I wanted to see the output after the decimal value. So once again, I think this point should be before f. So I just need to write dot and 2 before f, I think, and then press enter, and now it limits the number of digits after this decimal point. Now the last thing I want to show here is how you can allow the user to provide some input. So for example, I will declare a variable called value, and then I can use equals, and then I'm going to use an inbuilt function which is called input. So input is also an inbuilt function which allows you to take user input. So here I can just write as the first argument, and then I will provide this colon here, and that's it. You just need to press enter here, and now you can see this terminal is asking us the same question which we have written here. So let's say I just provide 50 here and then press enter. Then what's going to happen is this 50 is going to be assigned to this variable which is value. So now when you just use this value variable, you can see this 50 is assigned to this value variable. You will also see that this 50 is a string and not a number, right? Because it's enclosed in single quotes. So how you can assign 50 to this value using the user input? So what we can do here is, once again, I'm going to use this value variable. And what we can do here is we can typecast the output of input. So you can just write int, and then here inside the parenthesis you can just write, and now when I press enter and provide 50 and then press enter and see the value, now it's an integer, right? So you can typecast the output of this input function which provides us the string, and this int method is going to convert this string into an integer and then give us the result. Instead of this int, you can also use a float keyword here. So let me show you this example also. So I'm going to just copy this and paste it here, and instead of using the int, I'm going to just write float here, okay, and then press enter, and I'm going to provide this time 100 here and then press enter, and then I'm going to just print the value of the value variable, and now it prints the answer in floating points. So this is how you can use print function to print the output on the console, and input function to take the input from the user. In this video, we will discuss about built-in functions and modules in Python. So the Python interpreter has a number of built-in functions, modules and type that are always available. That means you can use them at any time, and we have already used some of the built-in functions in Python. So first of all, we have used the print built-in function. We have already used the input built-in function. We have already used the int, which is used to typecast a float or a string into an integer, right? We have already used a built-in function called float, which is used to convert an integer to a float value or a string to a float value. Now Python has a list of these inbuilt functions, and you can find this list by going to the python.org website and then clicking on the docs section, and you can choose the version you have installed. So we have installed the latest version, which is 3.7.0, and you can even choose your language which are available here. Now when you click on this link which says library references, you will be able to see this page which says Python standard library. And then when you scroll down here, you will be able to see the introduction about Python, and the second section here is about built-in functions. So I'm going to click on this built-in function link, and here you will be able to see all the built-in functions in Python. So this is the list of all the built-in functions which you can use in Python. And if you want to know more about these functions, for example, I want to know what this max function does, I can click on this function, and then you can get the help about this function. So what this function does and how it can be used in Python, all the information is given here. Now let's go to the terminal and let's see how we can use some of these built-in functions. So first of all, how you can list out all these built-in functions and types in Python. There is a built-in function to list out all the built-in functions and types, which is dir and then double underscore, and then you write built ins, and then once again double underscore, and then close the parenthesis, and then press enter, and it's going to give you the list of all the built-ins available in Python. So for example, from this list we have already used this function called float, print, and then we have already used this function int and input also. So let's use some more functions. So in the previous videos I have shown you how to calculate the power of a number. So you use these double asterisks in order to calculate the power of any number, and you can see you get the power of 2 to the power 10. Now Python also have a built-in function called POW. Here you can give as a first argument the number, and as the second argument you can provide the number which you want to use as a power, and when I press enter it gives me the same result. Let's use some other built-in function, for example len. Len you can use to find out the length of any string. So I can write len, and inside the parenthesis I can just write any string here, for example hello, and it will give me the length of the string. So this string hello have 5 letters inside it, that's why it's giving me length 5. Now there is a built-in function called help, using which you can get some help about any function. So I can write help here, and inside the parenthesis I can just write the function name. So for example, I want to know what this max function does, so I can just write max here and then press enter. So it gives me the signature of max, so how it's used, and then it will provide me some description about the function, so what it does. So you can see here it returns the biggest item, right? So I can just write max here, and inside the parenthesis I can give the list of items here, for example 1, 2, 8, 9, 4 and 5, and when I press enter it's going to give me the maximum value out of this list. So you can use this help built-in function in order to know more about all the other built-in functions. Now till now we have talked about the built-in functions which are available in Python. Now let's talk about some of the built-in modules which are available in Python. Now what is a module I'm going to describe in the later videos, but for now let's see how to import a built-in module in Python and how to use them. So there is a built-in module called math, and to import it you just use a keyword called import and then the module name, for example math, and press enter, and it's going to import this module into our interpreter. Now you can use this math keyword and then you can write dot and wait for some seconds, and you can see it gives me all the list which are available inside this math module. So let's say I want to find out the square root of any number. I can use a function called sqrt here, and then this gives me the square root of a number. So for example, I want to find out the square root of 100 and then press enter. It gives me the answer 10. Now once again, as I said, you can use a built-in function called help in order to know the signature of this function. So I can just write math.sqrt and then press enter, and it's going to give me some help about this function. So you can see it returns the square root of x, and the signature looks like this. Now if you want to print all the methods and types available inside this built-in module, you can once again use this built-in function dir, and then in the parentheses write the name of the module. So this time we will write math here and then press enter, and it gives me the list of all the available functions available inside this math module. And you can see all these functions which are available inside this module. So you can just use a cos function from here, pi function from here, radians or tan function from here. So this is how you can use built-in functions and modules in Python. In this video, I'm going to show you how you can write your first Python script in the form of .py file and execute it. But not just by idle, but I'm going to show you various different ways you can execute this Python file which you will create. So let's get started. So first of all, I'm going to show you how you can create your Python file using idle. So first of all, open your idle IDE and just go to file here, and you will be able to see this option here which says new file, and then you will be able to see this kind of window opens, which is a Python file editor. Now first of all, we are going to save this file. So let's save this file. You can save this file at any directory or any path wherever you want. So for this first file, I'm going to name it as hello.py. So .py is the Python extension and hello is the name of our file. So I'm going to save this file first of all, and you can see it's saved at my desired location. So in this file, let's write some Python code. So let's say I want to create a program in which I will ask the user to input 3 numbers, and as the output I want the maximum out of these 3 numbers which is inputted by the user. So how can I do this? So as we have already seen, you can define a variable in Python like this. So I'm going to define a variable x is equal to, and we also know that there is an inbuilt function in Python called input to take the user input, and then in the double quotes, so we are going to ask the user that he needs to enter the first number. So enter first number, and in a similar way I am going to ask the user to enter the second number and the third number. Let me change the variable name here. So instead of x, this variable will be y, and the last variable will be z, and this is the third number and this is the second number. But when I write the input like this may give us some problem. The problem is input function gives us a string, and we need to convert this string into a integer or a float. So let's convert this number into a float value. So you can use another inbuilt function which is float, and then this string will be converted to float. So I'm going to do the same for other 2 numbers. Now in order to get the maximum numbers out of these 3 numbers, we have seen there is an inbuilt function in Python which is called max, and we are going to use this max function. But first of all, we need to print something. So we will just write the max value is, and then we can calculate the maximum value and print it from here. So we can use this comma, and then we can use this inbuilt function which is max, and then we will just pass these 3 values which is x, y and z. So will this program work? Let's see. So first of all, before doing anything, you need to once again save this file. Okay, so right now you can see there is a little asterisk symbol here in front of my file, which means my file is not saved. So you need to first of all save your file, and then you will see this asterisk is gone. That means our file is saved. So let's run our code. So if you want to run this Python file using your idle IDE, you just need to click on the run button here, and then choose the third option which says run module. So I'm going to click on run module, and after some time you will be able to see this output printed on the idle IDE. So it says enter the first number which we have written in our code. You can see this line is executed first of all. So we will enter some number. I'm going to just write 50 here and then press enter. And then it asks us to provide the second number. So let's say this number is 90 and now we need to give the third number. So I'm going to just give 101 here and then press enter. And it says the max value is 101, which is correct. But in real world, you will not have this idle IDE installed everywhere. So how can I run my hello.py file? So I'm going to minimize this idle IDE for now. And I'm going to go to the location where I have saved this hello.py file. Okay. So just go to the location where you have saved your hello.py file. And now you just need to double click on this hello.py file. So I'm going to just double click on this hello.py file. And you can see as soon as I double click on hello.py, it opens this program in our terminal. Okay. So once again, I'm going to close this terminal. And I'm going to double click on my hello.py file and it opens our program in our terminal. So once again, I'm going to give three inputs here. Let's say 110, enter, 55, enter, 200 and enter. As soon as you press enter, this window disappears. So why this window disappears? Because after the execution of your program, this terminal immediately closes. So we need to provide something in our program in order to avoid the closing of this terminal. And how we can do this? We can do this using our input method, which is our inbuilt method, right? And here we can just type press any key to exit. So what will happen here is after printing the result, your terminal will wait for the user input, and once the input is given by the user, then only the terminal will exit. So let's test our program once again, but before this, don't forget to save this program. So I'm going to just save my program and then I'm going to open the folder where I have saved this hello.py file. And once again, I'm going to double click on this hello.py and I'm going to give three numbers here. And then I'm going to press enter and it prints 99, which is the maximum out of three numbers. And at last, it asks us to press any key. So I'm going to press any key, for example, Z, and then press enter. And this terminal disappears. So now the question is, how does this Python file is executed without compiling this file? So the answer of this question I have already given in the introduction video. And the answer is Python is an interpreted language and not the compiled language. So what happens in normal languages like Java, C++, C, you have a source code, and this source code you need to compile in order to convert this source code into an executable file. For example, you have a hello.java file. You need to compile this Java file in order to convert it into a hello.class file, which is an executable file. And when you run this hello.class file, hello world or whatever program you have written will be executed. Now in the case of Python, because it's an interpreted file, you just need to create this hello.py file and you just need to run it. You don't need to compile this file. And that is the difference between interpreted languages like Python and the compiled language like Java, C++ or C. Now there is one more way using which you can run your Python file, and that is by using your command prompt. So I'm going to open my command prompt. I'm going to right click on this Windows icon and then I'm going to open this command prompt from here. So make sure that this command prompt is able to understand this Python command. So first of all, type Python on your command prompt and then press enter, and if it shows you this output like Python and the version of Python, then Python is working on your command prompt. So this command prompt is Windows command prompt and not the Python shell which we have installed. So this is our Windows command prompt, right? Now let me make this terminal little bit bigger so we will be able to see what I'm typing. So I'm going to change the font size to, let's say, 24 here. So now we will be able to see what's happening. You can just write quit and then these two parentheses and then press enter, and you will come out of this command prompt. So you need to come out of your command prompt in order to execute your Python file. Now in here, what you need to do is you need to copy the path of your Python file. So I'm going to right click here and then go to the properties, and then in the securities, I'm going to just copy full path of this Python file up to .python. Okay, so I have copied full path of this Python file, and now what I need to do is I need to just write Python here. Okay, so just write Python and then paste the path which you have copied. So I'm going to just paste the path which I have copied and then press enter, and you can see our program is executed. So I'm going to just give quickly 3 numbers, and it gives us the maximum of these 3 numbers. Now I will just type any letter here and then press enter, and I will come out of this terminal. There is one more way of executing your file, and this is you need to just give this command, which is cd, and then your directory path. So up to your directory, you just need to copy this path from here. Okay, so you just need to copy this path, and then after cd you just need to give space and then paste this path without your hello.py file. Okay, so I haven't given the hello.py file name here, and now press enter, which will change your directory to your Python directory. So now we are inside our Python directory. From here you can directly give Python and the name of your file, which is hello.py, and then press enter, and once again the program opens. So we can just give 3 inputs here and the result is shown. Once again I'm going to just type any key or any letter here, with for example R, and then press enter, and now I'm out of this program. So this is how you can run your Python script on any terminal. You don't need any IDE or any other special software in order to run your Python script. You can run it on your terminal or directly click on the Python file. Till now we have been using idle IDE in order to develop our Python code. Now the reason behind why I was showing to code in Python using idle in the first few videos, because I wanted that you get familiar first with Python interpreter. So now whenever you want to test some functionality in Python, you don't need to open any IDE or any editor. You can just open your terminal and then test that functionality. Until you wanted to test something, terminal or Python interpreter was okay. But when you want to develop a big project using Python, we need to use some kind of IDE. IDE stands for Integrated Development Environment, in order to develop such kind of projects. So in this video, I'm going to show you how to install PyCharm on your Windows 10 operating system, which is the most popular IDE today used by developers to develop Python code. So let's get started and let's see how we can install PyCharm on our Windows 10 operating system. So open your favorite browser and search for PyCharm, and the first link which will appear here will be from jetbrains.com/PyCharm. So JetBrains is the company behind this IDE, and this company, which is JetBrains, is famous for making very good IDEs. So JetBrains has also created some other IDEs like Android Studio, IntelliJ IDEA, WebStorm, and many other IDEs which are popular between developers nowadays. So we are going to just click on this link. So now we are inside this jetbrains.com website, and here you will be able to see this logo PyCharm, and you will be able to see this download button here. So I'm going to click on this button which says download now, and then you will be redirected to this page which is for downloading PyCharm. So here you can select your platform, whether you are working on Windows or Mac or Linux. And what we want to download is we want to download the community version of PyCharm. This community version you can see is free and open source, so you can download and install it with no cost. If you want to download the professional version, then you need to pay some money to JetBrains in order to use it. And as soon as you click on download button, this download of PyCharm community version .exe file will start. So I will wait for this file to be downloaded. So now this exe file is downloaded on my Windows operating system. So I'm going to double click on this exe file, and I'm going to minimize the browser. And now you can see PyCharm setup wizard has been started. So here you just need to click next. And this is the location where PyCharm will be installed on your system. So it will be installed inside your C directory, then program files, JetBrains, and then there will be a directory created which will be called PyCharm Community Edition, whatever version you have downloaded. So I'm going to click next. Now on this next window, you will see two options. One is to create a shortcut. So we are going to choose this option which says 64-bit launcher. Now the second option here is create associations. And I'm not going to check this checkbox because I don't want that on my computer every .py file to be associated with the PyCharm. So I will leave this unchecked. And the next option here is download and install the JRE x86 by JetBrains. There is no harm in this. So I'm going to check this checkbox and I'm going to click next. And now I'm going to click on the install button. So this is going to start installing PyCharm on my Windows 10 operating system. So I need to wait for some time until this installation is finished. So now the installation of PyCharm Community Edition is finished on my Windows 10 operating system. And you can also see there is a PyCharm shortcut which is created on my desktop. Now I will check this checkbox which will start the PyCharm IDE, and I'm going to click finish, which is going to launch the PyCharm IDE. Now for the first time when PyCharm starts, it will ask you this question, whether you want to import any settings from the previous installation of PyCharm. We don't have any previously installed PyCharm, so we are going to just leave this as default, which says do not import setting, and then click OK. And then you will see this license terms and conditions window. If you agree with all these license terms and conditions, then just click accept. And one more window appears here, which is for data sharing. So I'm going to just say don't send. And now you can see PyCharm IDE has been launched. So for the first time, it will ask you which UI theme you want to use. You want to use the Darkula, which is the dark theme, or the IntelliJ theme, which is the light theme. So I'm going to choose this light theme, which is IntelliJ theme, and then I'm going to just click on next. And on this next window, you will see some featured plugin. So for now, I'm not going to install any of the plugin. I'm going to just say start using PyCharm, which is going to start the PyCharm. So now PyCharm IDE has been started. So let's create a new project here. So I'm going to click on new project, and now we need to give the title of this project, and PyCharm will ask you where you want to save this project. So I'm going to just give the name to my project. So let's name our project as Hello World, and then I'm going to just click on create button, which is going to create our Python project. So now you can see PyCharm IDE has been started. So you can see the first thing you will see here is tip of the day. I'm going to just close this tip of the day, and I'm going to maximize my IDE window, and you can see our project is shown on the left hand side. So let's create a Python file, and we are going to just run some code using this Python file. So we need to just right click on our project and then click on new and then choose Python file from here. And now we just need to give the name to our Python file, for example, hello, without any extension. So you don't need to provide any extension when you choose this option which says Python file, and now click OK. And now you can see on the left hand side that this file is created, which is hello.py. This .py extension is added by PyCharm for us. And now on this editor, for example, let's print hello world once again. So I'm going to just print the hello world. You already know how to print hello world, right? And once you have written your code, you just need to save your code by pressing Ctrl S. And now you can just right click on your file and choose this option which says run hello. So I'm going to just click on this option which says run hello, and you can see this output is printed on this run window. So this is how you can install PyCharm on your Windows 10 operating system. In this video, we will talk about using strings in Python. But before that, I want to show you something, and that is how to comment your code in Python or how to write a comment in Python. So for example, I have this line of code which is used to print hello world on terminal. Now for some reason I don't want to execute this line of code, then I can convert this statement into a comment. And how do I do this? You can just add an asterisk in front of your code, and this makes your statement a comment. A comment means that now this line of code will not be executed by Python. So let's run our code and let's see what happens. So you can see now it doesn't print hello world because now this is a comment. Now generally we use comments in order to provide some information about some functionality or what we'd want to do with our code. So let me remove this line, and because it's a Python strings video, we can just write after this hash symbol Python strings, right? And this means that this is a comment and this line will not be executed by the Python interpreter. Now there is one more way of giving a comment in Python, which is by writing the double quotes 3 times, and this is also a comment. So when you write, for example, Python strings, this is also a comment. So this will also not be executed by Python interpreter. So what is the difference between this hash comment and the comment with these 3 double quotes? So it turns out that using these double quotes, you can write multiple line comments. So for example, I want to write a multiple line comment. Let's say I want to write Python string tutorial. I can write this multiple line comment using these triple double quotes. So let's get started and let's see how we can use strings in Python. So I'm going to declare a variable, and in this variable I'm going to assign hello world here, right? And to print this hello world, we can just write print, and inside the parentheses we can use this x variable, and when we run the code, it runs. So we already know how to use this kind of string in Python. The second way of creating a string is you can use the single quotes instead of double quotes, and this is also a valid string. So this will also work. So let me just print this also, which is hello world using single quotes, and when I am going to run this, it's going to give me the result. Let me remove the spaces between the print and these parentheses. So let's say you want to add a single quote into this hello world string. So let's say I want to just write hello single quote s hello's world. So this is totally possible in Python. So whenever you surround your string using double quotes, you can just add this single quote without any problem. But when you do the same with this string, this will give you a problem, because now Python thinks that your string starts from here and ends at this place just after hello. And this will be seen as some kind of garbage by Python. So in order to use these single quotes inside the string which uses single quote, you use a escape character. And the escape character in Python is backslash. Okay, so when you add a backslash in front of a character, Python interpreter knows that it's a escape character, so this will be treated as a valid string. So let me just print the result, and you can see it prints the same result now. Now let's say I want to use a double quote in this string which uses double quote already. So I'm going to just give a double quote here, and the same problem arises which we have seen in the string with single quote. So to escape this, you can also use backslash and the problem will be gone. And let's run the program, and it gives us this hello world with double quote. So you can print this double quote using this escape character which is backslash. Now let's say you want to print a string with a backslash itself. So I can add a backslash here, and I want to add a backslash here, and let's save the code and let's run it, and let's see if it runs or not. So it turns out that you can use this kind of notation in Python. Also, when you use double backslashes here and here, let's see what happens. So when we run the code, it will give us the same result, because one backslash is a escape character and other backslash is the part of the string. So it will print the same result. So you can use this for escaping this character, or you can remove this. The result will be same. So now let me edit these two strings, and I'm going to use hello here with the capital H, and I'm also going to assign hello to the y variable with a small h here. Now Python provides us some inbuilt functions which you can use with strings. So this is a string, right? So you can use some methods related to strings on the x and y variable. So let's see what are these methods. So after the x, I can just press dot, and you can see so many suggestions is given to us by PyCharm, and this is called IntelliSense, which is provided by PyCharm to us. And IntelliSense means that whenever you type something, PyCharm will try to suggest you some supporting code for whatever you are typing. So let's use some method which are suggested to us. So I'm going to use this capitalize method. So let's use this capitalize method with the x and y variable, and let's see what happens. So I'm going to run the code, and you can see now the upper string is printed same, but the lower string is printed with a capital H in front of it. So this capitalize method capitalizes the first letter of the string. Now let's see what are some of the other method which we can use. So there is a method called upper, and also there is a method called dot lower. So let me just rewrite this hello in all capitals, and let's run the code now. And you can see in the result, the upper method has converted our string into all upper letters, and the lower method has converted our string into all lower letters. Now in Python, everything is an object. So using these square bracket, you can extract each and every letter based upon their index. So for example, I write index 0 here, and in the y, I'm going to use the same square bracket, and I'm going to write 1 here, which is the index 1, and let me run the code, and it prints the first character of the string because it's at index 0, and here you can see the second character of the string which is at index 1. So always remember, indexes starts from 0, not from 1. Now in Python, you can also get the substring out of a string. So here inside these square brackets, I can just write that I want a substring out of this complete string first three letters of this string. So I can just start from 0 and I can just say I just want to stop at 3. That means we will get, I think, the first three characters of the string. Also, let me add some spaces into the second string here. And in Python, there is a method called strip. So I'm going to just use this strip method. And let's run the code first of all, and let's see what happens. So you can see, first of all, this print has printed first three letters of this string. So you can see this notation means that we are telling Python to give a substring starting from 0 until 2, until the index 2. Okay, and we are saying that we want to stop at index 2. That's why we write 3 here. Now if you want to just print HELL, we can write here 0 to 4, and then we can run the code, and then we get HELL. If you want to get only ELL, you can write 1 to 4 here, and then it will give you ELL out of this string. And this is how you can strip your string. So strip means the spaces from the start and end will be stripped of this string. Now let me show some other method related to the strings. So first method I want to show here is, there is a method called isLower, and then there is a method called isUpper, and then there is a method called dot replace, which is used to replace some character inside the string. So let's say I want to replace capital H by, let's say, J. And the last method I want to show is how to split the string, but that we will see in a moment. So let's run this code, and the first result says false because this string is not lower. When we write all letters in lowercase, then only it will give us true. Otherwise, this method isLower will give us false. Now let's rerun the code, and now it gives us true because now every letter in this string is lower. Second method gave us true because we were checking whether every letter in this string is capital or not. The next method replace is used to replace the character if it's there in your string, and replace it with this character if this character is found in your string. So this capital H is not present in our string, right? So let's just add this capital H into our string, and let's see what's the result. So now the capital H is replaced by capital J here in the result. The next method which you can use with the string is a split method. So you can write y dot split, and this is used to split your string using any character. So I'm going to once again write hello comma world here, and I want to split this string using this character which is comma. So I can just write using single quote these comma, and once I run the code, you can see it gives us an array of two members. One is hello and other is world with a space, right? Because we have splitted our string using this character, that's why the space is here, right? So that's why you can see this space here also in the second element of this array. So there are number of methods which are associated with string which you can use, and for knowing all these methods you just need to write your variable which contains a string, and then just write dot, and you will be able to see the suggestions which you can use with the strings. So you can use the title method, for example, or you can use the translate method, or you can use all these methods which are available here. Okay, so just see all these suggestions and see what you can use from these methods. Also, if you don't have any variable in which you have assigned your string, you can directly take your string, for example hello, and then you can just write dot after this hello, and once again you will see all these suggestions because this hello is also a string. Let me show you one last thing which you can use with string very quickly. So you can write print here, and then if you want to print this hello, for example, 10 times, how will you do this? So you can just write, for example, x, comma, x, comma, x. This is how you can do this. Let's say you want to print this hello 100 times. How you can do this? So there is a trick in Python which you can use, and this is using these asterisks. You can print the string multiple times. So for example, I want to print this hello 10 times. I can just write my string variable name asterisk the number of time I want to iterate this string. So let me run the code, and you can see now this hello is printed 10 times. Let me provide the space here, so there will be a space between the two hellos, right? Let's say I want to print hello 100 times, then I can just write 100 here and then run the code, and it will print this hello 100 times on the terminal. So this is how you can use strings in Python. In this video, we will talk about the Boolean values, comparison operators, and the logical operators in Python. So first of all, what is a Boolean value? So in Python, Boolean values are two constant objects which are true and false. Now for this demonstration, I will be using a Python interpreter, and in PyCharm, you can open the Python interpreter by going down at the bottom, and you will be able to see this option which says Python console. So just click on this Python console option, which is going to open the Python console, and you can move this bar up and down in order to expand your console, right? So let me just clear this console. So we will start from the top. So in order to clear this console, you can right click and then just say clear all, and it's going to clear the console. And let me resize this console up to the top, and let me just minimize this section also. So as I said, Boolean in Python are two constant objects which are true and false. So how you write true and false in Python? You write true with a capital T and press enter. This is a true value. And false you write with a capital false. This is a false value. Now if you write true with small t, this is not recognized by Python. Also when you write false with small f, this is also not recognized by Python. Now generally we use Boolean values in order to find out the result of some condition. Now let's say you have two numbers and you want to find out which number is greater out of these two numbers. You can use a comparison operator to compare these two numbers, and the result will be shown as a Boolean value. Now the next question arises, what is a comparison operator? So in Python, these are some of the comparison operators you can use. So you can use this double equals to check the equality between two values. You have this not equal operator with this exclamation mark and equals, which you can use to check the non-equality between two values. There is a greater than operator and there is a less than operator, and also there is a greater than equals operator and the less than equals operator. Now examples of each of these operators I have given here. So how to use these operators? As I said, if you have two values, let's say two integers x and y, to compare these two integers whether they are equal or not, you write on the left hand side first variable and on the left hand side second variable, and in between you use the comparison operator. It can be a equal to operator or non-equality operator, or greater than or less than, or greater than equals or less than equals operator. So let's see how we can use these operators in real Python environment. So let's say I want to check whether 10 is greater than 9 or not, and when I press enter, it's going to give me true because 10 is greater than 9. Now once again, let's check if 10 is less than 9 or not, and it will give me a false value, which is also a Boolean result. Also, we can check equality between two values. So we can just write 100 is equal to 100 or not, and it will give us true. Once again, we can check if 100 is equal to 99, it will give us false. In the same way, you can also check for the non-equality. So for non-equality, you use this exclamation mark equals and then press enter. It will say true because 100 is not equal to 99. The same operation you can also perform with some variable. So let's say I have a variable called x whose value is 20, and I have a variable called y and I assign 30 to it. And let's say I want to check whether the value in the x is greater than or equal to the value which is there in y, then I can write this kind of a statement, and when I press enter, it's going to give me false because 30 is not greater than or equal to x. So let's assign a value which is 30 into our variable x. And now let's check whether x is less than or equal to y or not. And when I press enter, it's going to give me true because we know that x, which is 30, is not less than y, but it's equal to y, and this condition is true. Now you can also compare two strings using these operators. So let's say I have a string called hello, and I want to check whether the hello value is equal to some other value, for example hello in double quotes or not, and it will return me true. That means whether you write hello in single quote or hello in double quote, both these values are same in Python. Now also, we have seen in the last video where we have seen how to use strings, that whenever, for example, I write a string, I can use this dot operator in order to call some functions related to strings. So some of these functions returns a Boolean value. So for example, we can check whether this hello, all letters are in uppercase or not, and once I press enter, it says false. Or I can check whether in this hello all letters are in lowercase or not. This will give me true. Or I can test whether in this hello string all letters are alphabets or not. This is going to give me true because all letters are alphabets. Now if I check whether in this string whether there is a alphanumeric value or not, I can use this method which says is al_num, and this will check whether in my string there is a alphanumeric value or not. Now the next question you may ask is, for example, I want to evaluate two conditions at the same time. Let's say I want to evaluate whether 10 is greater than 9, and I want to evaluate whether 20 is less than 15 or not. So how can I evaluate these two conditions at the same time? So for those type of comparison, we use the logical operators, and there are three logical operators which we can use in Python: an AND operator, an OR operator, and a NOT operator. So this AND operator you can use to evaluate two conditions, and it will return true only if both conditions are true. Okay, so let's say you have two conditions, X condition and Y condition. Then if you use this AND operator, then in order to get true out of these two conditions, both conditions have to be true. In the case of OR, it will return true if one of these conditions is true. So whether X is true or Y is true, it doesn't matter, but if only one condition is true, this will give us true value. And the NOT operator will return the opposite of what we have. So if some condition returns us true, Then when we use not operator, then not operator will make this false. So let's try all these three operators in Python. So I said I can use an AND operator to check whether this value is true as well as this value is true or not. So when I press enter, it returns us false, because even though the first condition is true, which is 10 is greater than 9, but the second condition is not true, right? So in case of AND, both conditions should be true in order to get the true result. Once again, when I use the same conditions and instead of AND, I use the OR operator, it will return me true, because one of these conditions is true, which is 10 is greater than 9, even though the other condition is false. Now let's say we make both conditions true and we use OR, and when we press enter, it's going to still returns us true. So the minimum requirement of OR is there should be at least one condition which evaluates to true. Now let's see how we can use the NOT operator. So I can write NOT, and then I can check whether 10 is greater than 9 or not. And when I press enter, it returns us false, because we know that 10 is greater than 9 and not makes it false. So it returns us false. Once again, if we check whether 10 is less than 9 or not, it's going to return us true, because 10 is not less than 9, and this condition will return false, and not will make it opposite, which is true. So in this way, you can use Boolean values, comparison operators, and logical operators in Python. In this video, we will learn how to use if-else statements in Python. So first of all, what is a if statement? So a if statement is used to execute a statement or a block of code if and only if a condition is fulfilled. So first of all, let's see the syntax of if statement. So let's say I declare a variable called x whose value is 100, and then I'm going to check whether the value in x is equal to 100 or not. So I can use this keyword if, and then if you have seen the last video in which I have shown you how to use comparison operators and logical operators, then you will know that for equality we use a double equal symbol, and then I'm going to just check it against 100. Now after the condition, you need to give this colon in order to tell Python that this condition is finished, and you need to press enter, and you will see that there is an indent given to our code. And you can see this cursor is here, which is 4 spaces away from the start, or 1 tab away from the start. And here I can just, for example, print the value of x. So I can just say x is equal to, and then after the comma, x. And let me save this code and run this code, and you can see on the run window here x is equal to 100 is printed, because this condition which we are checking using the if statement is true, which means whatever code or statement or block of code you will write under if, it will be printed. Let's say this condition is not fulfilled. So I'm going to just say that x is not equal to 100, which is a false condition. And when I run the code, now it doesn't print anything, because this condition is not fulfilled, and that's why this statement is not executed. Now let's talk about the indentation a little bit. So indentation in Python is the way of marking a block of code. So you can see I have given 4 spaces indentation here. So 1, 2, 3, 4. Or if you are using PyCharm, when you press enter after an if condition, you will see that automatically this cursor is pointing here, which is 4 spaces away from the starting point. So this means that whatever you write after these 4 spaces or a tab is the part of this if statement. Now, if you are familiar with C or C++, this indent acts like a curly bracket in C or C++. So in Python, you don't use the curly bracket to define a block of code. You use indentation to define a block of code. So I can write this statement like this also. So I'm going to just say x is equal to, and in the next line, I can just give one more print function, and I will print x from the next line. And you can see here also I have given indentation after this starting point. And this means that these 2 lines are the part of this if statement. So let me change the value of x is equal to 99, and when I run the code, it will print x is equal to, and in the next line it prints 99 using this line of code. So you may ask what happens when I will write this print function here, and let's say we want to print finish here. Okay, and let me run the code and let's see what happens. So it prints finish. Now let me just change this condition, and I'm going to just say 100 here, and let's see what happens now. So now only finish is printed because this line of code is not the part of if condition. Only statement which you write after 4 spaces will be the part of the if condition, like this line and this line of code. But if you don't give any indentation here, that means that this line of code is not the part of the if statement. Now let's take another scenario, and this time I want to check whether the value of x is a positive value or a negative value. So I will start from here, and I will give one more if statement here, and I will just check whether x is greater than 0 or not, and then give this colon to indicate Python that I have finished this condition. And then if it's greater than 0, then I'm going to print that x is positive. Now if x is not positive, and if it has a negative value, I need to somehow print that x is a negative value. And for this you use a else statement. So here you can write else, and once again you need to give the colon here, and then under this else statement, once again you provide 4 spaces or a tab indent, and you can once again write print, and this time we can write x is negative. This means whenever this condition is false, and if and only if this condition is false, then only the else part will be executed. So whatever code or block of code you write under else, that will be executed if and only if the condition here is false. So seeing the value of x, which is 100, which is obviously greater than 0, it's going to print that x is a positive value. Now when I change the value of x is equal to minus 100 here, and once again I execute the code, first of all it prints that x is minus 100 here, because first of all this condition is checked, and obviously minus 100 is not equal to 100. So this condition is true. So these 2 lines of code are executed because this condition is true. And here, because this condition is false, that's why this statement is not printed, and the execution of code goes to the else condition, and then this line of code will be executed, which is x is negative, and you can see here. And this line of code is independent of both these if statements, and that's why it will be printed always. Now as we have seen from our last video, that we can provide multiple conditions using a logical operators. So we can here also write that if x is not equal to 100, or if the value of x is less than 0, let's write here x is less than 0, then only we want to print this statement. So once again when we run the code, in this case both the conditions are true, That's why this is printed. If we write here that x should be greater than 0, then also this will be executed because one of the condition is true, and because in the case of OR we only need to satisfy one condition out of multiple conditions. In the case of AND, when I write AND here and run the code now, you can see this is not executed because one condition is true here and other is false. And in the case of AND, we need to satisfy both the conditions, and then only these two statements will be executed, or this block of code will be executed. So this is how you can use if else statements in Python. Now in this video, I'm going to show you how to use elif statement with if else statements and how to use nested if statements in Python. So let's get started. So what I'm going to do is I'm going to declare a variable and I'm going to ask the user to enter some name. So I'm going to just write enter a name here, and when the user enters this name, I want to compare this name with some predefined names. So in the last video we have already seen how to use if statement, so I can just write name is equal to, and I can compare it with some name. So let's compare it with a name called Max here, and I will give this colon here, and once the name matches this name, I'm going to print the name. So I'm going to just write name entered is and whatever the name provided by the user. So I will just use this name variable here. This we have already seen in the last video. Now in Python you can also use elif statement, and the signature of elif statement is you can just write elif here, and then you can provide some other condition which returns Boolean. So I can once again here write if the name matches some other name, for example Leo, and once again I'm going to just print a name entered by the user. And this elif condition I can use any number of time after the if. Let me match this name to some other different names, for example Roy, and the last name will be Ali. So if the name matches Max, this statement will be executed. If the name matches Leo, this statement will be executed. If the name matches Roy, this statement will be executed, and if the name matches Ali, this statement will be executed. Now if the name entered by the user does not matches any of these names, then we can use a else statement. So we can just write else here, and we can just print a message here. So the name entered is invalid. So this message will be printed when the name entered by the user does not match any of the name I am checking here. So let's run the code and let's see what happens. So now my code is running, and I'm going to give the name Max here, for example, and then press enter, and it prints this message which says the name entered is Max using this statement. Now once again when I run the program and this name matches, let's say some other name Ali, and then when I press enter, it prints the name entered is Ali, which means this statement is executed. And let me run the program once again, and when I give some random string here, it prints the name entered is invalid. Now let's say the name entered by the user is Max and this condition evaluates to true, then this statement will be executed, and the other conditions which we have given using elif statement will not be evaluated. So let's say we will write Max here also. So this condition and this condition is same, right? Checking for the same name, and when I run the program and when I write Max here, only one statement is printed, which is this one. So we can see when this condition returns true, only one statement is executed and none of the other conditions are even evaluated. Now the important thing to note here is you cannot start with a elif statement. You need to start with the if statement. So you need to write a if statement and check the condition first, and then only you will be able to write elif condition. Now it's possible to use multiple if condition, and then this elif will become the part of this if condition, and this will be the separate if condition. So when I run the code once again, and when I write max here, it's going to print two statements. One is using this and other is using this, because this if condition and this if condition are two different if conditions. And once you use elif, so I'm going to use elif here, then this elif is the part of this if condition. So this is how you can use if statement with elif statement and else statement. Now let's see how to use the nested if statement. So I'm going to declare a variable called x, and the value I will assign to x is 10, and then I'm going to write an if condition, and here I'm going to just evaluate whether x is less than 0, and when x is less than 0 I'm going to just print that x is negative. Else, if the value is not less than 0, so I'm going to just write else, then I'm going to just print x is positive. Now let's say I also want to evaluate if the x value is an even number or an odd number if the x value is positive. So under the else, I can once again write if, and then we can just evaluate this condition, that if x modulo 2 is equal to 0, which means that when x modulo 2 returns a 0, that means it's a even number. So we can print x is even. Otherwise, in the else condition, I can just write else x is odd. So in this if condition, I'm checking if the value of x is less than 0 or not. And if this condition is not satisfied, then I'm checking whether x is a even number or x is an odd number. So if you remember, indentation here is very important. So this if condition falls under the else condition, right? So this if condition and this else is the part of the else statement. So because we have provided this 4-space indent here, whatever code you write with this indent is a block of code. And what we are essentially doing here is we are nesting one if else condition inside the other if else condition. You can also reverse this condition checking, and you can also say if x is greater than or equal to 0, then the value of x is positive, otherwise the value of x is negative. And this statement you can write under the if condition also, and this is also a nested if else statement. And let me run this program, and you can see x is a positive value because x is equal to 10, and x is a even value. So once this condition is true, this statement will be printed, and whatever if condition is there inside the parent if statement, that will also be executed. And this condition is checked first of all, and obviously this condition is true in this case when x is equal to 10, because when you do x modulo 2, it's going to give us the remainder 0, and that's why x is a even value, and that's why it's printing x is even here. So it's totally possible to use one if else statement inside the other if else statement, and this type of if else statement are called nested if else statement. In this video, I'm going to show you how to use lists in Python. So first of all, what are lists? So list in Python is a kind of collection which allows us to put many values in a single variable. You can also say that list is an ordered set of values. So let's define a list. So I'm going to just say x is equal to, and you can define a list inside these square brackets, and inside the list you provide some values. So for example, I'm going to provide the values 3, 5, 4, 9, 7, 10. So this is how you can create a list in Python, and when I press enter, it's going to create a list, and when I just use x to get the list, it's going to provide me all the values in the list. Now these values which are inside the list are called elements. So 3 is an element, or 5 is an element, or all these values in this list are all called elements. And all these elements are ordered by their index. Now index, as I already said in the previous videos also, always starts from 0. So we can fetch the value which is at index 0 using this square bracket once again with the variable name, and then when I write index 0, it's going to give me the element which is saved at index 0. So looking at this list, 3 is at index 0, 5 is at index 1, 4 is at index 2, and so on. So let's say I want to get the value which is at index 4, 0, 1, 2, 3, 4. So I'm going to just write x square bracket 4, and it is going to give me 7, which is saved at index 4. Now it's not necessary that list must contain all the same data type elements. So for example, I can also declare a variable called y, and in this I can save some name, for example max. I can save integer, let's say 1. I can save a decimal value, let's say 15.5. I can save other list inside this list using these square brackets, for example 3, 2. So one list can contain different type of data types with any number of elements. So when I press enter, and this time I want to get the value which is at index 0, it's going to give me max. And once I want to get the value which is saved at index 3, then it's going to give me this list which I have saved at index 3. Now when you try to access the index which is not there, so I'm going to just write y, and then I'm going to say 100, and this value is not present in this list at this index. So I'm going to press enter, and it's going to give me the error which says list index out of range. Now if you want to get the length of the list, you can use the inbuilt function in Python which is len, and then your list name. So for example, I want to find out the length of list x. It's going to give me 6. It's going to give me 6 because you can see here this list contains 6 elements. Or I want to get the length of the second list which is y, and it's going to give us 4 because this list contain 4 elements. Now it's also possible to insert and remove elements from the list. So for example, I'm going to use x which has 6 elements till now, and I'm going to insert the 7th element. So I can use a method called insert, and you can see this method takes an index and the object name. So I'm going to choose this, and the index at which I want to insert the value is at index 2, and the value I want to insert is some string, for example Tom, and I'm going to press enter, and I'm going to print the values inside the x list. Then you can see now this list has 7 elements, and Tom is inserted at the index 2 because we have inserted this value at the index 2. In a similar way, you can remove something from a list also. So to remove something, you can use your variable name, for example x dot remove, and the value you want to remove. So for example, once again I want to remove this name which I have inserted at index 2, and once again when I print the value of x, it's going to give me these values. Now let's say the list contains 2 elements which are exactly the same. So I'm going to insert one more element at index 1, and this element will be 3, for example, and now my list contains double 3 here. And if I want to remove this 3, so I'm going to just call this remove function once again, and I will say 3 here and then press enter. You can see only 1 3 is removed from this list. So you can see these 3 are at index 0 and index 1. So this value is removed, which is at index 0, and this will remain in this list. So if a list contains duplicate values, it's going to remove the value from the left, and also remove is going to remove only one object which is found first in the list. Now if you try to remove the element which is not there in the list, so I'm going to remove something which is not even there in this list, then it's going to give us this error which says that this is a value error and it cannot remove this value from the list. Now there is one more function with the list which is a pop method, and this we can use to remove the values from the last. So you can see our list was previously having 6 elements and 10 was the last element, and when you use this function which is pop, it's going to pop this 10 from the list. And now let's see the content of the list. So now this list contains only 5 elements and the last element is now removed. Once again, when you use this pop method, it's going to remove the 7, and now our list only contains 4 elements. Now let's say you want to delete the whole list. So I'm going to declare a list, and this list will contain a few values, and then I will press enter, and you can see the values of list. And now I can use a function called del and then the name of the list, and this function is going to delete this list. So I'm going to just press enter and then once again try to access the values inside this variable, and now it says the name Z is not defined because delete function has deleted this list. Now once again I'm going to create this list Z, and now there is a function called clear which is used to remove all the values from the list. So I'm going to just press enter and then try to access the value of Z, and you can see this list is now empty because we have used the clear function which is used to empty the list. Let me show you a few more functions related to lists. So let's say I can use X, and the values inside X are 3, 5, 4, 9, and I can use a function called sort to sort all these integer values inside the list. And once I press enter now you can see all the values are sorted, and you can see all the values are sorted in ascending order. You can also use this method x.reverse, and it's going to reverse all the values. So once I use the reverse function, and then when I try to get all the values inside the list, you can see all the values are now reversed. There is also a function called append, and here you can append anything to your list. So I want to append 10 to my list, and when I try to access this list, you can see at last this 10 is appended in my list. Also, if you want to copy one list into another, you can use, let's say I'm going to declare a variable called s here, and I want to copy all the values from X list. I can use x.copy, and this is going to copy all the content of my X list into this new variable called s. So you can see all the values are copied into the variable s. So let me append something into my list once again. So I'm going to append 10 once again, and now my list looks like this. And there is a function called count, using which you can count the number of elements which are there in the list. So I want to find how many number of 10 are there in the list. It's going to return me 2. And once again I want to count how many 3s are there in the list. It's going to return me 1. Let's say I want to count how many hundreds are there in my list, and it's going to return 0. So this is how you can use lists in Python. You can also use the list name and then dot and see all the methods which are available related to list here, and you can use these methods which you see here. In this video, we are going to see how to use tuples in Python. So first of all, what are tuples? So tuples are very similar to lists. That is, they are used to store the collection of elements in a single variable, but there is a very important difference between them, and that difference is tuples are immutable. Immutable means once tuples are created, they cannot be changed, or the content in them cannot be changed. So let's see how we can declare a tuple. So I'm going to declare a variable called x, and I'm going to assign some values to it. Now in case of list, we have seen we used the square brackets. In the case of tuples, we use these parentheses in order to store the list of elements. So I can just write 1, 5, 3, 4 and 8 for example, and then press enter, and it's going to create a tuple. Now in order to print the tuple, you can use x, and it's going to print this tuple. Now as I said, tuples are similar to lists in some ways, and that means you can call a tuple element by our index in tuple. So all the tuple elements are arranged by their index, and when you want to, for example, get the first element here, you give the index 0 and then press enter, and it's going to give you the value which is saved at index 0. Let's get the value which is saved at index 4, and I'm going to press enter, and you can see it gives 8 which is saved at index 4. Now when I try to give an index which is not there, for example 100, it's going to give us error which says index error, tuple index out of range. Now as I said, tuples are immutable, that is you cannot change the content of a tuple if they are initialized once. So let's try to test this. So I'm going to just assign the value at index 0, which is let's say 2, and I'm going to press enter, and you can see it says type error, tuple object does not support item assignment. That is, you cannot assign any other value to a tuple element if they are once initialized. Now that also means that you cannot use some of the functions which you used with lists in the tuples. For example, you cannot remove any element, you cannot append any element, you cannot change any element. So for example, when I write x here and then press dot, you can see there are few methods which are available with the tuple, and most important is this count method. So let's try to use this count method, and I want to know how many number of 8 which are there in this tuple, and it will give me 1 because 8 is only present once in this tuple. If 8 is present twice in this tuple, here you will see the result 2. Now in order to get the length of the tuple, you can use the inbuilt function which is len, and then the tuple name, and then press enter, and it's going to give you the length of the tuple. Now in the previous video, I have told you that you can save multiple data type values in lists. Let's see if we can do the same with tuples or not. So I'm going to give the parentheses, I'm going to give the first value as integer, second value as a string, third value as for example the decimal value, and I'm going to press enter, and I'm going to get the value of y, and you can see it's totally possible to save multiple data type values in a tuple. So now I have declared two tuples, one is x and other is y. So let's print x and y once again very quickly, and now what we want to do is we want to use a concatenation operators. So as I said, tuples are immutable, but let me define a third tuple here, and I want to add x tuple and y tuple here, and I want to assign the value to z. Is it possible? Let's check. So I'm going to just once again see the contents in the z variable, and you can see when you use this plus operator or concatenation operator, it's going to join these two tuple and create a new tuple with the combination of the values of both these tuples. Now there is one interesting thing which you can do with a tuple, which is you can declare a variable, and let me define a tuple with only one element, and I'm going to just give hi here, and then after this element I'm going to provide comma here. So this is important, I have provided this comma and I haven't provided the second element in the tuple, and I can use an asterisk here and I can use some value here. So let's say I have provided 5 here, and I'm going to press enter, and then I'm going to see the values inside this a variable. And now you can see hi string is saved 5 times in a variable in the form of a tuple. So you can once again get this value at index 2, for example, and it's going to give you the value which is stored at index 2, which is hi itself. You can also use an inbuilt function called max here to get the maximum value out of a tuple. So max, and I have provided x tuple here, and you will be able to see it will give us the maximum value stored in that tuple. And you can see here 8 is the maximum value which is there inside the tuple. We can also get the minimum value using min function, and it's going to give you the minimum value which is stored inside the tuple. And also you can use a del function to delete a tuple. So let's say I want to delete this tuple which is z here, so I can just write the name of the tuple after del and space and then press enter. And now once again when I try to get the value of z, it's going to give me error which says name z is not defined. So in order to delete the tuple, you can use the del function. So this is how you can use tuples in Python. In this video, we are going to learn how to use sets in Python. So first of all, what are sets? So a set is an unordered collection with no duplicate elements and no indexing. So let's see how we can use sets in Python. So you can declare a variable and then is equal to, and you define the elements in set in a curly bracket. So you can define multiple values here, for example 1, 2, 5, 4, 7, 9. But keep in mind that set cannot have duplicate values. So each value in set must be a unique value. So for example, what happens when we define a set with some duplicate values? So I'm going to just declare this set and press enter here, and this set is created. Now whenever I try to access the values inside this set A, then it's going to give me this set. And you can see the 2, which was a duplicate which we have defined here, is removed from this set. So a set always have unique values, and if you define a set with duplicate values, it's going to remove the duplicate values and only save the unique values in the set. So let's see some of the methods related to sets. And the first method is, as always, len method, and you can find the length of a set using this len method and the name of the set, which returns the length of a set. You can also use add function, so a dot add, to add an element in a set. So I want to add 10, for example, into my set. I can use this and then press enter, and once again when I try to get the values inside this set A, you can see 10 is added to this set. But this 10 will only be added if it's already not there in the set. If it's already there in the set, nothing will happen. So let's try to add once again 10 to this set which already have a set, and once again you will see that nothing happens inside the set because 10 was already there. Now if you want to add multiple values in a set, you can use a update method. So you can call this method which is update, and then inside the curly brackets you need to provide these multiple values. So let's add some values into this set. So I'm going to add 15, 18, 17, let's say, and 14. Okay, and then press enter, and now I will see the values inside the set, and you can see all these values are added to the set. You can also remove the values from the set. So I can use a method called remove, and let's say I want to remove 18 from this set. I can just give the element and then press enter, and once again I will try to access the set, and you can see 18 is removed from this set. Now there is a method called discard also. So let's see how we can use this method. Discard works similar to remove method. So So for example, I want to remove this 17 from my set. I can write 17 here and it works fine, right? So when I try to access the value of a, 17 is removed. So what is the difference between a discard method and a remove method? So a remove method, whenever you use a remove method and you try to remove an element which is not there in the set, for example, I will try to remove 100 which is not there in the set, it's going to throw an exception and it says key error 100. Now if you try to do the same thing using a discard method, so I'm going to use a.discard here and try to discard 100 from the set which is not there in the set, it's not going to give me any error. And that's the difference between discard and remove. So remove throws an error when an element is not there, but discard doesn't throw any error. It's not going to do anything if the value is not there in the set. Now there is a pop method also you can use with set. So I can use this pop method and then press enter, and what it's going to do is it's going to remove any random element from your set. So it's not necessary that it's going to remove the element from the left hand side or the right hand side. It will remove any random element from the set. Also, for example, I will declare a set of names, let's say, and if you want to clear the set, you can use a clear method. So I can use this clear method in order to empty this set. So now when I try to access the values inside the set, you can see it's an empty set with no values. If you want to delete a set, you can use a del function and then the name of your set and then press enter, and once you delete it, when you try to access it, it's going to give you an error that name is not defined. Now you can also create a set using a set constructor. So instead of these curly brackets, you can write set and in the double parenthesis. So you need to provide the double parenthesis here in order to create a set using the set constructor. So this is also going to create this set called name, and when I try to access the values inside the set name, you can see it has created this set of names. Also, you can convert a list into a set. So let me define a variable called z, and then I can use a set constructor, and inside these parentheses I can use these square brackets which we use generally with lists, and then you can define your list here and then press enter, and this list will be converted to a set, and you can see the result here. Now similar to the mathematical set operations like union, intersection, difference, symmetric difference, you can also use these mathematical operations related to set on the Python sets also. So let's see how we can use this mathematical set operations on our Python sets. So let me once again define a set. I have already one set which is A, which contains these values, for example, and I will define a set B with some other set of values. So I'm going to define a set with, for example, so that is the content of the set B. Okay, so now I have two sets, and on these two sets I want to perform some set operations which are also used in mathematics. So you can find out the union of two sets using an operator called OR. Okay, so when I write A and this pipe symbol which is called OR B, it's going to give me the union of these two sets. And what is the union? So union of two sets contain all the elements that are there in the set A or in the set B. So OR here is important, right? So I'm going to press enter, and you can see it's going to give me the union of A and B. That means this set contains all the elements that are there in set A or in set B. Also, I can use a method called union instead of this OR operator. So I can use a variable dot union. There is a method called union, and then you can write B here and then press enter, which is going to give you the same answer. Okay, so you can either use this union method or this OR operator. Now let's see how we can find out the intersection between two sets. So in order to find out the intersection, you use A and this operator AND, and then your next set, which is B here. So what is an intersection of two sets? So intersection of two sets contains all the elements that are there in both the set, that means set A and set B. Okay, so when I press enter, you can see it gives me two elements inside a set, and these two elements are there both in the A set and the B set. That's why we get only two values, because these two values are there in set A and set B also. Again, you can use a method called intersection. So A intersection and then B, which is going to give me the same answer. So either you can use this method or you can use this operator. Now let's find out the difference between two sets. So what is a difference between two sets? A difference of two sets contains all the elements that are in A but not in B. Okay, so you can find out the difference by this minus operator here. So when you write A minus B, you will be able to get the difference between these two sets, and this result will contain all the elements that are in A but not in B. You can also use B minus A, and then it's going to give you other result, because this time it's going to give you a set which contains all the elements that are there in B and not in A. So difference between set A minus B is totally different from B minus A. And also you can use a difference method. So A, then you can call a difference method B, and it's going to give you the same kind of answer you can see here. And also you can call B dot difference A, and it's going to give you the another answer of B minus A. Now you can also find out the symmetric difference between two sets. And what is the symmetric difference between two sets? A symmetric difference between two sets contains all the elements that are either in set A but not in set B, or they are there in set B but not in set A. So this is the symmetric difference, and you can find out the symmetric difference using this cap symbol and then B. So A cap B, I don't know what is the exact name of this symbol. You can find out by yourself, and when you do this, it's going to give you the symmetric difference between A and B. And whenever you find out the symmetric difference, then when you do, for example, B, this cap symbol A, it's going to give you the same answer, because symmetric difference give you same answer. Whether you give A cap B or B cap A, the answer will be always same. Also you can use a method symmetric difference. So you can use this method called symmetric difference B, and it's going to give you the same kind of result. Now one last thing I want to show here is sets are not indexed or ordered. So whenever you want to find out, for example, A and the value at index 0, it's going to give you an error because there are no indexes in a set and they are not ordered by any index. So sets are unordered collection of values. Now if you want to find out what all other methods you can use with sets, you can create a set and then write the name of your set and then press dot here, and you will be able to see this is the list of all the methods which you can use with the sets. Also, if you want to list out all the methods which you can use with sets, you can use this inbuilt function dir, and then you can provide any set name here, which is your variable name, and then press enter, and once again it's going to print the list of all the method which you can use with the sets. So this is how you can use sets in Python. In this video I'm going to show you how to use dictionaries in Python. So first of all, what are dictionaries? So dictionaries in Python are like associative lists or a map. Now you can think of dictionary as a list of pairs. So let me show you how to define a dictionary. So you can define any variable name, and to define a dictionary, first of all you use these curly brackets, and inside these curly brackets you provide a list of key value pairs. So let's provide the list of key value pairs. So first key is name, and the name is Max. The second key is, for example, age, and the age of Max is, let's say, 14. And we can also write here in which year he was born. So we can just write year, and he was born in 2004, for example. And I'm going to press enter here, and once again I'm going to just access the values inside this dictionary, which is D, and you can see our dictionary is created now. So as I said, dictionary is a list of key value pairs, and all these values which you see here before this colon are called keys. So name is a key here, year is a key here, and age is a key here. And whatever values you see after the colon are called values. So Max is a value, 2004 is a value, and 14 is a value. And you can access the values from a dictionary based upon their keys. So for example, I have this dictionary D. I can use this square bracket, and the key name, for example, I want to get the name value. I can just give the name key here and then press enter, and it's going to return me the associated value related to key name. In the same way, you can use other keys also, for example, age, and I'm going to press enter, and it's going to give me 14, which is the value. So age is a key here and 14 is the value. Now what type of data types you can store in a dictionary? So as key you can define any data type. So let me define a new dictionary here, and I'm going to give these curly brackets, and as I said, you can define a string value as key. Also you can define a number as a key, for example 15:15. Let's try the float values. So I'm going to just write 15:1:15.1. This is also allowed in dictionary. So you can use string values, you can use integer values, you can use decimal values as key, and also let's try the Boolean values. So you can use the Boolean values also as keys, and you can use a tuple also as a key. So I'm going to just give a tuple 2,3, and then I'm going to assign a value of 5 to this key. And as values also you can use string values or decimal values or integer values or Boolean values or any kind of collection you can use as a value. So I'm going to press enter here, and now to access, let's say we want to access the value for this key, which is this tuple. So I'm going to just enter this tuple inside these square brackets, and it's going to return me 5. Or I can just provide inside the square bracket true here and then press enter, and it's going to return me the value which is associated with it, which is true itself. Or I can just write here 15, and it's going to return me 15 in turn, because 15 is associated with this value, which is also 15. Now what happens when a key is not there and we try to access it? So I'm going to just access 100 from this E dictionary. It's going to give us error that this key is not present in the dictionary. You can also use the len method to find out the number of items in the dictionary, and you can see it says 5 items are there in the dictionary E, and we can count these items. So this is 1 item, 2 item, 3 item, 4 item, and the 5th item is here. Or in other words, you can also say that len function is going to return you the number of key value pairs which are stored in a dictionary. You can also use, for example, I'm going to use my D dictionary now, and you can also use a method called get, and then you can give the key name here in the parenthesis. So let's say I want to get the value associated with the name key. I can get it like this, and it's going to give me the value associated with the name key. You can also add a new key. So this D dictionary, you can see there are right now 3 key value pairs, and I can add one more key value pair. So to add a key value pair, you need to just write D, and in the square bracket you just need to give the name of the new key. So I'm going to just write surname here, which is the name of the new key in the dictionary D, and then you need to give the value associated with that key. So when I press enter, and once again when I try to access the values inside the dictionary, now you can see that surname is added to your dictionary. Now if you want to remove any key value pair from a list, then you can use d.pop method and then the name of the key which you want to remove. Let's say we want to remove the surname once again, which we have added, and you can just press enter, and now you can just print the values inside D. Now you can see the surname key value pair is removed. You can also use a clear function. So let's see what's there in the E dictionary. So these are the values inside E dictionary. I can use E.clear to clear the values inside the E dictionary. So once again when I try to access E, it will give me the empty dictionary. Also you can delete the dictionary using del function and the name of the dictionary, and when I press enter and when I try to access this dictionary E once again, it's going to say that this name is not defined. You can also update the values in a dictionary. So this is my dictionary and I want to update the name, for example. So I can use the dictionary name and then the key here, for example name, and the new name I want to associate with this key is, let's say, a new name here. And when I try to access this dictionary once again, you can see the name is changed. You can also use a method called update to update this key value pair. So once again I want to change the key value pair, which is name. So I can give this curly bracket and then give the key value pair which I want to change. So name, and the new name will be Max once again. And once again when I try to access the dictionary, it will give me this dictionary, and you can see the name is updated now. Now there is a function in dictionary called keys, which is used to list out all the keys of that dictionary. So you can see it will list out all the keys of the particular dictionary. There is also a function called values, which will list out all the values of that dictionary. If you want to list out all the key value pairs, you can use the function called items here, and it will give you the key value pair list. Now the last function I want to show here is, let me list out the content of the dictionary first of all. So there is one more function which you can use here which is pop item, and you don't need to give any argument with this pop item. When you press enter, it's going to remove the last key value pair which you have added or updated. So here we have updated this name key value pair, that's why this is removed. And now when you try to see the content of the dictionary, this name key value pair is removed. So this is how you can use dictionaries in Python. In this video we will talk about the slice function in Python, and also we will talk about how to use negative numbers with index in Python. So let's get started. So first of all, I'm going to declare a list. So now we have three variables. First is a list, second is a tuple, and third is a string. Now there is a function called slice which you can use with your lists, tuples and strings to slice something out of your collection. So to use this slice, I'm going to declare a variable and then I'm going to use this function which is slice, and you can provide some parameters in the parenthesis here. So the first parameter you can provide here is, for example, start. The second parameter you can provide here is the end, and the third parameter you can provide here is the step. So let's say I want to get out of this list the numbers from 0 to 4. So as a first argument we can define number 0, which is the first index, and at the end index we can define 5, and then I'm going to press enter, and once again I'm going to use my list variable and pass this x variable which contains the slice object which is returned by this function here, and then press enter. And you can see here it gives me the values from 0 to 4. So the first argument in the slice function is the index from where you want to start. The next parameter is the index of the element before which you want to stop. Okay, so if you want to stop at 4, you provide the index 5. If you want to stop at index 5, you will provide the stop value as 6. Okay, so it will be always one more than what you want. Now there is a short notation for achieving the same also, and for that you can use your list, and inside the square bracket you can provide the start value and the end value, and then press enter, and it's going to give you the answer. But instead of comma I need to provide the colon here, and then it will give me the answer. Okay, so here you can use colon to give the start value and the end value, and also an optional value which you can give as a third parameter, which we will see in a moment. Okay, so this is the short notation of creating slice in Python. So as I said, this is the start value and this is the end value plus 1. Okay, so let me show you something. I have a list here, and you can see here I have written, you have the variable a, it can be a list, it can be a tuple, or it can be a string, and inside the square brackets you give the start value and the end value separated by this colon symbol, and what it's going to give you is the items from start through end minus 1. Okay, so whatever end value you will give here, you will get the value end minus 1. You can also use this notation, so start colon and without giving the end value, and also reverse is possible, so you can give only the end value and not the start value, and also this notation is possible. So we will see one by one how to use all these notations. So first of all, I will give, once again I will use the tuple now, and this time I'm going to just give the start value. Let's say I want to start from 4 here, and then colon, and then press enter, and it's going to give me the result from index 4 until the end of this tuple. Once again, let me give the end value. So instead of using this value before colon, this time I will give the value after the colon, and I will leave the start value blank. And here let's say I just want to go before 6, so I'm going to press enter, and you can see it will give me the result from 0 to 5, that is end value minus 1, right? So until 5. And also you can give this kind of notation. So this time I'm going to use the string variable, and you can use colon without giving the start and end value, and when I press enter, it's going to give me the whole string. Let's say with this string I want to provide the start and end value, let's say 0 to 5, and then press enter, it's going to give me a string from 0 to 4. So this slice functionality you can use with the tuples, lists, and also with the string, or essentially whatever collection which have the indexes, you can use this kind of slice notation with those kind of collections. Now in addition, with the start and end value, you can also give the step values. So let me just print the value of a once again, and you can see the values inside the a. And let's say I want to get out of this list 0, 2, 4, 6, 8. Okay, so essentially I want the every second value from the list. So what I can do here is I can give the variable name and then start to end, so from 0 to index 9, and the third argument here you can give is the step. So let's say I want to get the every second value, so I can give 2 here and then press enter, and it returns me 0, 2, 4, 6, 8. Now let's say I want to get every third value, so I can write 3 here, and it's going to give me 0, 3, 6. Okay, in a similar manner, if I want to get the every fourth value, I can write 4 here and then press enter, and it gives me 0, 4, 8. Also, if you don't want to give this range from start to end, you can leave the start and end value as blank and then press enter, and it's going to give you the same result. Now in Python, you can use indexes with the negative numbers also. So let me explain what I mean by negative number index. So let's say I have a string called Python. It have these character Python. You already know that you can access the P character or P letter using the index 0, and the Y letter using the index 1, and the T letter using the index 2. So this is the positive index, right? You can also use the negative index, which starts from the right hand side. So it starts from N, and the index you can give here is from -1. So the last index here will be -1, then -2, -3, -4, -5, and -6 here. So let's use these kind of indexes and let's see how we can use them. So we have this string here, and let's say I want to get this value, which is 9, which is the last letter of the string. So I can use C, and here inside the square bracket I can give -1 and then press enter, and it's going to give me the last letter of the string. If I give -2 here, it will give me the second last letter. Okay, so the negative index starts from the right hand side, and it goes from -1 till the end of the string. Now let's use this negative number index with the list which we have. So we have this A list, and we can use A, and then we can give a colon -1, which is going to give you all the numbers in the reverse order in the list. So our list was starting from 0 to 9. It will give us 9 to 0 in the reverse order. Now let's say if you want to get the first 2 items in the reverse order. So this is when you use this -1 as the third parameter, it will give you everything in the reverse order. Okay, so -1 as the step value is used to give everything in the reverse order. So when you give, for example, 1 here and leave the end parameter empty, it's going to give you, you can see 1, 0. So as you can see, our list starts from 0, 1, and it's going to give us the reverse order values. So it's going to give us 1, 0, because here we have given 1, and it's the end value for this reverse string because we have used the -1 here. Let's take some more examples. So instead of the start value, I can give -3 here and then press enter, and you can see it gives us 8 and 9, which are the last 2 items of the list in the reverse format. Okay, because our index in reverse starts from -1, -2, -3, and we are skipping the -3 option because we have seen that we just take the end -1, right? So -1, -2, and these will be given to us in the reverse order because we have used -1 here. Now you can also give, for example, -3 as the start value. So I'm going to give the -3 as the start value and then press enter, and it's going to give us 0 to 7, right? So 0 to 7 except 8 and 9 in the reverse order. So because 3 this time is the start value and end value is until the, so because 3 this time is the start value, so we go from -1, -2, -3. So -3 is this index, and this is the start value. So we get 0 to 7 in the reverse order. So this is how you can use slice function and negative values with indexes in Python. In this video, I'm going to show you how to use loops in Python, and we will start with the while loop. So first of all, what is a loop? So a loop allows us to repeat over some block of code again and again until and unless some condition is met. Now let's see how to use while loop in Python. So let's say I'm going to declare a variable called I, and I'm going to initialize it with the value 0. And to use a while loop, you use this keyword and then you provide some condition. So let's say I want to check whether the value inside the I variable is less than 5 or not. Okay, and as in the case of if also, we have seen we provide after the condition this colon symbol, and then in the next line we write the code which we want to perform again and again until this while loop condition is true. So let's say we want to just print something, and we will print that the value of I is, and then we will print the value of I like this. Also, I want to change the value of I with every step. So I will change the value of I using this expression, which is I plus equals 1. This essentially means that we want to just add 1 every time whenever this code is executed. Also, we can say that we want to perform this operation I is equal to I plus 1. So this statement is similar to this statement. Let me provide some spaces here. Now in here also you will observe that I have provided some indentation here, and indentation means that these two lines of code is the part of while loop. Okay, so when I want to write something outside the while loop, I will start from here with no indentation, and let's say I want to just print that we are finished. And now let me run the code and let's see what's the result. And you will see here, first of all, this string is executed, which is the value of I is, and then the value of I is printed, which is 0, 1, 2, 3 and 4. So as you can see here that we have initialized I is equal to 2. So the initial value of I is 0. Now when we come to this code and when this condition is checked, here the value of I is 0, which is less than 5. That means this condition is true, and that means that these two lines of code which are under while loop will be executed. So this line is executed where value of I is printed, which is I is equal to 0, and this line of code increments the value of I by 1. So when this line of code is executed, now the value of I becomes 1 because previously it was 0, and once again this program flow goes to the starting to evaluate this condition, and this time the value of I is 1, which is less than 5, and the condition is true once again. And again this line of code is executed, and this line of code is executed, and the value of I is incremented by 1 once again, and the value of I becomes 2 here, and this will happen again and again until the value of I becomes 5. And when the value of I becomes 5, this condition will be false, and that means this code will not be executed. This code will only be executed when the while loop condition is true, and then at last this line of code is printed, which is finished while loop. Now let me give you one more example of while loop, and I will start from the top once again. And this time I will declare a variable called num, and I will initialize this value by 0, and also I will declare a variable called sum, and initial value of sum is also 0. Now here first of all I will ask the user to enter a number, so I'm going to just write, and also I will ask the user if he or she wants to exit from the loop, he can enter zeros. And then in the next line I will start with my while loop, and I will give the condition if the number, I'm going to write number is not equals to 0, we want to perform some operations. And what operation we want to perform? We want to ask the user to provide any number, and we will transfer this number into the variable num. So here I will first of all write input, and then I will ask the user to provide the number. And when the user provides the number, I want to convert it to a float value. So I will just typecast this input to a float value, and then this number will be assigned to the variable num. Now here don't forget to give the colon, and in the next line what I will do is I will just use my sum variable, and I will just add the number value to the sum. So I can just write sum is equal to sum plus num, and this means that initially the value of sum will be 0, and then this number will be added to the sum, and until this loop runs we will get the sum of all the numbers which is entered by the user. And at last I'm going to just print the value of sum. So now what do you think will happen? So in this condition we are evaluating that num should not be equal to 0, and then only this code will be executed, and we have provided the initial value of number is equal to 0. So this condition will never be met, and this statement will never be executed. So we need to provide the initial value of num is equal to 1, and then whenever the user provides the value, this 1 will be overwritten by the value which is provided by the user. So this time when we run the code, you can see first of all the program asks us to provide a number. So I will provide 100 here and then press enter, and you can see the sum is printed which is equal to 100. Once again we will provide some number and then press enter, and now you can see sum is equal to 150. Once again we will provide one number and then press enter, and now the sum is 1050. Now let's say we provide a number is equal to 0 and then press enter. You can see that our while loop is finished because 0 is not equal to 0, that means a false condition, and then the flow of program comes out of the loop, and then the other while loop will be executed, which is this while loop, and that's why this output is printed. We can also write that sum is equal to, so we know that this is the sum, so sum equals, and then after the comma we will print the value of sum. And once again when we execute the code, and once I want to exit from the code, I can use 0 to exit. So 0 and then press enter, and I come out of this loop. Now Python also supports the else statement to be associated with the loop statement. So what I mean by the else statement to be associated with the loop statement is that I can use after the end of this while loop condition, I can use here else, and after the colon I can provide some code which I want to execute once this loop is finished. Okay, so I can write here that I want to print, for example, finished sum. So let me run the code once again, and I will quickly provide some numbers here, and which will provide the sum, and when I provide 0 here, then we come out of the loop, and you can see this finished sum string is printed using this else. So once your program comes out of the loop, this else statement will be executed. Similarly, we can go down, and here also instead of writing this finished while loop, we can also give else statement here. So I'm going to just write else, and after the colon here I need to provide the indentation. So 4 space indentation, 1 2 3 4, and everything will be okay. And once I run the code, and first of all I will provide 0 here to see if this is executed, and you can see this else condition is called once your while loop is finished. Now also you can provide some condition here which is always true. So for example I can write true here, and this means that while loop evaluates to true every time, and this means that this statement will be executed forever. So this is also possible, but you need to think carefully. What do you want to do? Do you want to execute this code infinitely, or do you want at some time that this condition will be false? So this is how you can use while loops in Python. In this video, we are going to see how to use for loops in Python. So first of all, what are for loops? So a for loop is used to iterate over a sequence, and that sequence can be a list or a tuple or a dictionary or a set or a string. So for that, I'm going to declare some variables, and the first variable is A, which is a list. Second variable is B, which is a tuple. Third is C, which is a set. Fourth is a string, and fifth variable is E, which is a dictionary. Now before seeing the syntax of for loop, I'm going to show you how to use in operator in Python because it's used in for loop. So I'm going to first of all use print, and then I'm going to use 0 and then use in operator, and then I'm going to use this first variable, which is A, which is a list, right? And let's see what happens when I try to run this code. So it prints true. So in operator will give you true or false depending upon whether this value is present in your sequence or not. So for example, when I write 100 here, which is not present in the list, it's going to return us false. So this you can use with the tuple also. Let me just use it with tuple, and let's use 1 here, and I'm going to run the program, and it prints true once again. Also we can use in operator with strings, so I can write D here, but for that I need to convert this 1 into a string. So now when I run the code, it will give me true. Now let's see how to use a for loop in Python. So for loop, as I said, we can use with some sequence. So let's use it with A, which is a list. So I can write X in A, and A is a list in this case, and then I can just print the value of X, and let's see what happens first of all when we just write this kind of a for loop. So we are going to run the program, and what it does is it prints the values from 0 to 5, which is the element present inside the list. So for loop is going to iterate over your list one by one, and this in operator is going to check whether this value is there in your sequence or not, in this case in our list or not. So first of all, when for loop start, it will transfer the first value, which is 0, into X, and then it checks whether X is in this list A or not, and then it's going to print the value of X, which is 0. And once again program sequence goes here, and once again the next value is transferred to X, which is 1, and once again this condition is validated if 1 is in this list A or not, and then the value of X is printed, which is 1, and this iteration goes on and on until 5 is reached, which is the last value in the list. So 5 is printed, and after that there is nothing inside X, and then the program flow comes out of this loop. You can also use this for loop with the tuple also. So let's try it with tuple, and let's see what happens. And it's going to print the same values. Also with the set, let's see what happens. So I'm going to run the program once again, and it prints 0 to 5 once again because these are the content of the set also. Once again, let's try to use this for loop with the string, and let's see what happens. And it's going to print out the content of this string, which is 0, 1, 2, 3, 4, 5, and it prints them one by one. Now with the dictionary, we use this for loop in a little bit different way. So for example, I will write the variable name, which is a dictionary, and then let's say I want to just print all the keys inside this dictionary. Then I can write e.keys, and then we have all the keys using this function, and when I run the code, it's going to print all the keys inside your dictionary. Also, when you use the function called dot values, it's going to print out all the values inside your dictionary. You can see max and the age 20. Now let's say you want to print out all the key value pairs which are there in your dictionary. You can use a function called items, and this is going to give you keys and values, right? So I can just write key, comma, value here, and then I can print the value of key. First of all, key, and let's provide some space here, and then let's print out the variable value here. Okay, and when I run the code, it's going to give you first of all key and then the value, once again key and then the value. So in order to print out the keys and values from a dictionary, you can use this kind of notation. Now you can also use a function called range. So let me show you how to use this function, which is range, which returns us the values starting from 0. So there is a function called range here, and in here you can provide a number, and this range is going to return the number starting from 0 to 5. So whatever number you write here, the range will be returned from 0 until that number except whatever number you write here. Okay, so let me just try to print out the values which is there in the X, and when I try to print this, it's going to return me from 0 to 5. And you can see here 6 is not printed because the range will give us the value except that value which you write here. You can also provide the start value here. So let's say I want to start from 2 and I want to go until 5. I can write something like this, and now you can see now it start printing from 2 to 5. Also you can give a third parameter here, which is a step parameter. So I can give 3 here, for example, and let's say I want to write 30 here, and let's run the code. And now what is going to return is it starts from 2 because we have given the start value 2 here, and it's going to go until 29 because we have given 30 value here, right? And this is the step. So every third value will be printed after 2 here. So 5 will be printed, then 8, then 11, 14, 17, 20, 23, 26 and 29. Every third value, right? If you write here 2, then we will increment in the step of 2. So this is how you can use range function with your for loop. Also, as I said in the last video, you can use else statement with your loops. So I can also write else here, and then after the colon in the next line I can print something, or I can execute some statement. So for now I will just print finished, and then I'm going to run the code, and once the loop is finished, you can see this else statement is executed, which prints finished. So else statement will be executed once your for loop is finished. So in this way you can use for loops in Python. In this video I'm going to show you how you can use break and continue keywords with your Python loops. So to start with, I have here 2 loops. One is a for loop and other is a while loop. Now this for loop takes a list and then print every element out of this list using this print function. In a similar way, while loop evaluates the value of I. If it's less than 5, then it's going to print the value of I and then increment the value of I by 1. Now this is all normal and we have already seen this kind of code. Now you can use a break keyword with your loops in order to terminate the execution of loop immediately. So let's see how we can use break keyword first, and then we will see how to use continue keyword. So here I'm going to give a condition inside my for loop, and I'm going to just evaluate whether x is equal to 3 or not, and if x is equal to 3, I'm going to use this break keyword. In the same way, I'm going to use this if condition inside my while loop also, but instead this time I'm going to evaluate I is equal to 3, and if I is equal to 3, then I'm going to use this break inside this if condition. So let's run the code and let's see what happens. And you can see in the for loop it has only printed 0, 1, 2. Even though this for loop is supposed to print from 0 to 5, it has printed until 2 from 0, because as soon as this x value becomes 3 and we call break here, the loop is terminated immediately and our program will come out of the loop immediately as soon as this break keyword is called. In the case of this while loop also, as soon as this I value becomes 3, we are calling the break keyword, and as soon as this break keyword is called, our loop is broken and the execution of code will come out of this loop. So until 2 everything was okay, but as soon as the value becomes 3, this break is called and then we come out of the loop. Let me just print a line here in order to separate these two loops so we know that from where one is starting, right? So I'm going to once again run the code and you can see for loop prints from 0 to 2 and also while loop prints from 0 to 2. If you change the value here, for example here you want to evaluate x is equal to 2 or not, and here you want to evaluate if x is equal to 4 or not, and then you break out of the loop. And once again when I run the code, you can see the for loop runs only 2 iterations for 0 and 1, and as soon as the value of x becomes 2, we call the break keyword and we come out of this loop. And in the case of while loop, as soon as this value of I becomes 4, we come out of the loop. So the value from 0 to 3 is printed. Now let's see how we can use a continue keyword instead of this break keyword. So instead of this break keyword, I will use a keyword called continue here, and also in the while loop also I'm going to use this keyword called continue, and I'm going to run the program and let's see what happens. So now when you see here, so you can see here for loop starts from printing 0, 1, and as soon as the value of x becomes 2, this condition is met and this continue is called, and as soon as this continue keyword is called, everything whatever code comes after this continue keyword will be skipped and your program execution goes once again to a for loop for the next value. So you can see in case where x is equal to 2 and continue is called, this statement is not executed because as soon as we execute continue in our loop, then that iteration is skipped and all the code after the continue will not be executed. Okay, so we go to the next iteration. So that's why 2 is not printed, because this was skipped in case of 2, and then directly 3 is printed and then 4 and 5 is printed. In case of while loop also, as soon as the value of I becomes 4, you can see 4 is not printed here. You can also change this value to 2, and then I'm going to run the program once again, and you can see while loop prints 0, 1, and why it prints 0 and 1. So because as soon as the value of I becomes 2, this continue keyword is called, and after that this iteration is skipped, and also because this iteration is skipped, these two lines of code are not executed, and because this line of code is not executed, that's why the value of I is not incremented and the value of I always remains 2, and that's why this becomes an infinite loop, right? So instead of increment the value of I at the last line, we can increment the value of I just after this condition check whether I is less than 5 or not, and then we run the code. Now you can see it prints 1, 3, 4 and 5. So now what's happening here is initially the value of I is equal to 0 and this condition is evaluated, and then we first increment the value by 1, and that's why it starts with the printing of 1 by using this print function, and as soon as I is equal to 2, this continue is called, and that's why here 2 is not printed, because as soon as the value of I becomes 2, this continue is called, and every code or every statement after the continue will be skipped for that iteration. That's why 2 is not printed here. So in this way, you can use break and continue keywords with loop. In this video, I'm going to show you what is a function in Python and how to use functions in Python. So first of all, what is a function? So a function is a group of statements within a program that performs a specific task. Now functions can be of two types. One is built-in function and other is user-defined function. Built-in function, we have already seen that print is a built-in function, or for example input is a built-in function, or for example min is a built-in function, and so on. Now usually function does one task at a time. So you can see this print function only prints something. Whatever input you give here, it's going to print it. Input function takes some input from the user. Min function finds out the minimum out of some values. So a particular function do one task at a time. Now let's see how we can define a function. So to define a function, you use a keyword def and then you give the name of the function. So name of function, and after the name of the function, you give these parentheses and you provide number of arguments or parameters. So for example, arg1, arg2, arg3, and so on. So you can give any number of arguments to your function. Now after this ending parenthesis, you give this colon, and then under this function signature, you write some statements which you want to execute when this function is called. So for example, if you want to print something, you can print something, or if you want to calculate something, for example the product of 2 or 3 variables or a sum of 2 or 3 variables, you can do under this function declaration. So let's take an example of function and let's see how we can define a real life function. So I'm going to define a very simple function which is going to add two values. So I'm going to name it as a sum, and for example it takes two values. One is, let's say, arg1 and other is arg2, and then after the colon I want to add these two values. So I can just write print here, and then I can write arg1 plus arg2. So this is a very simple function which takes two arguments and then add these two arguments and print them. So this is how you declare a user-defined function. Now after declaring a function, you need to also call this function. So in order to call the function, you just use the name of the function and then you provide the arguments which is required by the function. So our function requires two arguments right now, arg1 and arg2. So we are going to provide these two values. Let's say I want to provide 15 as the argument 1 and I will provide 60 as the second value. Now let's run the code and let's see what happens. So when we run the code, you can see our function prints 75, which is the sum of these two values which we have provided as an argument to this function. Now also, if you remember, this plus operator you can also use to concatenate two strings. So I can use this sum function, and this time I'm going to provide, for example, hello as the first parameter and then world as the second parameter, and then I'm going to run the program and it's going to print hello world. In addition, we can provide two float numbers here. For example, I will provide 15.647 and the second argument I'm going to provide is 80.258, and this is also allowed. So I'm going to just run this code and it gives us the sum of these two values. So this function sum is doing one single task, which is to add two values, whether it's a string or it's a number or it's a float value. Now you may also observe that when I provide, for example, as a first argument I will provide a string, and as a second argument I will provide a number here. Will this work? Let's see. So it's going to give us an error, and this error says can't convert int object to string implicitly. So this is a problem. So to solve this problem, we can provide here a simple condition, and we are going to check the type of both the arguments. So if type arg1 is not equal to type arg2, this should be arg1, not agr1. So let me just change this here. And if the type of arg1 is not equal to arg2, we are going to just use this keyword, which is return. So this return keyword is used to return something. So you can return, for example, 0 here or any string here. And when you write this return function without any value here, it's going to return nothing. But as soon as this return keyword is called, nothing after that will be executed. So even though you are returning nothing from here, then also this statement will not be executed. So whenever return is executed, after that all the statements which are under the return will not be executed. Also, we can print a message here that please give the args of same type. Okay, and let's run the code now, and you can see now it prints this message which says please give args of same type. So if these arguments are not of same type, whether it's an integer or a string or a float value, if the user provides first argument which is a string type and the second argument which is an integer type, then this condition will be true and this statement will be executed, which is going to print this message, and then return is called, and after this whatever statements are there will not be executed. So now, as I said, you can also return some values from a function, and here when you don't give any values after this return keyword, it's not going to return anything. But let's return the addition of two arguments using a return keyword. So I'm going to use this return keyword here, which is going to return the addition of these two values using this sum function. So now what will happen is, let's run the code once again, and you can see this sum is executed, this sum is executed, this sum is executed, but the result is not printed. So in order to get the result out of this function when it returns something, we need to save this return value in a variable. So let's save this value into a variable, and then you can use this variable to print the value of the sum. So I can do something like this. Also, you can directly enclose this sum function inside a print function, and then also it's going to print the sum of these two strings. So either you can assign the result of this sum function, which is returning the result, into a variable, or you can use directly this print function to get the result and print it. So I'm going to use print with other two functions also. So first print and the second print here, and let's run the code once again, and now you can see what happens. So first of all, it prints 75, which is the addition of these two numbers, which is returned by this sum function into a variable a, and we are printing the sum using this print function. Here in the next result, it prints hello world, because this sum function now returns the concatenation of these two strings. Similarly, this sum function is going to return the sum of these two float values. And in the last result, because the type of hello is not equal to the type of 15, then this message is printed, because this condition is true in the last case, and then return will be called. And when this return is called, we were printing whatever is returned from the sum function. And you can see at last none is printed, because at last this sum function is returning nothing because the type of these two arguments is not same. So we were returning without any value, and that's why none is printed here. Now there are few things to note here. Okay, so the first thing is you can define a function using def keyword and then the name of the function, and under these parentheses you provide the argument. So these two are called arguments. So this is an argument 1 and this is an argument 2. Also you can use alternatively the name parameters for these two arguments. So this is a parameter 1 and this is a parameter 2. Now it's possible to return from a function, like you can return the addition of two values, or it's also possible to return nothing from a function. So when you use return without a value, it's not going to return anything. Now when you use this function somewhere, it's called calling a function. Now at last, let's discuss about some of the benefits of using functions. So the first benefit is function makes your code simpler, because if you don't use function to execute this kind of code, then you need to write this code again and again whenever you want to use this functionality at different places. The second advantage is function makes your code reusable. So the same code is used to add two integer values, to concatenate two string values, to add two float values, and it's also used to give the error if you provide the arguments of different types. So that means you write the code once and use it multiple times, and that results in faster development of the code. So if you use a function, you can develop your code much faster than if you don't use a function. And the last but not the least advantage is when you declare functions, you can test and debug your code in a better way. So this is how you can declare and use functions in Python. In the last video, we have seen how to declare functions and how to use functions in Python. In this video also, we will discuss some more properties which are related to functions in Python. So let's get started. So to start with, I have a function called student which takes two arguments. One is name and other is age. And inside the function, we just simply print the value of name and age using the print function. And when we call this function with the name and age, it's going to print this kind of output. Now Python allows us to set the default value of the arguments. So after this name, you can put equals to symbol and then put the default value, whatever you want to set for the name. For example, if somebody doesn't provide any name, then you can just say unknown name. Similarly, we can set the default age here. Let's say default age is 0. If somebody doesn't provide any age with the student function, then the default value will be 0. Now instead of using this student function like this, let's say I don't provide any argument to this student function, and let's run the code. And you can see if I don't provide any argument to this student function, the default values are taken. So the default values are used when you want to make sure that every argument in your function should have some value. Now let's say I just provide a name here and don't provide the age, and let's run the program. And now you can see the name is overwritten by the argument what we have provided here, right? So default value will be this one if no argument is provided. Similarly, if we give the value of age and now we run the program, the default age is replaced by the age which is provided using the arguments. So this is how you can use default values with the arguments of the function. So let me just remove these default values and I'm going to give you the next example, which is variable length arguments. So let's say with the name and age, I want to provide the list of scores which this student has scored for different subjects. So as a third argument, I'm going to provide an argument called marks, and somehow I want to provide a list of marks which is scored by this student, and let me print the value of marks using this print function also. Now in Python, you can use asterisk in front of your argument, and this means that you can provide multiple arguments when you use this kind of notation. So let's just provide, for example, we already provided the name and age here, and let's provide different marks scored by this student. So I can provide 95 for first subject, then 70 for second subject, then 80 for next subject, then 50 for next subject. And let's say we don't know how many subjects the student has taken, we just have only the information about these 4 subjects which he has taken. So we can provide 4 values here, and then let's run the code. And now you can see name is Tom, age is 22, and the value of marks is shown as a tuple. Okay, so whenever you provide this asterisk in front of an argument, you can provide the values for that argument using normal arguments as you provide for normal argument. So first 2 variables are associated with name and age, and all the other variables which you provide here will be assigned to this marks variable because it has this asterisk in front of it. So now you can also use a for loop in order to iterate over tuple. So x in marks, for example, and then you can print every value, or you can access every value inside this tuple. And let me comment this print function, and let's run the code once again. And you can see for loop has printed all these marks which are there inside the list. Now if you want to use this type of variable length argument, then I will suggest you to use this argument as the last argument of your function, so that it will be clearer to the reader of the function that whatever you provide at the end will be the part of this last argument. Now you may ask that we have provided these marks for this student, but for which subject these marks are given to the student? Now in Python, you can also use double asterisk in front of your function argument, and this means that now you can provide the key value pairs as a marks arguments. So instead of using 95, I can also say that 95 is scored in English, let's say, and then 70 is scored in math, and then let's say 80 is scored in physics, and the 50 marks is scored in biology. So now when you use these double asterisks in front of your function argument, you can provide these kind of key value pairs which are separated by this equal to symbol. And how you can access these values? So let's run the code and let's see what happens. And now you can see only keys are printed and not the values of these subjects are printed. So let's first uncomment this print function and let's see what type of value we are getting. So whenever you use these double asterisks, the values are given to you in the form of a dictionary. Okay, so if you use single asterisk, the values are given to you in the form of tuple. But whenever you use these double asterisks and whenever you try to access this variable, then this variable will be of type dictionary. And you already know how to print the values of dictionary. So you can just write marks.items here, and then here you can just write key comma value, and then you can print the value of key and value. So I'm going to just print key first of all, and then I'm going to just give a space here, and then I'm going to print the value, right? And now when we run the code, it will give me first of all the key, for example English, math, physics or biology, and the value which is 95, 70, 80 or 50. Now before starting our object-oriented programming journey in Python, let's discuss about what is the difference between the procedural programming and the object-oriented programming. So you will have the better idea why we use object-oriented programming. Now traditional programming languages such as C or Pascal were called procedural programming languages or structural programming languages, where the basic unit was functions. Now programming in these type of procedural languages involves choosing a data structure and then designing the algorithm and then translating that algorithm into a code. So if this sounds a little bit confusing, let me try to explain it with an example. So let's say you have been given a task to create a program for a passenger who wants to travel from one place to the another place using a cab service. So if we think from the point of view of procedural programming, what we do in the procedural programming is we create some global data structure which holds the data. So here, for example, we create some kind of data structure which can hold the data. For example, in case of a cab service, which cab service is it, or which type of cab is it, and at what location this cab is standing. All these kind of data we store in a data structure in a global environment. Now after storing the data, we design an algorithm. So let's see what kind of algorithm we can develop in the procedural programming language for our cab booking service. So this is a pseudocode which I have written. So first of all, the passenger will open the app from which he can book a cab, and then he will book the cab, and once the cab is booked, he will wait for the cab, and then once cab arrives, he will sit in the cab, and then he will reach to his or her destination, and at the end he will pay the fare of the cab. And this is the pseudocode of that algorithm, and then we will translate this algorithm into actual code in procedural programming language. Now in these type of procedural programming languages, we concentrate on creating the functions, and the major drawback of using these functions is that data and operations on the data are separated. That means we need a methodology to send this data to these functions. So here we need to send this data which we have saved globally into these functions, and these functions take this data either as argument or as a global variable and then perform some actions on this data and give you some result. Now these kind of functions are passive. What do I mean by passive here? That is, these kind of function cannot hold any information inside them. So once you give the data, they are able to give you the result back after performing some operations, but they cannot save or hold the state or the data, so that if you want to use that data in some other place in your code, then it will be very difficult using these kind of functions which you use in procedural programming. Now let's look at the object-oriented approach of doing things. So in object-oriented programming languages like C++ or Java or Python, the basic unit is class. Now if we take the same example of a passenger who wants to travel from one place to another using a cab service, using object-oriented programming thinking, which depends upon the creation of object, we can create different kind of objects. For example, for a cab, we can create a class called cab, and then we can create a class for cab driver, and the third class we can create for a passenger. Okay, so a class you can create for any real life object. It can be a car, it can be a motorbike, it can be a book or employee or a person. So object oriented programming allows us to create object. So first of all, what is a class? So a class refers to a blueprint in which we can have data and methods. Okay, so for example, for our cab class, what attributes this cab class can have? For example, a cab service, which cab service we want to take. What is the make of the cab? Is it a Toyota or a BMW or a Volkswagen cab? At which location this cab is right now? What is the number plate of that cab so the passenger can recognize this cab? So all these things which I have written here are called data because they can hold some kind of data. Number plate has number plate data, location have geolocation data, make have the make data. Cab service can have data like Uber or any other cab service. And the other thing which a class can have are called method. So earlier we have seen that we can create functions, and when these functions you use inside a class, they are called method. Okay, so functions inside a class are called method. Now the data inside this object or class is called attributes or the member variables which can hold some data. And using this class we can create object of the cab class, which means we can create different object using a same class. And how to create object using classes we will see in the next video in the real life example. So don't worry if you don't understand how these things works. I will give you a real life example so you will be able to understand in a better way. Now what is an object? An object is a software unit that combines data and methods. Okay, so we have this data here and then we have the methods inside the class, and object is able to combine both of them, which is data with the methods. Now these objects, for example a cab object and the passenger object, can exchange the data between them also. So data is interchangeable between, for example, the passenger object and a cab object. So let's rewind once again what we have learned about object-oriented programming. So the basic unit in object-oriented programming is a class, and a class refers to a blueprint which can have the data and methods. Now using a class we can create objects. And what is an object? Object is an instance of a class, and each object can have its own data and method, and an object is able to store the state of some kind. So at which location this cab is right now. So this is a state, and an object is able to store that state. Now in procedural programming, if you remember, there is no relation between the data and the method, right? We need to provide the data to the method, which are separate entities in the procedural programming language. Now these data members are called attributes or member variables, and these functions which you define inside a class are called methods. And what are some of the key differences between procedural programming language and object-oriented programming language? The first is the unit in procedural programming language is function, and on the other hand in object-oriented programming the unit is class. The second is the procedural programming concentrate on creating functions, while object-oriented programming starts from isolating classes and then they can have data and methods inside it. In procedural programming language, the data and the functions are separate, and in object-oriented programming language, data and methods are not separate. They are the part of a single object of a class. Now if all this seems to be little confusing to you, don't worry, you are not alone, and I will try to solve this confusion in the next video, in which I will tell you how to create the classes and how to use classes in Python. In this video, I'm going to show you how you can create your first class in Python. Now, if you haven't seen my last video in which I have discussed what is object-oriented programming and what are classes, I will highly recommend you to watch that video because this will be a continuation of that video. So let's create a class in Python. So for that, I will create a new project. So let's create a new project in PyCharm. So just click on File here and then click on New Project. And then the project name I'm going to give here is Oops. And then I will just click on Create. And I will choose this option which says Open in Current Window. And also this option which is Add to Currently Opened Project, which is going to create this project in this window itself, which is already open. So now you can see we have an empty project here. And inside this project, let's create a Python file. So right click on the project and then New, and then we are going to create a new file. And let's create a class called car. So I'm going to name the file name as car because we are going to create the car class. Now, in order to create a class in Python, you use a keyword class, and then you give the name to your class. So the class name in our case is car, and then you give this colon. And for example, I write here a keyword called pass. Now, when you write this keyword after the declaration of a class, this means that it is an empty class. You can also use this pass keyword to create an empty method. So this keyword pass is used to create an empty class or an empty method. Now here, after the class declaration, let's see how we can create an instance of a class. So it's really easy to create an instance of a class. So let's create a first object, and I'm going to name it as Ford, which is a car brand. And then you use your car class name and use these parentheses here. Okay. So this here, Ford, is an object, or you can also say it's an instance of the class car. In a similar way, we can create multiple objects. For example, Honda is another car brand, and you can create the Honda object using this class car. Once again, you can create a new object, for example, Audi, and then you can once again use this car class to create this object. So what we have done till now, we have created 3 objects from the class car. Now in the previous video, I told you that you can associate some data with your object. So let's associate some data. So for example, Ford, we can associate an attribute called speed, right? So we can assign the speed, for example, 200 here. For Honda, we can assign speed, let's say 220, and for Audi we can assign the speed, let's say 250. So speed here is called the attribute, and whenever you create an empty class using this pass keyword, you can add these attributes on the fly. So you can see we have added these attributes after the declaration of the class and after the creation of the objects. Let's add some more attribute to these instances or the objects. So a car can have the color. So I'm going to just write color, and the Ford has, let's say, the red color, and let me just copy and paste here, and let's say the Honda have the blue color, and we have the Audi of black color. So once again, color is an attribute here. Now if you want to print these attribute, you can use this print method, and then for example we want to print the speed of Ford and the color of Ford, then we can do it like this. And let's run the code. So in order to run this code, first of all, when you create a new project and a new Python file, you need to right click on this file and then click on run the file name, whatever is your file name. My file name was car. So you can see now the result is printed here. First is the speed and second is the color of an instance Ford. Similarly, you can print the color and speed of Honda and Audi objects also. Now if you want to change some attribute, it's also possible. So let's say I want to change the speed of Ford object. So I'm going to use Ford.speed once again, and this time I want to assign 300 speed to this attribute. Let's say we also want to change the color of the Ford object. So I'm going to just use Ford.color, and this time I want to use the color blue here. And let's once again we will try to print the color and speed of the object Ford, and now you can see this result. So before, the speed was 200 and the new speed is 300 for the object Ford, and before the color was red and the new color is blue for this object Ford. Now if you have followed the last video, this speed and color is the data. So speed and color are the variables which holds some data inside them. But still we haven't added any behavior or methods to our class car, and that we will do in the next video. Now let's create a new class, because understanding classes in any language is difficult. So let me give you another example. So this time I'm going to create a new Python class, and I'm going to name this Python class as a rectangle, and then press OK, which is going to create this class. And to create a class, you already know, you use the keyword and the name of the class and then the colon, and we will also make this class an empty class using this pass keyword. And in order to create an instance, I'm going to just write rect1, which is the first object, using the rectangle class, and then I'm going to create rect2, which is the second object, using this rectangle class. And now what are the attributes which we can relate to the rectangle? A rectangle have a width and the height, so let's add the width and height. So let me use the first object, and let's say height is 20 for the rectangle 1, and then we are going to use the second object, and once again we are going to add the height for the second rectangle. Let's say the height of second rectangle is 30. Similarly, we can add the width to the rectangle. So width is equal to, let's say it's 40, and rect2 object have the width, let's say 10. So what we have done here, we have created a rectangle class, and then we have created two instances of the rectangle class, rect1 and rect2, which are also called objects. And then we have added some attributes to our objects, which are height and width. Now let's say you want to calculate the area of these two rectangles. I can use the print method, and then what is the area of the rectangle? It's the multiplication of the height and the width, right? So I can use this rectangle 1 object, and then I can call the height and width of this object, and this will give me the area of the rectangle 1 using this multiplication operator. Similarly, I will do the same for the object 2 here. And let's run the code. And if you remember what we need to do, if we create a new Python file, we need to right click on the file and then click on run, right? So once the file is running, you can choose from here which file you want to run, but at least once you need to right click on the file and just click on run whatever file name you have. So you can see the area of rectangle 1 is 800 and the area of rectangle 2 is 300. So this is how you can create a very simple class in Python. In this video, I'm going to show you how to use init method in Python and how to use a keyword called self in Python. So I will continue with the class which I have created in the last video, and this was the class which we have created, and we have used this special keyword pass there, and pass we were using to create an empty class. Now I'm going to remove this pass and I'm going to add a method called init here. So I'm going to just write def and then underscore underscore init and then press enter, and you can see this init method is created here. So this is like a normal method with double underscore in front and back of this init keyword, and you will also see the self keyword is already added as the first argument of this method. Now this init method serves as a constructor for the class. So usually it is used to initialize some attributes or some functions, because this is the first method which will be called when you create an instance of a class. So here we are creating an instance of a class, and this init method will be the first method which will be called when this object or instance will be created. So let's check what I'm saying. So let's say I want to print inside this init method that the underscore underscore init underscore underscore is called, and let me run this code. So I will change this to car and then run this code, and now when I see this result, you will see this line is called 3 times because we have created 3 instances from the same class. Okay, so every time this instance is created, this print is called, and that's why this line is printed 3 times, and everything else will be printed after that. Whatever we were printing, for example speed or color of the car, will be printed after that. Now one important thing to notice here is I said init serves as a constructor. It's not a constructor. Although it would be tempting to call this init method as a constructor, actually it's not a constructor, but it behaves like a constructor because init is the closest thing we are going to get in Python to a constructor, because it is the first method which is called whenever an instance is created. Now if you are familiar with other object-oriented programming languages like Java and C++, there is a destructor also in those kind of languages with classes. Now Python doesn't have any destructor because Python has an automatic garbage collection. So you don't need a destructor in Python because Python will take care of anything which should be taken care of. Now as I said, usually init method is used to initialize something. So instead of initializing the value of speed and initializing the value of color, let me just comment this code first of all. So I'm going to select whatever I want to comment, and then I can press Ctrl / to comment all the line. You can also go to code and then use this option which says comment with line comment, and you can see the shortcut for that, Ctrl +/. Okay, so this is going to comment your lines of code, and now I want to use the speed as the initialization value. So after this self keyword, I can give the next parameter which is speed here, and then the third parameter is the color here. And now to print the value of speed and color, I can use once again print, and then first of all I'm going to print the speed, and then I'm going to print the color attribute. And as soon as you do this, and when you try to run this program, it will give you an error. So let me run the program and it will give me the error. It says init missing 2 required positional argument, which is speed and color. Okay, so once you create an init method and provide any arguments other than self, self is automatically provided by Python whenever you create an instance of a class. But other than self, when you write for example speed and color arguments here, you need to provide those arguments at the initialization of your class. So here first we will give the speed inside these parentheses, for example 200, and then the color, for example red here. Okay, same we need to do for the other 2 instantiation of the car class. So let me do it for the second instance and also for the third instance. And now let's run the code once again and let's see what happens. So now you can see everything works fine and no error is given to us. And you will also see, because this print is called first, you can see the speed is printed first and then the color, and then this line is printed after that. And that means we will get the speed, color and this line 3 times for every instance with different values, whatever values you have provided for the instantiation of your car class. Now usually you provide these arguments because you want to initialize the value of speed. So let's try to access the value of the Ford object speed and color. So let me just uncomment this code and let's run this code, and it will give us an error. You can see this says that car object has no attribute called speed, right? So what is the error? Because we have provided these attributes speed and color, but we haven't assigned these values to any attribute inside this car class. Earlier what we have done is we have assigned the speed value to a speed attribute and the color value to the color attribute, but we have already commented those codes. So how can we assign the speed and color to the car object? So it turns out that you can use the self keyword, and then using the self keyword you can assign the value to the current object. So self is essentially the current object. Okay, it's similar to using this in C++ or Java if you are familiar with those 2 languages. So you use self dot and then the name of the attribute, for example speed in our case is equal to whatever argument you provide for speed. So we have provided the same argument, which is speed itself. Once again I can use self to set the value of color here. So self.color is equal to color. Let me remove this semicolon because it's not required. And now when I run this code, you will see that there is no error now. So because we have now used the self keyword to set the attributes of speed and color, so we can easily access the values of the speed and color using any object of the car class. So let me once again minimize this. So now let's talk about the self keyword here. So whenever you create a class, the first argument of every method you need to provide this keyword self. Now it's not necessary to provide this same keyword which is self, but it's a convention to write this self as the first parameter. The first parameter can be, for example, ABC. It doesn't matter, but you need to use this ABC here also as self and it will be totally fine. But it's a convention that we use the self keyword in order to indicate that this is the current object. So every method you will create, you need to give this self keyword as the first argument of your method inside a class. Now you may also observe that here when I am initializing this class instance, I'm not providing any self keyword. So even though in the init method I have provided 3 arguments, I'm only providing 2 arguments here. So it turns out that you don't need to provide the first argument, which is self. It will be automatically be provided to your class. So you just need to give the next argument, whatever argument you give after the self. So we have given speed and color after the self argument, so we just need to provide those arguments after whatever you use after this keyword called self. So let's do the same thing with our second class, which is the rectangle class. And here also we have created this empty class. So let's remove this pass keyword, and instead of this pass keyword we will use this init method, which is def underscore underscore init underscore underscore. And here after the self we will provide the height as the second argument and the width as the third argument. Okay, and then we are going to initialize the attributes height and width using this self keyword. So self dot height is equal to height, self dot width is equal to width. Okay, so this is how you can initialize your attribute using this init method. And now when you do this, you don't need to initialize these values like this. You can directly initialize this height and width using these parentheses. So let me provide these values. Let's say 20 and 60 for the first rectangle, and let's say 50 and 40 for the second rectangle. And when we run this code, let me just change the file here and then run the code, and you will see it will print the area once again here. So this init method is used to initialize your attributes or whatever you want to initialize at the start of your class. You will do all those initializations inside this init method. So this is how you can use init method and self keyword in Python. In this video also we will discuss more about init method and the self keyword. So let's get started. So here I have a very simple class called hello, and in this class I have a method called init, and I'm just instantiating this class and creating an object out of this hello class. Now the first question which may arise is, what if I don't want to use this self keyword? You can see directly that there is a red squiggly line appears here, which means an error, and this we can also see when we run the program. So when we run the program, it's going to give us this error which says init takes 0 arguments but given 1. Now you may ask why it's saying that we have given 1 argument to the initialization of this hello class. So as I said in the last video, that self is automatically passed when you initialize a class, and that's why it says that 1 argument is given but init takes 0 argument, because here we haven't given any argument inside these parentheses. So self is absolutely important, so you need to give the self. Now the second question you may ask is, can I create multiple init method inside a class? So let's see if it's possible or not. So here I'm going to give this pass keyword, which means that this init method is an empty method, and let me create a second init method, and this time I want to add one more parameter here, let's say name. Okay, so we have provided 2 init methods here, and let's see what happens. So this is the instantiation of class where I haven't given any argument to this instantiation. So I'm going to run the program, and what it says init missing 1 required positional argument, which is name. So it turns out that it's not possible to provide multiple init methods in your Python class. If you provide multiple init method in your Python class, the init method which you define at last will be considered as the main init method, and other will be overwritten. Okay, so whatever init method you define at last, that signature of init method will be valid, and all the other init method which you will create will be overwritten by the last init method. Okay, so let's provide the argument name here. So I'm going to just provide one argument here and then run this code, and it works perfectly fine. Okay, let me just reverse this order. So instead of using this init at the top, I will use the init which doesn't take any parameter at the bottom now. Okay, and we provide this argument, and let's run the code. And now once again we get the error which says init takes one positional argument but two were provided. So one positional argument means that this init only takes the self argument and nothing else. But here self is provided automatically, but we are providing an extra parameter here which is not required, and that means this init which we have defined later is valid and this previous init is not valid. So always remember, it's not allowed to use multiple init method in the Python class, but if you do this, the last init method will be a valid init method and all the other init method will be the invalid init method. Now one more question you may ask here, what if I want to create both kind of instances, one which takes no argument here and other which takes one argument or multiple arguments here? So the answer is in my previous video, in which I have shown you how to provide default value to your arguments. So let's say I provide a default value to my argument here. Now I will create two instances of the same class. One takes no argument and other takes one argument, and when I run this code, no error appears here. Okay, so if you want to create an init method with multiple parameters, you can either use this default value for your init method parameters, or what you can do here is you can use this parameter which takes a tuple. So in the previous video we have seen that we can provide an argument with asterisk in front of it, and this means that we can provide multiple parameters to our method here, and when we run the code, it's also valid. We can also provide multiple parameters here and it will also be totally valid. So I'm going to run the program once again, and you can see it's totally valid. So if you want to provide multiple parameters to your init method, you can use this kind of notation, or you can provide the default value to your parameter, or the last thing you can use is you can use, for example, this type of argument which takes the keyword, so kw args here. Okay, and this also we have seen whenever you use this kind of notation, that means you want to provide the dictionary, right, key value pair. So let me provide some kind of key value pair. Let's say name is equal to some kind of name here, and then let me run the code, and it's totally valid. It doesn't give us any error. So even though multiple init methods are not allowed in Python, you can use these type of notations in order to give variable length argument in your init method. Now let me just remove all the parameters from here and this instantiation from here also, and let's take the next question. So let's say I want to remove this pass keyword from here, and here I want to initialize some values. So self dot name is equal to, let's say we will provide some name, so I'm going to provide a argument called name, and self dot name is equal to name here, and then let's say self dot age here, and we provide some value which is not taken from the argument, but we provide some static value here. Is it allowed? Yes, it's totally allowed, right? So if you want to provide some default value for your attribute, you can absolutely provide that without even passing it as an argument. So it's not necessary that all the attribute values you need to provide from this argument list. You can provide any default or static value here, which is not coming as an argument. So I hope that clarifies some more details about this init method. In this video, we will learn how to use encapsulation in Python. Encapsulation is one of the most important principles in object-oriented programming. So let's get started. I will be using this car class and the rectangle class, which we have been using in the previous videos also. And let me remove these print statements because we don't want them right now. Now let's say we want to change the value of speed. So if you want to change the value of speed, you can simply take your object, for example Ford dot your attribute name, for example speed, and then you can directly change it, for example 300, and when I run the program, it's going to print the new speed, which is 300. Initially we have set the speed to 200. In here we can also put, let's say, the speed as string, which is very stupid, but will it work? It works, you can see here. And this can break the function in which the speed is used. So therefore it is very important that we protect our data and only give the access to our data to the other users. So encapsulation is particularly important when you want to give your code to some other people because they might want to change your code. So let's see how we can encapsulate our code. So to encapsulate our code, we create functions. So let's create a first function, which is to set the value of speed. So I'm going to just say set underscore speed, and inside the parentheses it's going to take self as the first argument, which is the default, and second is the value of speed. So I can say value here, right? And then once we have the value of speed, we can just call self dot speed is equal to value. Similarly, we can create a get method for the speed. So right now we have created the set method to set the speed, and now we are going to create a get method to get the speed. And in order to get the speed, we don't need to pass any argument. We just need to return this speed, which is already set. So we can just write return and then self dot speed. So we have created two functions, set and get. These are also called setter and getter for the attribute, which is speed in our case. So let's use these functions instead of this kind of setting of data. So first of all, I'm going to call this Ford object dot set speed method out of this object, and then I'm going to pass the new speed using this set method. Now in order to get this speed, I can write, instead of this Ford dot speed, I can just write Ford dot get speed, which is going to give me the speed of this Ford object. So I'm going to run the code, and you can see it prints the speed which we have set using the set method. But still, will this protect your data? Let's see. So I'm going to once again try to use Ford dot speed, and then I will try to set the new value of speed. Will it be a problem? No. So you can see when I try to get the speed, the new speed is set, and we want to prevent this kind of setting of data using this equals to symbol. So we need to somehow make our attribute private. Now if you are familiar with other object-oriented programming languages like Java or C++, they use the keywords like public, private or protected in order to mark their attributes or the member variables as the private or public or protected. But Python doesn't have any of these keywords. So how we can make our data private? So let me give you first of all an example. So I'm going to go to this class, which is hello, and here I'm going to set some values. So first value is, for example, self dot a is equal to 10. Second value is self dot underscore b is equal to 20. And the third value is self dot underscore c is equal to 30. So we have created 3 member variables in this hello class. One is A, second is underscore B, and C is with 2 underscores in front of it. And let's try to access all these 3 values. So I'm going to just use the print method and then the hello object dot A, and similarly I will use this print to get the value of dot underscore B and also dot underscore underscore C. And let's try to run this program and let's see what happens. And you can see here the first value which is printed here is 10, which is the value inside the A variable. So this code was executed successfully. Now we can see here that 20 is also printed. That means this code is also executed successfully. But at the time of underscore underscore C, when we want to use this underscore underscore C outside the class, it says hello object has no attribute called underscore underscore C. And this is the point. So underscore underscore you can use to make your attribute private. Okay, so this is a convention. There is no keywords like private in Python. That's why Python uses this kind of convention in which whenever you use double underscores, it makes your data private. When you use single underscore, that also means that it's a private variable, but this is only a convention. Nothing stops you to change the value of underscore B or accessing the value of underscore B. Okay, so if you truly want to make your data private, then use double underscore in front of your variable. When you use single underscore, that means it's a partially private variable and it's only a convention. Okay, so let's go to our car class once again, and now we know that we can add double underscore in front of our variable name. So we have 2 variables here. One is speed, so let's add double underscore in front of speed, and also let's add double underscore in front of this color variable to make both of them private. So I'm going to change this value of speed in getter and setter also. And now let's try to access this value using this Ford object, which is underscore underscore speed. Now let's try to run our program. So I'm going to change the file and then run our program, and you will see that it's going to give us an error. And this error says the car object has no attribute called color, because this variable color is private now. Also, you will observe that the value of the speed is 300, which is set by this set function. Even though we have set the speed again to 400 using this underscore underscore speed, but this speed is not changed, right? So we cannot change the speed using this underscore underscore variable, because now it's a private variable, and that means we cannot change the value using this variable. We need to use this set function in order to change the value of the speed. Also, if you want to use this underscore underscore color here, and let's run the code, this will also give you an error because this underscore underscore color is private. So either you can remove this code, or you can create the setter and getter method for the color also. So let's create the setter and getter method for the color. And now we can access the value of color using the get color method, right? So instead of this get speed, we can just write Ford.get color, and it's going to give us the value of color. And now you can see that there is no error, and the speed here is 300, which we have set using this set speed method, and the color is red, which is the color we have given using this argument in the constructor. And this type of restricting your data access using functions is called encapsulation. Let's do the same thing with our rectangle class also, and let's create the setter and getter method inside the rectangle class. So you already know we can use this define, and then we can first of all set, for example, set the height first of all, and then we can give the value of height here, and then self dot height is equal to height, right? And don't forget, you need to give double underscore in front of your attributes in order to make them private. So I'm going to do just that, and let's create the get height method also. So now we have created the setter and getter for the height, and let's do the same for the width also. So now you have made the height and width as private, and we have created setter and getter for the height and width. And now in order to calculate the area, we can define one more method here, which is the area method. So let's create the area method here, and this area method is not going to take any argument. We are just going to return the multiplication of the height. So self dot height multiplied by self dot underscore underscore width, okay, which will give us the area of this rectangle. And we can call this area method instead of using this kind of notation. So rect1 dot area and rect2 dot area also. And let's run the code by changing the file name here and run this code, and you can see the area is printed now. So this is how you can use encapsulation in Python. In the last video, we have seen how to use encapsulation in Python. And we have also seen how we can declare private member variables in Python. To declare a private member variable, we use double underscore in front of your variable name, and this variable becomes private. But the question is, what exactly is a private member variable? So a private member variable is private to the class. That means you can use this private member variable inside the class, but as soon as you use it or access it outside the class, it will give you an error. So you cannot access a private member variable outside a class. And the example we have already seen. So here you can see I try to access this private member variable outside the class, and when I run the code, it says that there is no underscore underscore c attribute for this hello object. Why? Because whenever you create an instance, and if the member variable is private, this private member variable is invisible to your object. So you cannot access the private member variable outside the class. But can we use this private member variable inside the class? Let's see. So I'm going to declare one more method here, and I'm going to name it as public underscore method. And this doesn't take any argument, but what we have learned about the methods in a class, that even though you don't pass any argument to the method, you have to provide at least one argument, which is the self argument. And what is self? Self is the current object. So let me just print something here quickly. For example, public here. So can we use this private member variable inside this method? Let's see. So I'm going to just write self dot underscore underscore c, and then I'm going to run this code. And let me comment this line because this was giving us an error, and instead we can use this public method. So I can use an instance of hello, which is hello dot public method, and let's run the code now, and you can see there is no error. That means you can use your private member variables inside the class or any method of the class. Now the other question is, what is a public member variable like a here? So a is a public member variable because it doesn't contain any underscore underscore in front of it, and that means you can use this public member variable inside the class as well as outside the class. So if I want to use this public member variable inside the class also, I can just use self.a and then run the code, and it's totally fine. It doesn't give us any error. Let's print the value of those two member variables and once again run the code, and it will print the value of A and C and then this message which we are printing here, which is public here. Now the next question is how we can define a private method in the class. So let's see how we can define a private method. You already know most probably, which is by using double underscore in front of your method name. So for example, underscore underscore private underscore method, and then I'm going to just print something inside this method. Let's say private. So this is a private method. And how you can define a private method? Using these double underscore in front of the name of your private method, and the restriction will be the same on the private methods also. So let's try to access this private method outside the class. So I have this hello instance, and when I press dot here, you will see there is no suggestion for this private method because PyCharm already know that this is a private method, so it doesn't show this method in the suggestion when you use this object outside the class. But let's try the brute force and let's try to use this method outside the class, and when I run this code, you will see once again you will get an error which says hello object has no attribute underscore underscore private method. So private methods also you cannot use outside the class, but inside the class absolutely you can use your private methods. So how to use your private methods inside the class? So you can use your private method inside the class using once again a self keyword. So you write self dot and then your method name, for example private method, and that's how you can call your private method inside the class using self. So any method you want to call inside a class, you do it once again using this self keyword as you do with your member variable. And once again when I run the code, now it prints private using this statement, and this statement is executed when we call this private method from here. So I hope this video will clarify some more doubts about the private member variables and private methods in Python. In this video, we will talk about Python inheritance. So first of all, what is inheritance in Python? So classes in Python can be extended, creating new classes which retains the characteristics of a base class. And this process is known as inheritance. Now in simple words, the idea behind inheritance is that a new class can borrow the behaviors and methods from the another class. Now the inheritance involves two types of classes. One is a superclass and other is a subclass. Now the subclass inherit members of the superclass on top of which it can add its own members, for example any other member methods or variables. So here subclass is the one who is doing the borrowing of the members, and the superclass is one from which subclasses borrows these kind of member methods and variables. Now if this inheritance sounds to be a little bit confusing to you, let me give you an example. So I said in inheritance there are two types of classes. One is a superclass and other is a subclass. Now in this example, I have taken polygon as a superclass and two classes, rectangle and triangle, as the subclasses. Now if you see carefully, what is the relationship between rectangle and polygon and triangle and polygon? So rectangle is a polygon, right? And the triangle is also a polygon. That means the rectangle can inherit some properties from the polygon class. Also, triangle can inherit some properties from the polygon class. And the relationship between the superclass and the subclass is defined by a relationship called is-are relationship. So rectangle is a polygon and triangle is a polygon also. That means that rectangle and triangle can inherit from the polygon class. So in inheritance, the subclasses have a is-are relationship with the superclasses. So let me give you one more example. So as a superclass, you can take an animal class, and then as subclasses you can create a dog class, cat class, rat class, because all of them are animals. So dog is an animal, cat is an animal, rat is an animal. So always remember, when you use inheritance, there is a is-are relationship between superclass and the subclass. Now let's take a real life example and let me try to explain you this concept with some code. So I'm going to create a new project in my PyCharm IDE, and this I'm going to name it as inheritance, and I will choose this option, open in current window, and also this option which says add to the current opened project, which is going to create the project in the same window. So now this project is created. So I'm going to go inside this project and I'm going to create a new Python file here, and I'm going to name this file as polygon, because we are going to create a polygon class. And inside this polygon.py file, let's first create a class called polygon, and inside this polygon class, what are the attributes which we want to add here? So rectangle and triangle, what are the common things which they both have? They both have the width and the height. So we are going to first of all create a variable called width, and we will initialize it by a value none. The none keyword is used whenever you want to assign nothing to your variables, right? In the same way, I'm going to use height and I'm going to assign none to that also. Now what I'm going to do is I'm going to create a method here. So let me define a method using def, and I'm going to use this method to set the values of width and heights. And this method is going to take two arguments. One is the width and the other is the height, right? Now if you remember, in the last video I have shown you how to make your variable private. So you use double underscore in front of your variables to make them private. So I'm going to add this double underscore in front of width and height. That means these two variables are private. Now using this set values method, I'm going to just set the values of the height and width. So self dot underscore underscore width is equal to width, and self dot underscore underscore height is equal to height. So this is the polygon class which we have created, and it's a super class in our case, right? And now let's define two subclasses. One is a rectangle and other is a triangle. So let's define other class called rectangle, and inside this rectangle I'm going to define one method. Let's say this method is a area method, and this area method is going to give us the area of the rectangle. And what is the area of the rectangle? The area of the rectangle is the multiplication of the width and the height. Similarly, I'm going to define a triangle class also. So let me define the triangle class here. And let's say this triangle class also have this method which is area. Now what is the area of a triangle? The area of the triangle is the multiplication of width and height divided by 2. So we are going to divide the multiplication of width and height by 2. This is the area of the triangle. So now we have defined three different classes, and we are saying that polygon is the superclass and rectangle and triangle is our subclasses. Now, how we can inherit the properties of the superclass, which is polygon, into our subclasses, which is rectangle and triangle. So in order to inherit from one class to another, you use this parenthesis, and inside the parenthesis you write the name of your superclass, and that means your rectangle is inheriting from the polygon class. Similarly, when we write this parenthesis and the polygon class here, that means triangle is inheriting from the polygon class. Now, when a subclass inherits from a superclass, the superclass member variables and methods are accessible also using the subclass also. So let me give you an example. So I'm going to create the instance of rectangle first of all. So let me just write rectangle. So this is the rectangle instance, and let's create a triangle instance also. And now once we have triangle and rectangle instance, let's use this rectangle instance, and when you write dot here, you can see IntelliSense says that area is available for this object and set value is available for this object. So when you use set value, you can see we haven't defined the set value method inside the rectangle, but because we are inheriting from the polygon class into a rectangle class, all the members of the polygon class are available using the rectangle object also. And what this method takes, it takes the width and height. So we are going to provide the width and let's say height 50 and 40, and once again we are going to use the triangle object and we use the set values, and this time also let's say I'm going to provide the same values here. And what does this set value method is doing? It's just setting the values of width and height inside the polygon class. Now in order to calculate the area, we can call the area method from the rectangle and the triangle class. So let's just do that, and I'm going to do this inside a print method, and I'm going to just call the rectangle object dot area, which doesn't take any argument, and same I'm going to do for the triangle object also. So triangle dot area. So what do you think will happen now? So let's run the code and let's see what will happen. So I'm going to right click on this file and I'm going to just choose run a polygon, and it's going to run the program, and you will see it gives us an error. And what is the error? The rectangle object has no attribute rectangle underscore underscore width. That means because this width and height are private member variables of the polygon class, they are not accessible from the subclass, which is the rectangle class and the triangle class. So you cannot inherit the private members from the superclass into the subclass. So what is the solution here? So what we can do here is we can create the getter methods for the width and the height. So I'm going to do exactly that. So let's define a method called def get underscore width, and it's going to take no argument, and it's going to return the value of the width. So using self, we can access the value of underscore underscore width. In the same way, we can define a method called get underscore height here, and it's also not going to take any argument, but we are going to return the value of the height here. So self dot underscore underscore height. So now we have created the getter methods for the width and height, and these getter methods are the public members. Why they are public? Because we haven't used the double underscore in front of these two methods, and these two methods now we can use in place of these private member variables which we were trying to inherit in the subclass using the superclass. So instead of underscore underscore width, we can write self dot get width, and also here instead of underscore underscore height, we can use get height. Similarly, we will do the same for the triangle class. So get width and the get height dot get height. Now let's run the program again and let's see what happens. And now when I run the code, it gives me the area of rectangle using this print line statement, and then it's going to give me the area of triangle, which is exactly the half, using this line of statement. So let me once again minimize this and let's recap what we have learned. So we have created a superclass and two subclasses. Superclass is polygon and subclasses are rectangle and triangle. And in order to inherit from the superclass, you just use parentheses and the name of your superclass. And that means in our example, rectangle is inheriting from the polygon class. Next, what we have learned is all the public member variables or the methods are accessible from the subclass from the superclass. So set value method and get value method is accessible because they are public methods, but underscore underscore width and underscore underscore height are not accessible because they are the private member variables. So you cannot inherit the private member variables into your subclasses. Now we have seen this example in which we have created two instances of the classes. One is rectangle object from the rectangle class and the other is triangle object from the triangle class. And first of all, we have used the set method, which is coming from the polygon class. It's not the part of the rectangle or the triangle class, to set the values of width and height. And then we have just called the area method from these two classes in order to give us the area. So this set method is used to set the value. So it has set the value of width and height, and using this get method, get width and get height, this value is returned and this value is returned into the subclasses, and then the multiplication of these two values gives us the area here, and the multiplication of these values divided by 2 gives the area of the triangle here. So this is how you can use inheritance in Python. Hey guys, welcome to the next video on Python tutorial for beginners. In this video, we will discuss how to create modules in Python. Now, in the previous videos, I have already discussed briefly about built-in modules and how to import a built-in module. You use an import keyword and then you use the name of the built-in module in Python. Built-in means this module is already present in Python. So we can use these built-in module in order to perform some functionality. So for example, this math module helps us to perform some mathematical operations. Now, first of all, what is a module? So it turns out that a module is nothing but a Python file. Now, to prove my point, let me just hover over this math module and just press Control and then hover over it. So right now I'm pressing Control and I'm hovering my mouse over this math on the PyCharm IDE, and now I'm going to click it. And when I click it, you will see this module is nothing but a file, right? And inside this module, we have a number of functions which we can use. For example, a cos function or a tan function or many different functions which we can use from this math module. So a module is nothing but a Python file. Now, if a module is nothing but a Python file, why don't we create a module? And it turns out that Python allows us to create our own modules. So let's create our own modules and let me show you how you can create your own module. And right now you can see in my project there is only one file, which is hello.py, and it's empty right now. Now to create a module, I'm going to just create a new file. So right click and then new Python file, and this module I'm going to name it as my functions, and then press OK, and this file is created. So now I have two files in my project. One is my functions and other is hello.py. So let's say I want to create some functions inside this my functions.py file. So let's create some function. I'm going to very quickly create some very basic functions which you already know in Python. So let's say a add function which returns the addition of two numbers, and also let's create, let's say, a multiply function. So multiply, and this is going to just give the product of two numbers. So let's say this is our module and it has two functions. Now somehow I need to use these two functions from my functions.py file into this hello.py file. Now as you can see, these two files are in the same directory, right? So I can import this my functions file using import and then the name of the file, which is my functions, and that's it. So in order to import a module, you just write a keyword called import and then you just write the name of the file without the extension py. Okay, so you don't need to provide any extension here, and then I can use this function. So let's say I want to print my function, which is the file name. So whatever file name you give here, you need to use the file name here. Dot, you will see all the functions in the file are now visible in the other file, which is hello.py. So let's use this add function, and I'm going to just give two parameters here. And also let's use the multiply function from the my functions file. So the file name and the method name or the function name, and let's give two parameters here also, and that's it. So it's that simple to create your own modules and import them into other files in Python. Now when I run this program, it's going to give me the addition and the product of these two arguments which I have provided here. Now let's say your my functions file is in some other directory. So let me create a directory. So I'm going to right click here and then I'm going to create a directory, and I'm going to name it as dir and then click OK. And now I'm going to move this my functions.py file into the new directory. So I'm going to just right click and cut from here this file, and I'm going to just paste this file into the dir directory. Okay, so let me just click OK here. And as soon as I do this, you will see here PyCharm is intelligent enough to refactor this code, and now it has given us the correct import. Okay, so if this my functions file is in some directory, then you use this type of notation. So you write from and then your directory name and then import keyword and then your file name. So you can see this is the directory name and this is the file name. So I use from directory name import file name, and when I run the code once again, it's going to give me the same answer. Now there is one more way of writing the same notation, and that is using the import. So use import keyword and then write the name of your directory dot the name of your file. So directory dot the file name, and then you use this name in place of your my function name. Okay, and once again when you run the code, it runs fine. Now sometimes you might feel that this is a long name, and Python have the solution for it also. So it turns out that you can rename your file using a keyword called as. So after the import, so import directory name dot file name as, and then you can provide your name. For example, my functions, I will just name it as mf. Okay, and now I can use this mf name instead of this big name, and this will also work fine. So either you can import from your file which is inside the directory using this notation, or you can use this notation. You can also write as in front of this notation also. So from directory name, import file name as whatever name you want to give here, and this you can use to call your function using this dot notation. Now this was the easy stuff, and I have just written here the two functions and then imported these two functions into the other file. But what if I have multiple classes? I haven't shown you how to import files which have classes in them. So let's see how to import the Python files which have classes inside them. So I'm going to close these two files, and in the last video I have shown you how to use inheritance in Python, and we have created this class polygon and two other classes, which is triangle and the rectangle class, and this might be right now the perfect candidate to import into some other file. So I'm going to create two more files. One is the rectangle file. So I'm going to just right click and create a Python file, and I'm going to name it as rectangle. And I'm going to create one more file with the name of triangle. So right click, new Python file, and the name is triangle.py. And let me create the fourth file, which I'm going to name it as main, and this will be our main file in which we will import all these classes. So in my polygon class, I will just leave this polygon class, and I will just transfer this rectangle class into the rectangle.py file, and this triangle class into triangle.py file. And also this was the instantiation of the rectangle and triangle class which we have done. So I will transfer this code into our main.py file. Okay, so now we have a polygon.py file in which we have the polygon class, and then we have the rectangle class inside rectangle.py, and also we have the triangle class into the triangle.py file, and rest of the code we have inside the main.py. Now when you go to the rectangle.py, you will see that it's inheriting from the polygon class. That means we need to import polygon class into the rectangle.py file. So how to import it? You can use from and then the file name, which is polygon, and then use import keyword and use the name of the class, which is polygon, and you will see that this error is gone. And same we will do inside the triangle.py file in order to import the polygon class into the triangle.py file. So this is the file name. So from file name, import the class name. Now when I go to the polygon class, we don't need to import anything here because it's a super class and there is no import needed here. Let's go to the main.py file, and here you will see red squiggly line under rectangle and triangle class because we haven't imported this triangle.py and the rectangle.py into our main.python file. So the procedure is same. From your file name, which is first of all rectangle, import the name of the class, which is rectangle. Same we will do for the triangle class. So from the triangle file name, triangle.py, and then import and then the name of the triangle class. And you will see as soon as you do this, the error is gone. So now there is no red squiggly line under any of the code. So now let's run the code. So I'm going to just go to the main.py file, and I'm going to right click on this main.py file, and I'm going to just click on run main, which is going to run the program, and it's going to print the result, which is the area of rectangle and the area of the triangle. So in this way you can import the py file which have classes inside them. So this is how you create your own modules in Python and import them into other Python files. In this video we will talk about multiple inheritance in Python. So first of all, what is multiple inheritance? So the ability of a class to inherit from more than one class is called multiple inheritance. And in Python, a class can inherit from more than one class. So let's see an example which shows us how to inherit from multiple classes. Now I will be using this example which I have already shown you in the video where I have shown you inheritance in Python. So there is a class called polygon which is a superclass, and the other two classes are triangle class and the rectangle class, which are the subclasses, and these two classes are inheriting from the polygon class. And I have also one more Python file which is main.py, and in this main.py I'm just importing these two rectangle and triangle class and creating an instance out of them, and then setting the value of width and height, and then we are printing the area of the rectangle and the triangle. So if you haven't seen the last two videos, just watch those videos because I will be using the same code in order to show you how to use multiple inheritance. So let's get started. So what I'm going to do is I'm going to create a new Python file here, and I'm going to name my file as shape, and I'm going to use this shape.py to create a class called shape. So let me create a class quickly, and I'm going to name it as shape, and this method I'm going to define a private variable called color, and I'm going to initialize it with the value none, and then I'm going to define the setter and getter for this color attribute. So let's define those. So now we have defined the setter and getter for this color attribute. Now if you remember what I told you about inheritance, and that is whenever you want to do inheritance between a superclass and a subclass, there is a relationship between the subclass and the superclass. So rectangle is a shape and triangle is also a shape. So that means we can also use this shape class as the superclass in rectangle and the triangle classes. So let's use the shape class into the rectangle and triangle class as the superclass. So first of all, I'm going to import this shape class from the shape file. So let's import this, and same I will do in the triangle class also. And now how to inherit from multiple classes into our subclasses. So we have already inherited from the polygon class, and in order to add one more class here, you just need a comma separator and the name of your class. So this is how you inherit from multiple classes. You just use the parenthesis and then the name of your classes separated by the comma. That means the triangle class is inheriting from the polygon class as well as the shape class. The same we will do in the rectangle class. So I will just provide the comma here, and then I will just write shape here. And now I will go to the main.py file, and once you do the multiple inheritance, that means all the public methods of the shape class is available in the subclasses, which are triangle and the rectangle. So I can use this kind of notation. First of all, I'm going to use rectangle class to call the method called setColor. So I'm going to set color from here, and let's say the rectangle color is red, and then I'm going to use the triangle object to call the setColor method once again, and the color I want to provide here is, let's say, blue. Okay, and in order to get those two color values, we can once again write print the instance name, which is rectangle dot get color, and same we will do for the triangle object also. So print triangle dot get color, and that's it. So now all the public method of the shape class is also available in our rectangle and the triangle classes, and we can use all the public methods of this shape class into the subclasses. And let's run the code and let's see what happens. So the code is running and you can see it prints red and blue using these two statements. So this is how you can do multiple inheritance in Python. In this video, I'm going to show you how you can use a built-in function called super in your Python classes. So let's get started. So to start with, I have two classes here. One is the parent class and other is the child class. And here parent class acts like a super class and the child class acts like a subclass which is inheriting from the parent class. Now both these classes have this init function, and you already know what does this init function do. It is the first function which is called when an instance of a class is created. And here I'm just creating the object from the child class. Now what do you think will happen? Will this constructor will be called or this constructor will be called, because we are inheriting from the parent class into the child class? So let's find out. So I'm going to run this code and it prints child init. That means this statement under the child class init method is executed and this method is not executed. Now in some cases you might want to pass some parameters also into your super class. For example, I'm just going to give this example. Let's say I want to pass an argument called name here, and then I will just print the value of name. How can I call this init function using this child class instance? So it turns out that there is a function called super in Python that allows us to refer to the super class implicitly. Now this super function is a built-in function which returns a proxy object that allows you to refer to your super class. So let's try to use this super function. So you just use the keyword super and then give these parentheses because this is a function, and then this super function will return the proxy object of the super class. That means I can use this dot operator to call the init method from the super class. So this notation means super.init means we are calling the init method from the parent class, and that means we can pass the name from here. So let's just pass this name. I'm going to just write Max here, and now I'm going to run this code. And now you will see that child init is printed using this statement first of all, and then using the super function the init method of the parent class is called, and then this name is passed here and it prints parent init and the name, whatever name we have provided here. So this super function allows us to refer to the super class. Now let me show you one more thing which is called the method resolution order, and you can find this method resolution order by using your class name. So child class name dot underscore underscore MRO. So just write underscore underscore MRO underscore underscore, and this statement I'm going to use inside the print function so we can see the result what it returns. So I'm going to run the code now, and you can see it returns this kind of order. So as the name suggests, MRO stands for method resolution order, and this is the order in which the methods are called inside your child class or the parent class. And this order means that all the method in the child class will be executed first, and then all the method in the parent class will be executed. Now there are some rules based upon which this order is calculated, and these rules are, the first rule is the method inside your subclass are always called first, and then whatever the method inside the base class, they will be called. And the second rule is related to multiple inheritance. So let me just create the second parent class, and I'm going to name it as parent2, and here also I'm going to just write parent2 here, and let me inherit from the parent2 also in the child class, right? And let's run the code once again, and now you will see this order. So once again, child is printed, and then the parent, and then parent2, and then the object. So the second thing on which the MRO depends upon is the order in which you inherit from the parent class or the superclass. So in our example, we were inheriting from the parent class first of all, and then parent2. And in the same order, this MRO also will be decided. So all the method in the child class will be executed first, and then all the methods inside the parent class, whatever you use first here, will be executed, and then whatever superclass you write after that, those method inside the class or superclass will be executed next, and then at last this is the base object. Now let's try to just reverse this order, and once again let's run the code, and you will see that this order will be reversed. So the method resolution order will tell you which class method will be executed first, and then the order of all the methods from the superclasses. Now one more interesting thing which you will observe here is this output. So I said that this super function is used to refer to the superclass, and now we have two superclasses, that means multiple inheritance, and you will see here that only one output is printed, which is from the init method inside the parent2, and this statement is not printed, which is inside the init method inside the parent class. So how to solve this problem? So if you have multiple inheritance, then you need to manually call these init function using the class name. So let's say I want to call the init function first of all from the parent2 class. I will use parent2 dot init, and then you need to give also the self as the first parameter, and the second, which is the name. In the same way, you use the second class, which is parent dot init function, and then first parameter is the self, and then you can pass any other name, for example Tom here, and let me run the code, and you will see it calls first of all parent2 init function, and we have passed Max here as the name, and then it calls the parent1 init function with the name Tom, which is printed here also. So this is how you can use super function in Python. In this video, I'm going to show you what is composition and how to use class composition in Python. So to start with, I have two classes here. One is an employee class and other is the salary class. Now in the salary class, I have this init method which takes two arguments, pay and bonus, and it sets these two arguments to the member variables of this class. Also, I have a method called annual salary which is used to calculate the salary. Now in the employee class, I have this constructor which takes four arguments, which is name, age, pay and bonus. Now what do you think? Can we apply inheritance here? The answer is no, because there is no is-are relationship between salary and employee. So employee is not a salary and salary is not an employee. But somehow I want to delegate the responsibility of calculating the employee's salary to the salary class, because calculating salary is in itself is a big task. I have just simplified this class in the form of just calculating the annual salary, but the employee can have his own taxes, or he has taken some leaves, or many factors affects the salary of an employee. So this salary calculation, let's say we want to delegate to the salary class, but whose salary is this? This salary is the employee's salary. So we know that we cannot use inheritance here, but we can use a concept called composition here. And the composition means that we are just delegating some responsibility from one class to the another class. So how to delegate this responsibility? We can just create one more variable here. For example, self.obj underscore salary, which is the salary object we are going to create using the salary class. Okay, and this salary class takes two parameters. One is pay and other is bonus, which we are already providing using the employee init method. So I'm going to just pass this pay comma the bonus into the salary class. So we are instantiating the salary class inside the employee class. So here one class, which is an employee class, acts like a container of the other class, which acts like a content. Okay, so salary class is the content and the employee class is the container of this salary class. Now in order to calculate the total salary, we can define one more method here, and I'm going to just say total underscore salary, and then what we are going to do is we are going to call our object salary member variable, because this gives us the object of the salary. So I'm going to just call object salary, and we can call this method from the salary class, which gives us the annual salary. And now I'm going to just create the object of this employee class. So let me just write emp is equal to employee, which takes four parameters. First is name, second is the age, third is the pay. So let's say pay is 15,000 and the bonus is 10,000. And now I just want to print the total salary of this employee. So I can just write print and then emp object dot the total salary, which is total salary method. And you can see here this total salary is returning. Let me just use the return keyword also, because we are returning this annual salary from the salary class using this total salary method. So let's run the code once again and let's see what happens. And you can see annual salary is printed, and this annual salary is calculated using the salary class. So what this employee class has done, it has delegated some responsibility to the other class, which is the salary class, which gives us the annual salary of an employee. And this here is called composition. Now one interesting thing which you will notice here is we are not instantiating salary here. We are just instantiating the salary inside an employee class. So as soon as you delete an instance of an employee, the salary class instance will be automatically deleted. So whenever you want to delegate some responsibility of one class to the another class, it's called composition. One more example of composition can be a book class and a chapter class. So a chapter is not a book and book is not a chapter, but we can delegate some responsibility from a book class to the chapter class. So this is how you can use composition in Python. In the last video, we have seen how to use composition between classes in Python. In this video, I'm going to show you how to use class aggregation between classes in Python. Now, if you haven't watched my last video in which I have shown you how to use class composition in Python, I will highly recommend you to watch that video, because I will be using the same code to demonstrate how aggregation works in Python. So in the last video, we have created two classes. One is an employee class and the other is the salary class. And then we have used the salary class inside the employee class, and we have seen how composition works in Python. So employee class is delegating some part of its responsibility to the salary class, and that is called the composition. Now in composition, the relationship between the classes which have some association is represented by a keyword part of. So salary is the part of employee. So the keyword we use in composition is part of. Now let's see how we can use aggregation instead of composition between these two classes. So let's say I will not use this salary class inside the employee class, but what I'm going to do is I'm going to pass an instance of salary here. So I'm going to just write salary, and this will be the object of salary class which I'm going to pass in the init method of the employee class. So let's create an object of the salary. So I'm going to just write salary here is equal to the salary class, and we will instantiate the salary class by these two arguments which we have given in the last video to the employee class. So I'm going to just copy these two arguments and paste it here, and I'm going to remove this comma here. So now what we are doing here is we are first of all instantiating the salary class, and now this salary class we can pass to the constructor of the employee class, and this is the object which we have passed using the salary class object. And then I'm going to take this salary class object and I'm going to assign this salary class object to the member variable of the employee class, which is obj_salary. Now because we are passing the salary object, that means this member variable is the salary member object, and we can call any public method from the salary class using this member variable now. So let's run the code and let's see what happens. And we get the same result as we have seen in the last video in the composition example. So what we have done differently here. So instead of using this salary class inside the employee class, we have first created an instance of the salary class, and then we have passed this instance to the employee constructor, which can be used inside the employee class. And this type of relationship is called aggregation. Now let's see what are the special properties of the aggregation. The first property is the relationship between the associated classes in aggregation is defined by the keyword has a. So employee has a salary, because now we are first of all creating the salary object and then passing it to the employee. So now we are not directly using salary inside the employee class. The second property of aggregation is the associated classes have unidirectional association. So we are just passing salary object to the employee class. We are not passing employee object to the salary class. So it's a unidirectional association. Only salary can be passed to employee, not the other way around. And the third property of aggregation is we have created the salary object and the employee object. So both these objects are independent of each other. So if one object dies, the other survives. So both the objects are able to survive individually. So these are the three properties of aggregation. Now let's see the difference between the composition and the aggregation. So I'm going to split the screen. So I'm going to just right click on this tab and I will say split vertically. And here I'm going to open the example of the composition. So on the right hand side I have the example of composition, and on the left hand side I have the example of aggregation. Let me just maximize this so you can see it. And now let's discuss about the differences between the composition and aggregation. So the relationship in composition is defined by a keyword called part of. So salary is the part of employee. In aggregation, there is no part of relationship, but the relationship is defined by the keyword called has a. So now in aggregation, we are defining the instance of salary and then passing it to the employee class, and salary is not the part of the employee class. We are just passing it to the employee class. So aggregation, we use has our relationship, and in composition we use part of relationship. The second difference is when you delete the employee object, the salary object will be automatically be deleted. So salary object is dependent on the employee class. But in aggregation, the salary object and the employee object are individually independent. So they can survive individually. If one object dies, then it doesn't matter that the other object dies, because we have created these objects individually. Now in composition, both salary and employee are interdependent on each other. But in aggregation, the relationship is unidirectional. So the association between the employee and the salary object is unidirectional. We can only pass the salary to the employee class, but we cannot pass the employee object to the salary class. So these are the three major differences between composition and the aggregation. In this video, we will talk about creating abstract classes in Python. So let's get started. So to start with, I have here two classes. One is a shape class and other is a square class. In shape class, I have two empty methods. One is area and other is perimeter. And I'm using shape as a superclass and square as a subclass, and square class is inheriting from the shape class. Now in this example, I want to do two things. One is I don't want to allow the other users to create an instance of a shape class, because shape class acts like a template for the square class. So I don't want to allow the users to create an instance of this shape class. So let's see right now if we can create an instance of this shape class or not. So I'm going to just write shape is equal to shape, and when I run the code, my code runs fine. That means right now I'm able to create an instance of the shape class, which I don't want. The second thing is I want to make sure that both these methods which are there inside the shape class are implemented inside the square class. So I want to make sure that whoever is using this shape class, he or she must implement these two methods inside the subclass. So how can I achieve these two things? Now it turns out that abstract classes are just made for that. So how to create an abstract class in Python? The fact is, Python on its own doesn't provide any abstract class. But don't worry, there is a built-in module in Python which we can use to create an abstract class. So let's import this built-in module first. So I'm going to just write from ABC import capital ABC, comma, abstract method. So these are the two things we need to import from this module. Now this module ABC stands for abstract base classes, and this allows us to create the abstract classes. So how we can create an abstract class using this ABC module? So what we need to do here is we need to inherit from the ABC module into the shape class. Okay, so shape class is inheriting from the ABC module. Now once this shape class inherit from the ABC module, the second thing what we need to do here is we need to add a decorator here. And how to add a decorator? We just need to use @ and then the name of this abstract method, which is like this. And let me use this abstract method decorator on top of this perimeter method also. So what this abstract method decorator does is it makes these two methods abstract. And what is an abstract method? An abstract method is a method which you must implement in the subclass. So when you run the code now, it will give us this error which says can't instantiate abstract class shape with the abstract method. So once you create any of your class method as abstract, then your class becomes the abstract class, and then you cannot instantiate this class like this. So our first goal is achieved, that we cannot instantiate this shape class now because this class is now an abstract class. And how to create an abstract class? You just need to import the ABC module, and then you just need to add this decorator on top of your method. And if you do this even with one method in your class, then your class becomes abstract. So now we have removed the instantiation of this shape class, but now when I try to instantiate this square object from the square class, let's see what happens. So this square class takes one argument, which is the side of the square, and let me run this code, and once again it gives us an error, and this error says can't instantiate abstract class square with abstract methods. So that means that whenever you inherit from a class which is an abstract class, and if this class contain any abstract methods, then the subclass have to implement the methods which are abstract. So this method area is an abstract method, and this method parameter is also an abstract method. That means we have to provide the implementation of these two methods inside our subclass. So I'm going to provide the implementation of area first of all into the subclass, and area I'm going to just return as the multiplication of the sides, right? So self dot underscore underscore side multiplied by itself, so self dot underscore underscore side. And let's say for now I will remove this abstract decorator from the parameter method, and let's run the code once again, and you can see it runs fine. So there is no error when we instantiate this class when we implement all the abstract method into your subclass. So right now there is only one abstract method, which is area into the shape class, which we need to implement in the subclass, and that we have done, so we see no error here. Now let's add this decorator abstract method on top of this parameter method also, and once again when I run the code, it will give me once again this error, and it's going to give me the same error which says can't instantiate the abstract class square with the abstract method parameter. So we also need now to implement this method also. So let's just implement this parameter method inside the subclass once again. And what is the parameter? It's 4 times the size of your square. So self dot underscore underscore size, and now we have implemented both of them, and once again when we run the code, it runs fine. Let's also try to print the area and parameter of the square. So I'm going to just use this object to call the area method, and in the next line I'm going to just use print to once again call this object, and this time I will call the parameter method. And let's run the code once again, and it prints the area of the square and the perimeter of this square. So let's rewind what we have learned till now. So in Python, you can define an abstract class by importing this module and this abstract method, and this ABC stands for abstract base classes, and you need to inherit from this ABC into the class which you want to make abstract. The second thing which you need to do is you need to provide this decorator @abstract method on top of at least one of the methods inside your abstract class that makes your class abstract. And what are the properties of the abstract class? You cannot instantiate an abstract class, so you cannot create an object of this abstract class, and you need to implement all the abstract method into the subclass which is inheriting the abstract class. So this abstract class acts like just a template for other classes which wants to inherit from this shape class. So this is how you can use abstract classes in Python. In this video, we will learn how to use exception handling in Python. So first of all, what are exceptions? So an exception is an event which occurs during the execution of a program that disrupts the normal flow of the program. So basically, exception is an unexpected event which disrupts the normal flow of the program. So let me show you some examples of exceptions which may occur during the execution of a program. So to start with, I'm going to open the PyCharm Python console, and then I'm going to maximize this PyCharm Python control. And let me also just clear this terminal. So we will start from the top. So let's say we have a number and we divide this number by 0. And when we press enter, it's going to give us this exception which says 0 division error. So this 0 division error is an exception when you divide anything by 0 in Python. Let me show you some more examples. So let's say I want to add a number and a string. Let's say 10 plus 10, but this 10 is an integer and this 10 is a string. And when I run the command, it says type error, unsupported operand types for int and string. So we cannot add a number and a string in Python. So this type error is another kind of exception. Let's say I'm going to just use a variable name ABC which I haven't declared till now. And when I press enter, it's going to once again give me this exception which says name error. Name ABC is not defined, which is true because we haven't defined the name ABC, but we are calling this variable which we haven't defined. So we get this exception which says name error. Next, let me define a variable and I'm going to assign some tuple values here, 1 and 2. And now what I want to do is I want to call some methods. So you can see some methods are available for this tuple. Now let's call some random method using this tuple variable. It will give us an error which says attribute error. Tuple object has no attribute, whatever attribute I have provided here. So this attribute is not present in the tuple object. Also, when you call our method, let me call some other method which is not there, and once again when I press enter, once again I get this error which says attribute error because this function is not present in the tuple object. So these are all exceptions in Python. Attribute error or name error or type error or 0 division error, all are exceptions in Python. Now if you want to see more exceptions, you can use the help inbuilt method and then you can write built-ins and then press enter. It gives me the name error once again because I need to first of all import this built-in module. So import built-ins and I'm going to once again use help and inside the parenthesis built-in and then press enter, which is going to give me this kind of output. And when I go at the top of this output, so let me just scroll at the top, and here you will see under the classes there is an object class, and under the object class there is a base exception class, and under the base exception comes the exception class, and under the exception there is a big list of exceptions which you can see here. So 0 division error we have already seen, or when you scroll down, name error we have already seen. So all the exceptions which Python may throw are all listed here. So if you want to see the list of all the exceptions, you can just give this method which is help built-in, but before that you need to import this built-in module, and then it's going to show you this kind of output, and you will also be able to see all these exceptions in Python. Now let me show you a real life example of exceptions in Python. So what I'm going to do is I'm going to define some variables here. So first variable is result, and I'm going to initialize it with the value none, and then I'm going to declare two variables, let's say a, which takes an input, and we want to ask the user to provide some numbers. So let's say number 1 using the variable a, and in the same way I'm going to declare a variable b which also asks the user to provide a second number, but you already know that this input will return the string, so we can just convert this string into a float, let's say. So I'm going to just cast the output of this input string to a float value, and then what I want to do is I want to save the division of the two numbers a and b into the result. So a divided by b, I want to save it into the result, and then at last I would just want to print the value of the result. Now let's run this program. So right click, run the file name, and then let me provide some numbers here. So 5 and 6, and press enter. It's going to give me the result, which is the division of these two numbers. Let me run the program once again, and this time I will provide 10, and the second number is equal to 0 here, and we know that when we divide some number by 0, we get this exception which says 0 division error. And you will also observe that as soon as this error is thrown, so this error comes from this line 5. So when you click on this line, it shows us that this error is coming from this line, which is the division of these two numbers. And as soon as this exception occurs, all the code which we want to execute after that will not be executed. So we were printing this result here, but it's not printed. Let me print something else here. So I'm going to just say end, and once again I'm going to run the program, and I'm going to provide the same inputs here, and you can see neither this statement is printed nor the end is printed. So whenever an exception occurs, Python stops whatever it is doing. So in our case, whenever this exception is thrown at this line, both these statements will not be executed. And why these two lines of code will not be executed? Because we haven't handled this exception. So Python allows us to handle the exception, which we are not doing right now. That's why it stops everything whenever this exception occurs. So how to handle these type of exceptions? So you can handle these type of exceptions using a try except keyword. So just write try, and then under the try you write whatever you want to test, and then you write except keyword here. So just write except, and then under the except you write some code which you perform when the exception is thrown. So I'm going to just say this error, which is float division error. Okay, so this is what I'm going to print, and don't forget to put colon in front of except and try. So let me run the code, and let me give the same condition. So 10 and second is 0, and this time you will see that this exception is not thrown, and the result is also printed, and the end line is also printed, you can see here, and also this line is executed, which comes from the except statement which says float division error. So whenever you use try except notation, first of all your code under the try will be evaluated, and if it throws some exception, then whatever code you write under the except will be executed, and then all the other statements will be executed, whatever comes after this try except code. So this time no error is thrown, and we have handled this error, and you can see clearly it says that float division by 0, which means it comes to the except condition. So now we are handling this error, which is 0 division error. Now in other condition, when this error is not thrown, so we will just give some valid value 10 and 5, so no 0 division error will be thrown, and when I press enter, you will see that result will be printed and end will be printed by these two lines, but no except statement will be printed. So this statement is not executed because this code has not thrown any error, because there is no error occurred. Now as I have shown you that all the exceptions are under exception class. So we can also write here exception, and then we can just write this notation exception as E, and this will show us more details of the error. Okay, so I'm going to just write here error is equal to, and then I'm going to just print whatever the content of E is. And once again, when I run the code, and I will give the number with the 0 here, and you will see it prints this error which says float division by 0. So this is printed using this E keyword, which shows us the correct error. I have also shown you that this exception is the base class of zero division error. So for example, when I will try to know the type of this error E, and when I run the code once again, and let me provide this input once again, you will see that this error is of type zero division error. So we know that this exception is thrown from this class. So instead of writing this generic exception class, we can also use this zero division error here. And now whenever this specific error is thrown, then only this will be printed here. So let me run the code once again, and let me give this input here, and you will see once again this line of code is printed using this statement, and that means zero division error is caught by this line of code, and then the statement under that is printed. Now let's say this line of code throws some other kind of error other than zero division error. So let me just remove this typecasting of float here. That means it's going to throw us some other kind of error which is not zero division error. And let me run the code now, and I will provide two numbers here once again, and you will see that now this error is different, which is type error, which says unsupported type, string and float. So why is this happening? We are catching the exception using this except keyword, but we are only catching the zero division exception. We are not catching the type error exception. That's why our program is stopped and these two lines of code is not executed. So you need to either use the base class of the exception, which is this one, exception, and when you run the code and when you write these input, it will be handled, and you can see this time type error is caught. It's not a zero division error, but the type error which comes because the type which we have provided here is string, and we are dividing string by a float value which throws this error. So if you want to catch all the exceptions, you use this base class, but it's not a good practice. You need to have information about your exceptions. So I'm going to once again write this zero exception error here. And what I can do more here is I can add one more except statement here, and this time instead of zero division error I can say catch also type error. Okay, so I'm going to just write type error and here zero division error, so we know from where this error is coming. And when I run the code once again and when I give the inputs, you will see that this error is coming from this line of code. So this except statement is catching your exception, which is type error. Now when I just add this typecast of float once again, and when I run the code once again, and when I provide 10 and 0 once again, you will see this error is caught by the other except statement, which is this statement, which is used to catch the zero division error. So you can also provide multiple except statement in order to catch multiple exceptions in Python. So this is how you can do exception handling in Python. There is more to exception handling, which I will cover in the next video. In the last video, we have seen how to use exception handling in Python, and we have seen how to use this try except statement in order to catch the exceptions. Now in this video also we will talk more about exception handling in Python, and we will talk about else and finally statement with this try except statement. So I will be using the same code which I have used in the last video. So I will highly recommend you to watch the last video if you haven't seen that. Now to start with, at the end of this try except statement, we can also use the else statement. So you can just write else, and for now I will just print here, for example, underscore underscore else underscore underscore, and also we can use a keyword called finally with our try except statement. And here also I'm going to just print underscore underscore finally underscore underscore. So what does this else and finally statement do? Let's see by running our program. So I'm going to run the program, and now I'm going to give some valid input so that our program will not throw any error. So I'm going to just divide 10 by 5 and then press enter, and you will see what is printed here. So first of all, else is printed, then finally is printed, and then the result is printed using this print statement, and then at the end this end string is printed. So in this scenario there was no exception thrown by the code. That's why none of these exception statements are printed. So you can use else statement whenever your code does not throw any exception. So whenever your code doesn't throw any exception, else statement will be executed. But when this finally statement is executed, so let me give you one more scenario and then we will discuss about the finally statement. And this time I'm going to intentionally write 0 here, which is going to throw the exception, and I'm going to press enter, and you can see 0 division error is thrown, which is caught here, and this statement is printed first, and then this finally keyword is printed using this statement, and at the end these two lines of code are executed. So once again, let's talk about the else statement. You can see whenever your code throws an exception, then this else statement will not be executed. The else statement will only be executed whenever your code doesn't throw any exception. But what's with finally statement? So we have seen in the case of exception, this finally is printed, and in the case of no exception also, this finally is printed. So this finally statement is guaranteed to be executed whether exception occurs or does not occurs. So the only code which is guaranteed to be executed in all these lines is the finally statement. Finally statement is always executed whether your code throws any error or it doesn't throw any error. Now in which cases you might want to use this finally statement? So sometimes whenever you use files, you need to close these files after opening them. Whether the exception occurs or not, it is mandatory to close your files, and in those cases you can use this finally statement. The next example is, for example, you are using any database and you are opening that database, right? And for some reason your connection is lost with your database, then the exception is thrown, and in the finally statement you can reconnect to your database using the reconnect code of the database. So in finally statement you would want to execute that code which you think that have to be executed whether error happens or does not happens. So in all those scenarios you can use the finally statement. Now the next question arises is whether we can use this else and the finally statement without the except statement. The answer is, you can already see here, no. So you cannot use this else statement without the except statement. So you have to use except in order to use this else statement. But when I remove the except and the else statements, you can see there is no error now. So you can use the try and finally without the use of except or the else statement, because the code under finally will always be executed whether your code throws any error or not. So it's independent of this except statement or the else statement. So this is how you can use else and finally statements with the try and except keywords. Now in this video, I'm going to show you how to raise an exception in Python. Now raising an exception is similar to throw an error or exception in the languages like Java or C++. So Python allows us to use a keyword called raise, and that raise statement or keyword allows the programmer to force a specific exception to occur. So let's get started and let's see this raise statement with an example. So to start with, I have created a class called coffee cup, which have a init method which takes one argument, which is the temperature, and I'm just initializing the value of temperature using this init method. And this coffee cup class also have one more method which is called drink coffee, and inside this drink coffee method I have some conditions. So if the temperature is greater than 85, then I print coffee is too hot. If the temperature is less than 65, then I print coffee is too cold. And if the temperature is between 65 and 85, then I print that coffee is okay. And here I have created an instance of coffee cup class with an argument which is 75 to start with, and I'm just calling this method drink coffee from this object. So let's run the code and let's see what happens. So because this 75 is neither satisfying this condition nor this condition, so the answer which is printed here is coffee okay to drink. Now when I provide, for example, 101 temperature value here, and when I run the code once again, it will say coffee too hot. If I say coffee temperature is 10, it says coffee too cold. Now in these two situations, when the coffee is too hot or the coffee is too cold, I can also throw an exception and show the user some kind of message. So instead of printing that coffee is too hot, I can use a keyword called raise, and then I can use any class of exception. So we can use the exception class or any subclass of exception. And you can see this exception class comes in this built-in module. So I'm going to just use this exception, which is the base class, and same I'm going to do here when the coffee is cold, and I'm going to comment these two print statements. And now when I run the code, it throws an exception without any error. So it throws an exception, and after that the execution of program stops. So right now temperature is 10, which satisfies this condition. So this exception is thrown, and that's why we see this exception. So in Python, we can throw an exception using this keyword raise and this exception class or any subclass of this exception class. Now in the last video also I have shown you how to see all the subclasses which are under the exception class. To see them, you can just open your Python console, and in the Python console you just need to import built-ins and then press enter, and now you use a method called help, and inside the help method you use this keyword built-ins and then press enter, which is going to give you a big list here. And when you scroll up at the top, you will see classes here, and under the classes you will see base exception, and we have used this class which is exception, you can see here. So to raise an exception, you can use this exception class or any subclass under this exception. So you can use arithmetic error, or you can use zero division error, buffer error, whatever error is appropriate for your exception, you can use from this list. So right now I have just used the exception class, which is the base class, to throw an exception. Here, instead of exception, I can also use, for example, exception called value error, which is also the subclass of this exception class. And now when I run the code, it will show me the value error. So this is the one way of throwing an exception in Python. Now with these exceptions, you can also pass an argument inside the parentheses. So you can write exception, and then in the parentheses you can write the message whatever you want to show when this exception is thrown. So here I can just write coffee is too hot, and for the another exception I'm going to just say coffee too cold. And when I run the code, because it's a value exception which comes from this statement, it shows the value error exception and then the message which we want to show. So we are just showing coffee too cold. So here it also prints the same message which we have given as the first argument of this exception error class. So you can either raise an exception with the base class exception or the subclass of the base class exception, for example value error, and you can also give an optional argument here, which is the message which will be displayed at the time when this exception is thrown. So this is how you can raise or throw an exception in Python. In the last video we have seen how to raise an exception in Python using this raise keyword, and we have seen how to raise an exception using the base class, which is exception, or the subclasses of this exception class, for example the value error or any other error which is the subclass of this exception. Now in this video I'm going to show you how you can create your custom exception classes and use them to raise exception in Python. So let's get started. So I'm going to create a custom exception class here. So let me create a class and I'm going to name it as coffee too hot exception. And to create your own custom exception class, you need to inherit from the exception class. So you just need to provide exception as the super class here inside the parentheses, and then after the colon you can just define the init method to provide the message. So it takes one argument, for example msg, which stands for message. And now what we need to do is we need to pass this message to the constructor of this exception class. And how to do that? You can do that using the super function. So you can use super and then call the init function here, which means we are calling the init method of this exception class using this super function. And we just need to pass the message which comes as an argument of your custom exception class to the super class, which is the exception class. And that's your custom exception class. Now I can pass this class instead of this base exception class. Similarly, to create the coffee too cold class, I can once again write coffee too cold here, and instead of using this subclass of exception, I can give here my own custom exception class. So let's run this program and let's see what happens. So because right now the temperature which we have provided here is 10, which means this falls in this condition which says coffee too cold. So we are seeing this exception which says coffee too cold, and then it's going to show us this message which says coffee too cold. Now we have made this exception class explanatory enough so that we don't require this coffee too cold message. Instead of this coffee too cold message, we can give some more information for the user. For example, we can write here coffee temperature, and then we can provide the information of the coffee temperature which the user has provided. So self dot underscore underscore temperature, and same we can provide in the coffee too hot exception message. One more thing which we need to do here is we need to convert this temperature into a string. So we can use this method str to convert from the integer or the float value to the string value. So this is just the typecasting from the integer to the string. And now we are going to run our program and see what's the result here. So you can see now the result says coffee to cold exception, and then it shows the temperature which is provided by the user. Let's say this temperature we change from 10 to 100, and once again run the code. Now it's going to say coffee to hot, and it's going to display the temperature of coffee, which is 100 here. So let's rewind what we have learned about creating our own custom exception class. So in order to create your own custom exception class, you need to inherit from this exception base class or the super class, and then you can create any custom class with any name. And for passing the message which you provide as the first argument of your exception, you can just create an init method which takes this message and pass it to the init method of your super class, which is the exception class. So this is how you can create your own custom exception classes and use them to raise the exception in Python. In this video, we will talk about this special keyword which is underscore underscore name underscore underscore, and we will see in which situations we use this keyword and why do we use this special if statement which is name is equal to underscore underscore main underscore underscore. So let's get started. So to start with, you can see I have two files here. One is mymath.py and other is test.py. Both the files are in the same directory in my project. So now what I will do here is I will define a very simple method which is add, which takes two arguments a and b, and it's going to return the sum of a and b. So we have already seen how to create these kind of simple functions, and now what I'm going to do is I'm going to use this print function to call this add function, and here I'm going to just give two numbers here. So nothing special about this code. Now what I'm going to do next is I'm going to import this file which is mymath.py file into the test.py, and now I'm going to just use print, and then I'm going to use this module name which is mymath to call this function which is there inside this mymath.py file, and then I'm going to provide two values here once again into this add function. So let's say 7 and 6. Now let me run this test.py file first, in which I'm importing this mymath.py file. So right click and then run test, which is going to run this program. And what you will see here is it prints 26, which is the sum of 10 and 16, which is printed using this print statement. And then you will see 13, which is printed using this print statement, which is the sum of these two numbers which we have provided in test.py. Now I have a simple question. Is this a correct response? Because I just want to call the add method from mymath.py file into the test.py, and I don't want to print any result which is coming from this print statement, because I just want to use mymath.py as a module, and we just want to use the functions inside this mymath.py file, not any special code which is written here. So that's where we use this special condition, which is if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore, and under this condition we use whatever code we want to execute. And this name is a special built-in keyword in Python whose value is equal to either the module name, which is mymath, or its value is equal to underscore underscore main underscore underscore. So under what condition the value of underscore underscore name becomes the module name, and in what condition underscore underscore name underscore underscore contains this value which is main. So whenever you run this mymath.py file as the main Python file. So whenever I run this file, which is mymath.py file, then the value of name becomes this, which is underscore underscore main underscore underscore. Let's print the value of this variable, and then we will see how this value changes in different conditions. So once again, I'm going to run this code, and you will see the value of this special variable becomes underscore underscore main underscore underscore. So whenever you will run this mymath.py as the main file, then only the value of this special keyword underscore underscore name underscore underscore becomes this main value. Now if I import this mymath module into some other file, for example test.py, and then use the functions from this module, then let's see what happens. So I'm going to just right click on the test.py now, and then I'm going to run it, and you will see the value of this underscore underscore name underscore underscore is now is equal to the name of your module. Okay, so my module name is mymath.py. So here it just prints the module name, and you will also see that because we have provided this condition, this statement is not executed, and only the statement which we have written here is executed, because this condition checks for the name value, which checks whether we are running this mymath.py file as the main file, or we are importing this file into the other file and we are just using the functions inside that module. So this condition is similar to, for example, main method in the C++ or the Java programming language. And what does the main method do in those two languages? The main function is the main entry point of your program. So this condition is performing the same operation. We can run these two files using the terminal also. So in PyCharm, you can just click on this option which says terminal, which opens the terminal in your PyCharm IDE in the same folder in which you are currently working in. And then I can use this Python command to call this mymath.py file first of all. So I'm going to just use mymath.py, which is going to run this mymath.py, and you can see if we run this mymath.py as the main file, then the value of this special keyword name becomes main. Otherwise, when we are going to run this test.py file, in which we are just importing this mymath.py file, and then when I press enter, you will see that now the value of this name variable becomes the name of your module, which is mymath. So in this way, you can use this special condition in Python. In this video, I'm going to show you how you can create a text file in Python and write in it. So let's get started. So to start with, we use a built-in function which is open, and it takes two arguments. First is the name of the file which we want to create or read. So let's say I want to just create a file which is demo.txt in the same folder in which I am working in. So you can see I'm working in my file handling project, and there is only one file there, which is test.py, and this demo.txt file will be created in the same folder. Now the second argument which we want to give here is the mode. So there are several types of modes which we can use with this open function to work with the files. So let me show you the list of some of these modes. So you can see on the left hand side I have listed the modes. So you can use the R or R plus or W or W plus or A or B. Now R is used to read from the file, and if you don't provide any mode to this function, then the default mode is the read mode. Now if you want to write to a file, you use this write mode with a keyword W. So we are going to use this W keyword in order to write to the file. So let's use this W keyword here, and then this open function returns a file object. So let's store this file object into a variable. Now generally we call this file object a file handler, and using this file handler we can work with the file on which we are working on. So this file handler will be used to work on this file which we want to create. Now in the next line I will just use this file handler, and then I can call some methods here. You can see there is a list of methods I can call on this file handler which is returned by this open function. So to write into a file I can use the write function, and here inside the write function you can provide any text whatever you want to write to the file. So let's say I just want to write this line of string to my text file which I'm creating. So I can just paste this text here, and then after writing to a file, when you are finished working with the file, you use once again this fh and then call a method called close on it. Now what does this close function do? So this close function is used to close the file and immediately free up any system resources used by your file handler, which is fh. And it's a good practice to use this whenever you are done with the handling of your file. So always remember to use this close function after you are done with the handling of your file. So this is a good practice, but I would say you must call this function. And that's it. So this W mode, if the file demo.txt doesn't exist, it's going to create the file and then it's going to write this text into the file. So W mode is responsible for creating the file also. And if the file already exists, it will overwrite the previous string by the string which you are writing using this write function. So let me just run this code and you will keep eye on this project because this file will be created inside this project. So I'm going to right click and then run this test file, and you will see as soon as I run this test file, there is one more file created here which is demo.txt, and when I click on this file you can see the same text appears here which we have written using the write function. Now if you want to provide the line breaks, you can provide them using \n, and I'm going to once again run the code. So remember, when the file doesn't exist, the W mode is going to create the file, and if the file already exists, which it does now, then it's going to overwrite it. So I'm going to run the program once again and see the content of this demo.txt, and you can see this string is split into 2 lines, which is done by this \n. So let me just split the screen so you will see the demo in the real time. So on the right hand side I have my demo.txt file, and on the left hand side I have this code on which I am working on. So let's write something else in this file. So instead of writing this big line of text into the file, what I want to do now is I want to use a for loop to print 10 lines into this demo.txt file. So I'm going to use a for loop for that, and I'm going to just write for I in range, and let's say the range is 10, and then we will call our write function using this fh file handler. And then what I want to write here is, let's say this is line number modulus d, and I will just replace this mod d with the line number, and then I will just provide the line break after that. And in the previous videos we have already seen that when you use this modulo symbol and then give some value here, for example I, then this mod d will be replaced by this I, right? So let's run the code and let's see what happens now. So I'm going to run this code, and now you will see that this code prints this is line number 0, this is line number 1, because the range starts from 0. So in order to print the line number from 1, what we can do here is we can use this parenthesis here. Let me just move this to the side. So inside the parenthesis we can use I plus 1. So we can add 1 every time this value of I is printed. So it will start from 1. So let's run the code once again, and you can see now it prints this is line number 1, line number 2, 3, 4 up to 10. Now you might have already observed that whenever I run the code, this demo.txt file is overwritten every time when I run this code. So the old text is overwritten by the new text. Now in order to avoid the overwriting of the text, what we can do is we can use a special mode which is A here, and A stands for append, and this append mode is used to append the text to the file. So let's replace this W mode with the A mode now, okay? And you can see this is the previous content of the demo.txt file, and now when I run the code, you will see the previous content is staying there and the new content is appended to the same file. So A we use to append to the existing content of the file. Now let me go to the list of modes once again, and you will see there is a special mode W plus also, which means if you want to read and write at the same time, you use this W plus mode, and this mode is going to create a new file if the file doesn't exist. Otherwise, if file already exists, it's going to overwrite to the file which already exists. Also, you will see a special mode B here, which is used for the binary files such as images or other binary files. This R and R plus mode we will see in the next video, and I'm going to show you how to read from the file using these modes in Python in the next video. So let's go to our code once again. And in the videos in which I have shown you how to use exception handling, I told you we can use try with the finally keyword. So try, and we can enclose this for loop inside the try block, and let's do this. And then in the finally, we can add the closing of this file. And what does this finally do? If you remember, this finally block is always called in the case exception is thrown by this code, or if exception is not thrown. So this fh.close is definitely will be called whenever we use this finally keyword in order to call the fh.close function. So you can either use this kind of code in order to work with your file handler and then use this close function with this file handler at the end of the handling of the file. Otherwise, Python provides the shorter form of writing the same type of notation. And this notation is you use a keyword with and then you call open function, and you can provide the same type of arguments here, for example demo.text and append, and then you use as keyword and then you write the name of the file handler, for example fh, as you have done here, and then you provide this colon, and inside this with statement you work with your code. For example, we work with the file writing with this for loop. So this whole code, including the try and finally block, is equivalent to this kind of code, which is the shorter form of writing the same code. So this with statement is going to always call this close method with your file handler when you are done with the handling of your file. So you don't need to explicitly call this try finally block in order to work with your file. This is enough to work with the file. So either use this notation or this notation. Both are equivalent to each other. Now the last thing which I want to show here is, let me just use the with statement in order to work with this demo.txt file. Is, for example, you don't want to create this demo.txt file into the current project. Instead, you want to create this file into some folder on your computer. So let's say I want to create this file inside this folder, which is inside my C directory. So I can just copy this whole path from here, and then I can just paste this path with the backslash here. And the important thing to note here is, on Windows, you always need to use the double backslashes in order to provide the file path. Okay, so use these double backslashes to provide the file path. So C, inside the C directory, I have this files folder, and inside the file folder right now you can see this is empty. And now when I run this code, let me just change the mode to W, which is for write mode, and I'm going to run the code. And as soon as I run the code, this demo.txt file is created here, and you can also see the content of the file on the right side, which is, this is line 1 up to this is line number 10. So this is how you can create a text file and write into it using Python. In the last video, we have seen how to create a file in Python and how to write content in that file in Python. Now in this video, I'm going to show you how you can read the content of a text file using Python. Now if you remember, in the last video, I have told you that you can use this open function to open any text file. And this open function takes two arguments. First is the path of the file with the exact name of the file. So because this demo.txt file is in the current folder in which I'm working in, that's why I haven't provided any exact path. I can just give the file name here. But if you have the full path, then you can provide, for example, C:\/ and then whatever is the folder name and then the file name. So either you can provide the exact path of this file with the file name, or you can provide the file name if this file is present in the same directory in which your Python script is there. Now the second argument which this open function takes is the mode of opening this file. So we have seen in the last video, when we write W here or A here, that means we want to write or append to the file. Now in order to read from the file, this mode here should be R, which is the read mode. In the last video, we have seen this table in which we have seen that we can use this R or R plus mode in order to read the file, or if you want to read and write at the same time, you can use this R plus mode. Now if you see here, I have also written here that R is the default mode. So when I don't give any argument here as the second argument, which is for the mode, then also the default mode is the read mode. So let's see how we can read this file, which is demo.txt file, and the content of file is shown here. So in order to read the file, you use the file handler and then use the function, for example, read, which is used to read the whole file. Now in order to print the content of the file, you need to use this print function. So this fh.read will provide the string, and then using this print function, we can print that string. So let's run the code and let's see what happens. So you can see it prints the whole content of the file. Now let me minimize this window once again. Now let's say if you provide some file path which doesn't exist. So this file name doesn't exist in the current folder, and when I try to read this file, let's see what happens. So it's going to throw an error, and this error says that no such file or directory. So if you try to open a file which doesn't exist, it will throw an error. So you need to give the exact name of the file in order to read it. Now here we can also be more specific, and we can also say that this is a read mode in which I want to open this file, and once again when I run the code, it's going to read the content of this file. Now let's say I just want to read the first word of first line here. So let's say I want to just read the first 4 characters of this line 1, then I can just write 4 here, which will read the first 4 characters of the line 1. Now if we just want to read the first 2 words of this line 1, then you can see the number of characters here, 4 for this, and then there is a space, so 5 characters, and then IS is 2 characters more, so 5 plus 2, 7. So when we write 7 here, then it's going to read the first 2 words of this line 1. Now let's say I want to read the whole line. So instead of some words or some characters, I want to read the whole line. Then I can use a function called readLine, and this readLine function is going to read the first line of the text which is present in my file. So I'm going to just run the code, and you can see it reads the first line of my text file. Now if you want to read the next line, then you need to use this readLine function once again, and when I run the code once again, it's going to print the second line, and so on. So if you want to print the 3 lines, then you use this function 3 times. Now let's say you want to read some characters of the line 1, then you can once again write the number of characters which you want to read, and then run the code, and it will print the first 4 characters of the first line. And you will observe that when I use this readLine function once again, the string starts from the ending of the first line. So in the first line, we have just used the first 4 characters of the first line. Now pointer will be set to the end of this first 4 characters. So when you use the readLine function once again, it's going to start where the first line has ended. So first line has ended at the end of the 4th character, and then it's going to read the space and then all the line characters which are there. So in the second readLine statement, it has printed this kind of text which is after the first 4 characters. And in the third readLine, because we haven't provided any argument here, so it has printed the whole line here. So let me minimize this. Now let's say you want to read all the lines of this file in the form of the list. So you want to read the 10 lines of this file in the form of list. You can use a function called dot read lines. So here you just need to write dot read lines, and this function is going to give you the list of every line in the text. So let me run the code first of all, and you can see this is the list which starts from a square bracket, and the first element of the list is the first line with the \n, which is the line break, comma. The second element of the list is the second line of the text which we are reading from here. So now we know that this read lines function returns the list. So we can also call some index of this list. So let's say I just want to read the 5th line of this text, then I can just write index 4 because index starts from 0, right? So let me run the code once again, and it prints this line which is at the line 5. Now let's say I want to read the last line. I can just say 9, and it's going to print the line number 10 of your text file. Let me minimize this once again. Now let's say you want to read all the lines of this text one by one and do some operations on each and every line one by one. So you can use a for loop for that to iterate over the lines one by one. So for, let's say, line in your fh, which is the file handler, and then you can print the line one by one. So you can call this variable which is line here, and now let's run the code, and it's going to iterate over this text line by line, and every line is printed one by one using this print line statement. So let's say you want to count the number of characters in every line. You can use this function, which is len function, which is used to count the length of a string. And when I run this code, now it's just going to print the number of characters in every line. Now once again, let's say you want to count the number of words in every line. So we can use a function on this line variable, which is a function called split. So line dot split, which is going to split your line on the basis of character you provide as an argument here. So let's say I want to split the line on the basis of a space. So let me run the code once again, and now you will see that it's going to give me the list of each and every word of every line. So this is the first element of the first list, and then the second element, third element, and fourth element, and the fifth element. So if you want to count the number of words in every line, then once again we can enclose this code into a function called len. Okay, so this length is going to give you the length of this list, and when I run the code once again, it's going to print the number of words in every line of this text file. So if you want to count the number of words in every line, you can split the words using the space, and then using this len function, you can just find the length of the list which is returned by this split function. Or if you want to just see the list of words in every line, then you can just use this function without the len function, and it's going to give you the list of each and every word of every line of your text file. And of course, to make things easier, you can also use this with notation, which I have also told you in the last video. So you can write with and then this open function, and in the open function you give these two arguments, which is the name of the file and the mode, and then you can use as fh, for example, and then you can execute whatever code you want to execute using this file handler. For example, once again, I want to read the content of the file once again. So using this with statement, you don't need to use this fh.close function, because this with function is going to take care of closing of this handler by itself. So this whole code is equivalent to the code which you write whenever you use the try finally block with this code also. So this is also possible. So let me just remove this code and let's run the code once again, and it's going to give me the same result as we have seen earlier. So in this way you can read the text files in Python. In this video I'm going to show you how to handle JSON values in Python. So first of all, what is JSON? So JSON is a text format which stands for JavaScript Object Notation, and JSON is a syntax which is used for storing and exchanging data. Now if you want to know more about JSON, what is JSON and how to create JSONs and what value you can store in JSON, then I have created a whole video about that, so you can watch that video and understand more about JSON. So let's get started with this tutorial and let's see how we can use JSON in Python. So to use JSON in Python, you use an inbuilt package which is called JSON. So you need to import this inbuilt package which is JSON. Now let's say I have a Python dictionary. So let me create a dictionary in Python which have, let's say, so this is our dictionary in Python. So in order to convert this dictionary into JSON, you use this JSON keyword which we have imported here, and then call a method called dumps. So this dumps method we can call here to convert some Python values to a JSON value. And we will pass this dictionary variable a here, and in order to print the value of JSON, we can use this print method. So I'm going to enclose this JSON.dumps method inside our print function. Now let's run this code, and you will see that this JSON.dumps function has converted your dictionary into a JSON value. So this is our JSON text format. Now the next question which can arise here is what data types this dumps function takes as an argument. So it takes a dictionary we already know now, but what are the other data types which we can pass as an argument to this dumps function? So it turns out that you can provide majority of your collections and your data types as an argument to this dumps function. So you can provide dictionary here, list, tuple, string, int, float, or a Boolean value. Any value you can provide here. I think sets you cannot provide as an argument here, but other than sets you can provide any other format as an argument to this dumps methods. So let me show you how you can provide all these values into this JSON.dumps function. So here in the first print statement I have provided the dictionary, in the second print statement I have provided the list, in the third we have provided tuple, in the fourth statement we have provided the string, and then the integer, and then float values, and then we have provided the two Boolean values, false and true, and at last we have provided this none keyword to this dumps function. So let's run the code and let's see what happens. So everything runs fine. So that means you can convert from this JSON.dumps function a dictionary or a list or a tuple or a string or a decimal or a float or a Boolean value into a JSON value, and all these are valid JSON values. Now let me go once again to this dictionary method, and here also as the JSON values you can provide any type of values which I have shown here. So you can use inside this dictionary, for example, another dictionary. So I can just write so we can also provide a tuple here. So let's run this code and it's totally valid. So you can see our dictionary is now converted to a JSON value. Now this dumps function also takes few other parameters also. So we can also provide a parameter called indent here. So you need to write indent is equal to, and then after that you can write some number here. So if you want to give the indent of 4 to each and every element of your JSON, then you can write indent is equal to 4. And let me run the code once again, and now you can see this JSON is printed into a pretty format. And the indentation here, indentation means this indentation is 4 spaces for each and every element of your JSON. So if you want to print your JSON into a pretty format, then you can just write indent is equal to and the number of indents you want to give. So let's say I want to provide just 2 indents here, and let me run the code once again, and you will see now this only have the 2 indents for every element of this JSON. Also you can provide a parameter called separators, and as the separators, let's say first value I want to provide here is a dot value and the space here, and the second value I want to provide here is this equals to symbol. So what this separators argument does is it will replace your commas with this dot notation and your colons with this equals to notation. And when I run the code, you can see now the colon is replaced by the equals to symbol and the comma is replaced by this dot symbol. So you can use separators like this also, but I will not prefer to use these kind of notation. The original notation is the one which I prefer to use, which is with commas and these colons. One more thing you can use here is the sort keys. So you can just write sort keys here, and whenever you write true here, it's going to sort your JSON according to their alphabetical order. So you can see right now your keys are assembled in non-alphabetical order. So they are assembled in a random manner, but when you give sort keys is equal to true here, and I'm going to run the code, you can see age comes first, then the marks, and then the name, and then the object. So now your keys are assembled or sorted in the alphabetical order when you use this kind of notation. Now let's try to save this JSON value into a JSON file. So in the last video, I have shown you can use this with statement, and then you can use open function, and we can provide a file name here, for example demo.json. So JSON file always have the extension .json, and the second value we will provide here is the mode. So we want to write to the file, so that's why we have used w here as fh, and then using this fh we can write to this file which we have created. So we can pass this json.dumps function here, and now your dictionary A will be converted into a JSON, and then this JSON will be saved into this demo.json file. You can see here I'm working inside this file handling project, and here I only have .py file, and when I run this code, you will see there is one more file which will be created here, which is demo.json. So I can open this file here, and here you will see all our JSON values are saved in this demo.json file. So we have provided these values into the demo.json file. Let me just split the screen so you will be able to see it correctly. So we have provided a name here. So name is here, age is here, marks is here, and then the object is here, and also the pass is also here. So this is how you can write your JSON values into a file. Now let's see how we can read the JSON values from a file. So I'm going to remove this dictionary from here, and instead of using this write mode, I'm going to just use read mode, which we use to read from the file. And a file we already have. So let's say we want to read all this data which we have written into this file, and now instead of using this line, I need to use fh.read function here, and to print the content what we have read from this file, we can use the print function. So I'm going to enclose this fh.read into the print function, and let's run the code first of all. And when I run this code, you can see it prints all the content of this JSON. Now one thing which you need to observe here is this fh.read function is going to give you a string value. So to confirm that, we can just write type here, and we will just see the type of this fh.read function, and I'm going to run the code. Let's see what's the answer. So you can see this read replies you in the form of string. So in order to convert this string into some parsable format, you use a function called json.loads. So I'm going to save this string into let's say a variable json_str. This is the variable name, and we will assign whatever we read from the file into this variable. And now what we can do here is we can convert this string into a JSON value using a method called json.loads. So let me create a variable once again. So JSON value is the variable name, and then I can use this JSON keyword which we have imported .loads function. So just use the loads function and then pass this string as an argument of this loads function. So this loads function takes a string and converts it into a JSON value. So now let's print the type of the JSON value. So I'm going to just write print type, and then we use the JSON value argument here, and then once again run the code, and you will see now the JSON value data type is the dictionary. So because now it's a dictionary, we can parse some values from it. So let's say from this JSON value dictionary, we want to get the name. So name here we have stored is Max. So we can just give the key here name, and then run the code. It's going to give us the value associated with the name, which is Max. So this json.loads function we use to convert from a JSON or a string value into a Python dictionary. So this is how you can handle JSON values in Python. In this video, I'm going to show you what are iterators in Python and how to use iterators in Python. And at the end, I'm also going to show you how you can create your custom iterator class in Python. So let's get started and let's see first of all what is an iterator. But before that, we need to understand what is iteration. So what is iteration? An act of going over a collection is called iteration. Now what kind of collections we are talking about? We have already seen some kind of collections like lists, tuples, dictionaries, sets, and other kind of collections. And till now, what we have seen is we can use a for loop to iterate over a collection. So till now, what we have learned is, for example, I'm going to declare a collection, which is list in this case, and I'm going to just add some values inside the list. And once I declare the list, I can iterate over this list using a for loop. So let's say for I in the collection name, and then you can just write print here to print each and every value of this collection A. So this for loop iterate over each and every element in the collection and then print the value using this print statement. Now let's talk about the iterators. So what is an iterator? Iterator is an object which can be used to iterate over a collection. Now this iterator object has two special methods. First is underscore underscore iter underscore underscore, and second is underscore underscore next underscore underscore. So iterators have these two special methods. One is iter, and this iter method is going to get you the iterator, and the next method is going to give you the next value using this iterator. Now collections like lists or dictionary or tuple are all iteratable collections. That means we can iterate over them, and all these collection objects have a special method called iter, which is used to get the iterator from these collections. So let me show you first of all these two methods inside a collection. So when you use dir inbuilt function and give any collection as an argument here, and when I press enter, you will see a list of functions here, and when I scroll little bit right here, you will see a special function which is iter. So all these collections like lists or dictionary or tuple have this iter method, and we can call this iter method to get the object of the iterator, and we can call this underscore underscore iter method using a special method called iter without underscore in front and back of it. So let me just show you what I'm saying. So I'm going to declare a variable it, which stands for iterator, and then I'm going to use a special method called iter without underscore, and this iter method is used to get the iterator. So I can just pass my collection here as an argument, and this iterator method is going to give me the iterator object of this collection which I was talking about, which is underscore underscore iter underscore underscore. So let me just press enter, and now we have the iterator object, and this iterator object we can use to call all the values in the collection. So let's once again print the values of our A list, and this has these 6 values, and now I can use a special method called next here to get the first value of this collection. So I'm going to just pass the it, which is the iterator which we have got from this iter method, and then press enter, and you will see it will print the first value of your list. Now once again, when you call this next using this it variable, it's going to give you the next value of the list, and when you call it again and again, It's going to iterate over your list and give you the values of the list one by one. So let's get all the values. So this is the second last value, which is 9, and then at last it's going to print the last value, which is 7. Now at this point, iterator has iterated over all these 6 values. After that, when you call this next method once again over this it variable, then it's going to give you this exception which says stop iteration. So when your iterator is exhausted, then it's going to give you the exception which is stop iteration. Now, as I said, the collections like list, dictionary or tuple have this iteratable object. That means we can use the for loop to iterate over these collections. So for loop uses the same iterator mechanism to iterate over all these elements of the collection. Now, many times in your programming development career, you will have to write a class in order to iterate over some kind of collection. So let me show you how you can create your custom iterator class. So let me minimize this Python console in the PyCharm IDE, and I will just comment these two methods. So as I said, an iterator always have these two special methods. One is underscore underscore iter underscore underscore, and the second is underscore underscore next underscore underscore. So in order to create your own iterator class, you need to implement both these methods. So let's create an iterator class, and I'm going to just name my class as list iterator class. And in this list iterator class, first of all, I'm going to define init method, and this init method is going to take any type of list or any type of collection which is iteratable. And then inside this init method, I'm going to just call a self to create a member variable here, and I'm going to name my member variable as dot underscore underscore list, and I'm going to just pass the value of a. Let's name this a as list also, so we will be clear. So list is equal to list. The second member variable which I want to create here is the index variable. So the second variable is the index variable, which is the index of the list or the collection, and let's give the initial value of this index. Now, as I said, in order to create an iterator class, you need to implement these two methods, which are underscore underscore iter method first of all, and in this method we are just going to return the value of self. So this underscore underscore iter method is going to give you the iterator, and let's also implement the method which is underscore underscore next. Now in this next method, first of all, when this next method is called, what we want to do is we want to increase the value of index. So let's call our index member variable, and let's increase the value of index by 1. And the next thing which we want to do here is we want to send the value at this index. So we can just return. So let me call return first of all, and then self dot your list name, whatever is your list, and then inside these square brackets we call the index which we have incremented by 1. So self dot underscore underscore index. So this statement is going to give you the current value at this index right now, and that's basically it. So I'm going to just say my list is equal to list iterator, and this list iterator takes an argument which is a collection, right? So let me create a list collection, and I'm going to name my list as A, and here I'm going to provide some values inside the list. So let's say we have these 6 values inside the list, and now we can just pass this list as an argument of our list iterator. So once we have this list iterator object, we can call a iter method in order to get the iterator object, which is this one. So let me create one more variable which is it, and then I'm going to call this iter method, and I'm going to pass my list object as an argument of this iter method. So now I have the iterator object of this list using this list iterator class. And now I can use the print method. So let me call a print method, and then I can call the next method to iterate over the list using the it variable. So let's run this code once again, and you will see it's going to print the first value of the list, which is 1. Let's print it 2 more times, and let's run the code once again, and you can see it's going to give you the next 2 values of the list. So now we know that this next is going to call every time the next value from this list. So let's print all the values of the list using this next method, and you can see it prints all the values of this list. Now when I want to go beyond this after the list iterator is exhausted, and let's run the code, you will see it's going to give me this error which says list index out of range. But this is not the problem of the iterator, it's the problem of the list. Now what I have shown you when I have shown you the example of this list iterator in the Python console, whenever your iterator is exhausted, it throws the stop iteration error or exception. So let's raise the same kind of stop iteration exception using our class also. So I will go to the next method of my class, and here I can give a condition, and this condition checks whether the value of index, so self dot underscore underscore index, is greater than or equal to the length of your list. So length, and the list name is self dot underscore underscore list, and when this condition is true, we are going to raise an exception. So let's use the raise keyword, and the exception which we want to raise here is the stop iteration exception. So let's throw this exception or raise this exception, and what this condition is basically going to do is, until the last index, which is, for example, in this list, the last index is 5. So until the last index, everything will be okay. But as soon as this index becomes 6, which is the length of your list also, so the length of the list which have 6 element is 6. But index will go up to 5 because the index starts from 0. So as soon as this index becomes is equal to the length, which means the iterator has been exhausted, we can also write double equals to here. As soon as the value of index becomes the length of the list, we can throw this exception. So let's run this code once again, and you can see we have used this next method 7 times. So at the last print statement, it's going to give us the error. So first of all, let me remove the last statement, and let's run the code, and it's going to run fine. So you can see everything is fine. But as soon as I call this last next method, and I know that my iterator is exhausted, and when I run the code once again, it's going to raise an exception, which is stop iteration. Now one more thing which I said which you can use with your iterators is the for loop. So let's try to use this for loop, and I'm going to just write for I in your iterator, which is it, which we have got using this iter method. And let me comment this code also, and now I can print each and every element inside the list A. So I'm going to just write print I here, and let me remove this code from here so you can see the list also and this for loop also. And I'm going to run this code once again, and you can see this for loop has iterated over our list, which we have provided as an argument of this list iterator class, and you can see all the values inside the list have been printed using this for loop. So in this way you can create your own iterator class in Python. In the last video we have seen how to use iterators in Python. Now in this video we are going to learn how to use generators in Python. So first of all, what are generators? So generators are the simple way of creating iterators. Now simply put, a generator is a function that returns the iterator object on which we can iterate upon. So let me give you an example of generators, and then we will see why it's a simple way of creating iterators. So what I'm going to do is I'm going to create a simple function, myFunc, and inside this function I will use a special keyword called yield instead of return. Now after this keyword yield, let's say I want to return some values. So I'm going to write first of all a, and then once again I'm going to use yield, and I'm going to use b here, and once again I'm going to use this keyword yield, and again I'm going to return c here. So if your function contains at least one yield keyword, then this function is called a generator function. So how this yield keyword is different from the return? So in the case of return, the statement is immediately terminated entirely. So after return, you cannot do anything inside a function, because after using this return keyword, the statement is terminated entirely. But the yield statement pauses the function and saving the state of that function. So let me demonstrate what I said. So I'm going to create a variable x, and I'm going to just assign the value of my function to this variable x. Now on this x, I can use a next function. So as I said, whenever you use at least one yield keyword inside your function, it becomes a generator. And I also said when you use a generator, it returns the iterator object. So this myfunc generator function returns the iterator object, which we are saving inside the x variable. And we can provide this x variable, which is an iterator object, as an argument of this next function, which is going to give you the first value which you use with the yield keyword. So let me just run the code. So right click and then run the file, and you will see it's going to give you the first value which you use with the yield keyword. Now after that, let's say we use this next function 2 more times, then it's going to give you the next value, and once again when you use the next function, it's going to give you the next value. So it's like using the iterator on which you can use the next function, but it's much simpler to use because you just need to use this yield keyword instead of implementing the iter method and the next method inside your class, which we have done in the last video. Now after using next 3 times, because we only have used this yield 3 times, let's use the next function 4th time, because now in the 4th time your iterator is already exhausted, and let's see what happens. So you will see it's going to give you this exception which says stop iteration, which we have already seen in the case of iterators also, which I have shown you in the last video. So generators are similar to iterators, but they are more simple to use and create. So you don't need to throw any exception. The generator will take care of throwing this exception by itself. So what is the difference between iterators and generators? So as we have seen in the last video, that in order to create an iterator class, we need to implement 2 methods, which are iter method and the next method. So if you haven't seen the last video, I will recommend you to watch that last video in which I have shown you how to create the iterator class. So whenever you need to implement the iterators, they are more lengthy and sometimes counterintuitive. Now in the case of generators, the methods like iter and next are automatically implemented. So this generator which we have implemented here will return the iterator object on which we can iterate upon. So now what's the role of this yield keyword? So whatever value you will write after the yield keyword, it's going to return that value, and immediately after that it's going to save the status of your function. So that means, for example, whenever we call this next function for the first time with this x value, then it's going to return the first value which you use with the yield keyword. As soon as you do that, your function is going to save the status of this iterator, that means the iterator is at A, and then whenever you call the next method once again, your generator is going to remember that last time it has returned the first value and now it's the time to return the next value. And this will go on and on until you use this yield keyword. So let me give you one more example. Let's say I will declare a variable n and the initial value of n is 1, and then I'm going to just yield this value n for the first time. And also above the yield keyword, I'm going to print the value of n. So I'm going to just give this string, and after this string I'm going to just print the value of n. Same print statement I'm going to use before the other yield keywords also, and before using this n keyword with other yields statements, I'm going to increase the value of n by 1 every time. So before the next yield, I'm going to increase the value of 1 once again, and before the last yield also, I'm going to increase the value of n once again. So we have used yield 3 times, and every time we are increasing the value of n. And let's use the same initialization of my func, and also I will use this print statement 3 times. And when I will do this, I'm going to run the program and you will see what happens. So let me use this next function only once, and when I run the code, it prints the print statement using this print statement and then gives you the value of n, which is 1 at the first yield. Then we have increased the value of n by 1, so now the value becomes 2. So when we call the next method once again, it's going to give you the value of n, and also it's going to print the next print statement. So let me just move this below this expression so we will see the increment here also. And similar we will do with the third yield statement. So when I use this next third time, is going to print the third value. So basically your yield keyword is saving the status after it returns the value associated with it, and it resumes the status whenever you use the next function. Now let me show you one more thing, and that is how you can use this yield keyword with the for loop. So let's say I will create a for loop and I will say for I in some range, and let's say this range is up to 5, and after this I want to print the value of I, for example. So here I will print the value of I, and then what I'm going to do is inside this for loop I'm going to return the value of I. So now we don't need this n variable. So every time from the for loop I'm just returning the value of I in each iteration, and let's see what happens. So let me use this next function only once, and you will see it's going to first print the value of I, which is 5 here, which is little bit strange. I thought I have written here range here, but it was something else. So let's rewrite range function here. Inside this we have provided 5 as the range, and once again when we run the code, it's going to print the value of I, which is 0. Now every time you use this next function, it's going to give you the next value of I, which is 0, 1, 2 until the 5. So let me just run this code once again, and you will see it's going to give you the value until this for loop is valid, and as soon as you go outside the range, it's going to give you this exception, which is stop iteration exception. So everything in generator is working similar to the iterators which we have seen in the last video. So how about we recreate the class which we have written in the last video when I have shown you the iterators example, which is list iterator class. So I'm going to write a similar code to iterate over this list of numbers. So what I want to do is I want to rewrite this code using the generators. So let me just split this editor so you will see iterators and generators side by side. So I'm going to close this from here. So on the left hand side we have a generators file, and on the right hand side we have the iterators file. So let me just remove this code from here, and what I'm going to do is I'm going to create a new function, and I'm going to name it as list iterator function with the smaller l and smaller I. So this function takes a list, as we have seen in the case of list iterators, which was taking a list as the argument. So here also we are going to give this argument, which is list, and inside this function what I'm going to do is I'm going to use a simple for loop for I in, and I will iterate over the list which we have provided as an argument. So we will iterate over this list using the for loop, and then we are going to yield the value of I every time when we iterate over this list using this for loop. And that's it. So it's that simple to recreate the whole class of iterators using this generator. So the biggest advantage here when we create the generator is we don't need to implement this iter method or this next method, and we also don't need to raise this exception from our function or a class whenever we create the generator. The generator function will take care of this stop exception by itself. So the only thing which remains now is we just need to create a list. So we will use the same list as we have used with the list iterator class, and instead of this class I will just replace it with this list iterator function, and you don't need to do anything. So you don't need to use this iter method to get the iterator object. This function is going to return the iterator object by itself. So now we just need to call the print function and the next function, and inside the next function we just need to pass this variable which we have got from this generator function which we have created. And when we run this code, so I'm going to right click and run this code once again, it's going to give you the first value of the list, which is 1. And when you do this several times, let's say we call this function 6 times, which is the length of your list also, is going to iterate over your list and print each and every value which we have inside the list. Now if you use this value 7th time, that means our iterator is exhausted, it's going to automatically throw the stop iteration error. So we don't need to create or raise this stop error by ourselves. Generator function will take care of it by itself. Now as we have seen in the last video also, we can use a for loop with the iterators. So you can also write for x in your my list variable, and then you can print the value of x every time, and this is going to give you the same result. And you can see it gives us the same result, which is all the elements of your list which you have provided here. So now this whole list class is performing the same operation as this small piece of code which we call generators. So let's discuss the advantages of using generators. First, we have already seen that generators are easy to implement. Second is generators are more efficient if you want to perform the same logic with the normal function. So let's say you want to perform the same functionality, which is to iterate over the list of these numbers, and let's say this list is big enough. Let's say this list length is 1 million. Then if you are using the normal function, your normal function has to store all the 1 million values inside that list variable, and that's not very memory efficient. But whenever you use this kind of generators, they are more memory efficient because they are not going to store 1 million values in the variable. Your generator function is going to work on the values one by one. So let's say you want to stream some data. Let's say you want to stream a video and you don't know the length of the video. Then in those cases, the generators are much efficient because they will work upon your stream in steps. It's not going to wait for your stream to come entirely and then work upon it. So generators are good to work with streams also. So these are the few advantages of using generators in Python. So that's how you use and create generators in Python. In this video, I'm going to show you how you can pass the command line arguments to your Python script. So to start with, I have a script called myparser.py, and in order to pass the command line arguments to this .py file, first of all, we need to import a built-in module which is called argparse module. Now using this argparse module, we can parse the parameters which is passed using the command line to this script. So let's see how we can parse those parameters. So first of all, I'm going to declare a variable called parser, and then I'm going to use this argparse keyword which we have imported, and there is a special class here which is called argument parser which we are going to use. Now this argument parser class takes an optional parameter which is the description, which we will see a little bit later. So the first step is to initialize your parser. The second step is to add the parameters which you want to parse. So this we will see in a bit, but let's see the next step, which is actually parsing the arguments which is passed using the command line. So let me declare one more variable which will be our arguments which we want to parse, and then we will use this parser variable which we have created and call the method called parse args. So now once you have used this method parse args with this parser variable, then you will have all your arguments into this args variable. So let's run this script and let's see what happens when we run this script. So in order to open the terminal in PyCharm, you can just click on this option which says terminal, and this is going to open the terminal in the PyCharm IDE. Now it depends in which project you are working in. So if you see some other location which is opened using this terminal, you just need to provide the path where your project is. So I'm going to right click on my file, and then I'm going to copy the path of this file. So right click and copy path, and I will just do cd and I will paste this path which I have copied, and I will remove the name of the file because I just want to cd to the directory in which I'm working in. So now I'm in the directory in which this myparser.py file is present. Now in order to run this Python script, I can use this Python keyword and then the name of my file, which is myparser.py file. Now whenever you import the argparse module and you initialize this module, there is a special help parameter which is available. So you can write -h here and then press enter, and you will see that this help parameter is automatically present whenever you import this argparse module and initialize it. So this is one way of running your script. You can also run your script on your Windows or Linux terminal. The process is same. So you need to cd to the directory in which you are working in. So I'm going to once again copy the path and paste it here. And once I'm in this directory, I will just write Python and the name of the script, which is myparser, and then -h, which is for help, and it's going to give me the same kind of result. So you can run your Python script either on the Windows command prompt or in the PyCharm. The choice is totally yours. So I'm going to use this PyCharm terminal. So let me minimize this terminal for now. Now, as I said, you can pass some argument here in the argument parser class. So the argument which you can provide here is the description, which is the description you want to give whenever somebody runs this script. So this is going to be the description whenever you run your file on the terminal. So I'm going to once again run this Python file, and you can see the description is printed here now. Now how to pass the command line arguments. So you can pass two kinds of arguments as the command line arguments. One are called positional arguments and other are called optional arguments. So first of all, we will see how to pass the positional arguments. So in order to pass the positional argument, you use your parser variable and then call a method called add argument here. And first of all, inside the add argument, you give the name of your argument. For example, I want the user to provide two numbers and I want to perform some mathematical operations on these two numbers. So I can store these two numbers into some variables, and these variables I can define here. So the first variable name I want to provide here is num1, and then as the second argument you provide the help parameter. So in the help, what you do is you provide some help about the argument which you want to receive from the user. In the same way, I can provide the number 2 argument, and I can just change the name of the argument 2 and the help description of argument 2. Now the third parameter or argument which I want to provide using command line is the operation. So let's say we want that user should provide some kind of mathematical operations to work with. So in the help, I can just write provide operator. So these are the three arguments which I want the user to provide. Now once these three arguments are provided by the users, these three arguments will be parsed using this function, and then all these three argument list will be assigned to this args variable. So we can just print the value of this arg variable and let's see what is the content inside the args. So I'm going to open the terminal once again. So after the Python keyword and the name of your script, you provide the first number, which is, let's say, 84, the second number, let's say it's 41, and the operator. So let's say I want to provide the operator plus to add these two numbers, and then I'm going to press enter, and you will see this print statement is going to print the value of number 1, which is 84, the value of number 2, which is 41, and the value of operation, which is plus here. You will also observe that all these three numbers are present in the form of string. So in order to work on these numbers, we need to convert these numbers first into a float value or the integer value, and then only we will be able to work on these numbers. So how we can provide the type of these two numbers so that our script understands that these are the numbers and not the strings. So the way in which you provide the type of the argument is using the type keyword here, and then you provide whatever type you want for your argument or the parameter. So here I have written type is equal to float, and in the second argument also I have written type is equal to float, and by default the type is string. So if you don't provide any type, it's a string. So now we have provided the type to our first two numbers, and let's run the script once again. So now you will see that these values are no longer string values, but now they are some float values. Also, whenever you run this script with -h keyword, which is the help keyword, it's going to show that these are the positional arguments which is required by the script, which is number 1, number 2, and operation. And also we can use -h as the help, and also it's going to give us the description of this script which we have provided here. So now we can perform some mathematical operations on the arguments. So let's perform some mathematical operations on the arguments. So we can extract these arguments using the args keyword and then calling the name of the variable which we have provided. So args.number1 is going to give you the value of number 1. So what I want to do here is I want to know the operation first of all. So args.operation, and if this operation is equal to plus, then I will just add these two numbers. So I'm going to just say args.num1 num1 plus args.num2. Now after adding these two numbers, I need to save these numbers into a variable. So let's create a variable called result here, and I will initialize this result by none. So initial value of result is none, and then we will assign the addition of the two numbers to the result parameter, and then at the end we will just print the value of the result. And the same I will do for the other operations also. So let's define some more operations. Second operation I want to provide here is the subtraction. Third operation I want to provide here is the multiplication. And let's say fourth argument I want to provide here is the power of operation. So here I can use an inbuilt function which is POW, and then I will just pass the first number as the first parameter, so args.num1, and the second number as the second parameter. So now let's run the script once again, and let's see what happens when we run this script once again. So I'm going to provide the same parameters 84, 41 and operation plus here, and then press enter, and you will see the result here is the addition of these two numbers, because our plus condition is met for the operation, and then it's going to just add these two numbers and print the result. We can make this result little bit more sensible by just saying this is our result. So I'm going to just say result colon and then provide the comma here, and once again let's run the same script with the minus operation this time. So I'm going to provide the minus operation now and then press enter, and it's going to still give me the addition. This is strange because I think I have done some mistake here, which is I haven't provided or changed these operators from here. So in the case of minus I need to provide the hyphen here, and in the case of multiplication I need to provide the asterisk here. So let's run the code or script once again with minus, and now you will see as a result you will see the subtraction of these two numbers. Let's run this script with POW and then press enter, and it's going to give me the power of operation of these two numbers. So this is how you can provide the positional parameters. Now as the name suggests, these are the positional parameters. That means every parameter have its own position, and this position is defined by the declaration here. So the first position is for the number 1, second position is for number 2, and the third position is for this operation parameter. So if you change the position, for example, I will provide the plus operator first and then these two numbers, this will give me an error, and it will say that I was expecting a number as the first argument, but you have provided some string parameter here. Also, if you don't provide any parameter, so I'm going to just say first two numbers I will provide, but operations I haven't defined, then also it's going to give me an error, and this will say that operation is not defined because we haven't defined any operation here, so it's going to give us an error. So there is one way of solving this error, which is by providing the default value, and in order to provide the default value you use the keyword default and then provide the value of it. So let's say by default the operation is plus always, and when I run this code once again, it's going to still give me this error because these are the positional arguments. We cannot change the position of this argument, and we cannot provide the optional values here, and that's where the optional parameters comes in. So using these optional parameters you can provide the optional values. So let me show you how you can provide the optional parameters. So the way you provide the optional parameters is by simply adding double hyphen symbol in front of your parameters. So I have provided double hyphen symbol in front of each and every argument which is provided to the script. And let's go to the terminal once again, and this time we need to provide the name of the parameter, which is hyphen num1 space the value of it, for example 80, and then we need to provide the second number, which is hyphen num2, and then after the space the value of number 2, And let's say I don't want to provide the operation now. And when I press enter here, it's still going to give me the result, which is plus, because now we have the default value of operation, which is plus. And if I don't provide the value using these command line arguments, then the default value of this operation will be taken, which is plus. If we provide any argument here, so hyphen hyphen, let's say operation, and we will provide the value of operation, let's say minus here, then it's going to give us the subtraction of these two values. So whatever argument you will provide here, the default value is overwritten by that value. So this is how you can use the optional parameters. And in order to use the optional parameters, you also need to give the name of your optional parameters. Now, whenever you use the optional parameters, it depends upon you at which position you want to use these optional parameters. So I can use, for example, num1 at first position, operation at the second position. Let's say operation is multiply now, and then I will provide the num2 at the third position. It doesn't matter now because the position is irrelevant here, because we are providing the name of the variable and then the value. So value will be parsed using the name variable and not by the position. Now there is one more notation which you can use with these optional parameters, and this is the short form of whatever parameter name you want to give. So let's say I want to give n as the number 1, and let's say I want to give I as number 2, and for operation I want to provide this letter O. So this is the short form of these three values. So n is for number 1, I is for number 2, and O is for operation. And also in front of each and every letter here, we need to provide a single hyphen. So either you can provide this kind of notation with explanatory keyword and double hyphen, or a single letter and single hyphen in front of it. So now in order to use this kind of notation, what I can do here is, first of all, let me call Python and the name of my script, and let's say first of all we call the help, and you will see this help shows this letter also, which is -h or help. And for our parameters, we have -n or the number 1, -i or number 2, or -o or operation. So the way we provide these shorthand notation is we just need to write the name of the notation, which is -n for number 1. Let's provide the value of number 1, and -i for number 2. So you use this equal to symbol in between the value and your shorthand notation, not the space. So this time I'm using the equals to symbol. So I equals 70, and the value of -o is equal to, let's say, plus this time, and then press enter, and it's going to give you the addition of these two numbers. So for this shorthand notation, you use the equal to symbol, not the space in between the name and the value. So this is how you can provide the command line arguments to your Python script. In this video, I'm going to show you how to use lambda functions in Python. In addition, I'm going to show you how to use lambda functions with functions like map, reduce, and filter. So let's get started. So as we all know that Python is a multi-paradigm language, and it also supports functional programming. And the lambda functions falls into functional programming paradigm. So what are lambda functions and how to use lambda functions? So lambda functions in Python are also called anonymous functions because they don't have any name. Sometimes they are also called one-line functions because they can be written in a single line of code. So let's see how we can define a lambda function. So as you can see here, I have three normal functions defined here. One is the double functions, which doubles whatever arguments you provide here. Second is a simple addition function, and third function is the function which takes 3 arguments and provide the product of the 3 arguments which are provided. So let's see how we can convert these 3 functions into the lambda functions. So the first function which we have is the double function. So I'm going to once again write double as a variable, and then I can use a special keyword called lambda to create a lambda function. So as you can see here, this double takes 1 argument which is x. So to provide an argument in the lambda function, you just write the name of the argument, and then after the colon you write the body of the function. So in our case, this double function have this body which is return x multiplied by 2. So in lambda function, if you want to return some value, you don't need to use this return keyword. You can directly write x multiplied by 2 here. So this lambda function is equivalent to this double function which is a normal function. So this double function takes 1 argument which is x, which we are providing here, and it returns the multiplication of x by 2, which we are writing after the colon. Now let's write the add function using lambda function. So I'm going to once again declare a variable called add and once again use lambda. And this time this add takes 2 arguments. So I can provide multiple arguments in lambda functions by comma as you do with the normal functions. So I will provide 2 arguments, and then after the colon you just write whatever you want to return. So we want to return x plus y, so we can simply write x plus y here, and that's it. So in a single line we can define the lambda function. Now the third function we want to provide here is the product function. So I will declare a variable product, and this time I just need to provide 3 arguments using the comma separator, and after the colon I just provide the multiplication of these 3 values, which is x multiplied by y multiplied by z. So all these 3 normal functions is equivalent to these lambda functions. So I'm going to just comment these 3 functions out by pressing Ctrl and /. And now let's see how to use these lambda functions. So you create a lambda function and then assign the result into some variable, and then you use these variable as you use the normal functions. So I'm going to just use print to call the double variable, and then using the parenthesis I just provide the argument which this lambda function takes. So this lambda function takes 1 argument which is x, so I can provide the value of x here. So let's say I want to provide 10 as the value of x. Same I will do with the add function and the product function. So add function takes 2 argument and the product function takes 3 argument. So I can simply write these functions like this, like a normal function, and then I can just run my script, and you will see it's going to give us the same result as the normal function gives us. So the first is the double of 10, second is the addition of these 2 numbers, and third is the product of these 3 numbers. Now you might ask a question that these functions which we have defined normally, we can also define these functions in a single line because there is not much logic inside these functions. So we can declare these functions like this, and they are also the single line functions. So why do we use lambda functions? So the lambda functions are generally used with the functions which takes function as an argument or returns function as the result. So in functional programming, functions are the first class citizens. That means we can pass the functions as the normal argument. So as you can see here, we have passed some static or constant value as an argument here. But we can also pass the functions as an arguments, and in addition you can also return a function from a function. So instead of this multiplication, you can create a function and return from a function, and that's where these lambda functions are useful. So let me give you some examples of where you can use lambda functions. So as I said, you can use lambda functions with the functions like filter, reduce, and map. So let me illustrate how these functions work. So I'm going to declare a list of some numbers. So now I have created a list which have these 6 elements. Now let's see how to use a map function with a lambda function. So there is an inbuilt function called map in Python which takes 2 arguments. One is a function and second is an iteratable variable, and we all know that collections like lists or tuples or the dictionaries are all iteratable collections. So we can use map keyword, and then here we can define a lambda function. So let's say I want to double each and every element of this list. So I can define a function which takes one argument x, and then we are going to return the double of this value. So this is the function which we have passed to this map function, because the first argument which map expects is the function. The second is the iteratable collection, so we are going to pass this list as the second value. Let me define, let's say, my list here, so it will be more clearer. So I'm going to just pass this my list as the second variable. So what this map function is going to do is, it's going to apply this lambda function to each and every element of this list, which is basically going to double the value of each and every element of the list. Now let's assign the result of this map function into a variable. So I'm going to assign the result into some variable, and then I'm going to print the result first of all. So this variable contains the map function. So let's see first of all what is the result, and then I'm going to show you how to get the result which we are expecting. So you can see here, whenever you want to print the value of map, it's going to just give you this kind of result. So how we can get the list out of this map value? In order to get the list out of this map value, you need to cast this value into a list. And how to convert this value into a list? You use a list function and then pass the result of the map function as an argument of this list function. Let's run the program once again, and you will see now that the result is a list, and in the result every element of the list is doubled. So basically what this map function has done is, it has applied this function to each and every value of the list, and this function just doubles each and every value of the list. Now you might say that this is a very simple function which we are applying to the list. So let's make things little bit complex, and let's say now I have 2 lists. One is my list 1 and other is my list 2, and this other list contains some other set of elements. So let me just change the values which this second list contains, and let's say using this map function I want to add each and every element of these 2 lists and create a third list with the addition of, let's say, 2 and 1 and 5 and 4, 8 and 7, 10 and 8, like this. So how can I create a map function to achieve this? So let's say this is a variable b, and here inside the lambda function we give the second argument which is y, so it takes 2 arguments, and then it adds the value of x and y. So we can do like this, and then as the second argument we are passing the first list, And also as the third argument, you can pass the second list here. So now what this map function is going to do is it's going to take the first element of the first list and the first element of the second list, and then it's going to apply this function to the first elements of both these lists, which is to add these two numbers. So let's see what is the result which we get using this map function. So I'm going to just convert the answer or the result into a list, and then I'm going to just pass this b variable as an argument of this list, and then we are just printing the result. So let's run the code and let's see what happens. So you can see we get the list which adds the value of these two lists and creates a new list. So you can see 2 plus 1 is 3 here, 5 plus 4 is 9, then 8 plus 7 is 15, and so on. So this is how you can use lambda functions with map function. Now let's see how to use a filter function. So I'm going to use this special function which is called filter, and this filter functions takes two arguments. But what is special about this filter function is it takes a function as the first argument which gives us a Boolean result. So instead of adding two numbers and returning, this filter function is expecting a function which gives us the Boolean result. So let me minimize this. So let's say we want to filter the even values from this list. So how we can achieve this using the filter function? So as I said, this takes a function as the first argument, so you can use lambda. And how to find out the even values? You pass an argument and then you return x modulo 2 is equal to 0. So this x modulo 2 is going to give us 0 whenever the number is even, otherwise it's going to give us 1. So this is the first argument, and the second argument we can pass here is, for example, the first list here. And now I'm going to assign the result into a variable, and let's print the value of c now using the list function. So list, and as an argument I'm going to pass c here. Let's run the code and let's see what's the result. And you can see you just get the even values filtered out from this first list, which is 2, 8 and 10. Now let me give you one more example of filter. So let's say you want to filter out from the second list which values are greater than 5. So all the values which are greater than 5 we want to filter out. So we will pass x as an argument, and let's say this is the d variable. So this lambda function takes x as an argument, and it's going to return true. So let me just write the syntax here. So it's going to return true if the value of x is greater than 5. Else it's going to return the false. So else we can just write false here. So if you want to write if and else condition inside a lambda function, you write something like this. So this is the syntax of if and else. So if the value of x is greater than 5, it's going to return true, otherwise it's going to return false. So let's run this code and let's see what happens. Let me just replace this c by d, and I'm going to run this file, and you will see the result here. So in this list you will see 8, 10 and 9 are greater than 5. That's why we got this result. If we write here greater than and equal to, and once again run the code, it's going to give us 4 values including 5 here. So this is how you can use filter function with the lambda functions. Now let's see how we can use one more function which is called the reduce function. So in order to use the reduce function, we need to import a special module which is functool. So let's import this module, and this module is called functools. So we are going to write from functool import reduce. So what we are basically saying is we need a reduce function from this functool module, and now you can use a reduce function. So I'm going to declare a variable e, and then I can use this reduce function, which also takes two arguments. One is the function and other is the iteratable collection. So let's define a function first of all, which is the lambda function, and this lambda function is going to take, let's say, two values x and y, and what it's going to return is the sum of x plus y here. Now as the second argument, I'm going to pass my list variable here. So what a reduce function does is it takes first two element of the list and then apply the function which you have written here, which is going to add first two element, and then it's going to store the result in x variable and take next element into the y variable. So 7 plus y is going to give us whatever result, and once again it's going to apply the result and then going to add the next number to the result. So let's see what result we get using this reduce function. So I'm going to once again use print, and then we can directly print the value of the reduce function, which is e. So let's run this code once again, and you will see this result, which is 37. Now 37 is the sum of all these elements inside this my list. So let me explain you once again what this reduce function is doing. So first of all, because we are passing two arguments here in the lambda function, it's going to take first two element of your collection, which is 2 and 5, and then apply this code or statement to these two elements, which is 2 plus 5, and we will get 7 as the result. Now once again it's going to take 7 as the first argument, which is the sum of these two numbers, and 8 as the second argument, which is y here, and then apply this logic once again to 7 and 8, which gives us 15, and once again this 15 will be passed as x and 10 will be passed as y, and once again the addition of 15 and 10 will happen, which will make it 25, and so on. So this is how you can use lambda functions in Python, and this is how you can use lambda functions with map, filter, and reduce functions. In this video, I'm going to show you how to use nested functions and closures in Python. So let's get started. So we will start with the nested functions. So in Python, we can define the nested function. That means we can define a function inside a function. So let me give you this example. And in this example, this function, which is an outer function, takes some text or message as the argument, and I have defined one more function inside the outer function, and I named it as inner function, which prints the value of the text which we have passed in the outer function, and we are just calling the inner function in the outer function scope. So this function is declared locally inside the outer function, and we are just calling this inner function inside this outer function. Now in other words, we can also say that this outer function is an enclosing function, and this inner function is the local function of this outer function. And now when I call this outer function and let me run the code, it's going to just print the value which we have passed as an argument. So we have just passed this text argument, which is once again passed to print statement of inner function, and because we are calling this inner function inside this enclosing function, it prints the value using this statement. So when you declare one function inside the another function, it's called the nesting of functions. Let me give you one more example of the nested function, and I have defined this pop function, which is our outer function or enclosing function. And here I have defined a function called get last item, which is our inner function or the local function to the pop function. Now this pop function takes a list as an argument, and we have defined a local function inside this pop function. And what this local function get last item does is, whenever you pass a list as an argument to this local function, it's going to find out the last element of the list and return the last value of this list. So here this is the last index of the list, and then it's going to return the last item of the list, which is passed as an argument. Now you may already know that you can call a function called remove on your lists, which is used to remove some item from the list. So I'm just calling remove function on the list, and as an argument of the list I'm passing the function which finds out the last element of the list. So this is going to give us the last element of the list, and this last element will be removed from the list. And at last I'm simply returning the list which is passed as an argument to the pop function. So let's say this is the list on which we are working on, which have 5 elements, and we are calling pop function on this list again and again 3 times. So let me run the code and let's see what happens. So you can see when first pop is called, it's going to remove the last element, which is 6, from the list. And then whenever the second pop is called, it's going to remove the 4. And whenever the third pop method is called, it's going to remove the 3, and so on. So this is how you can use nested functions in Python. Now let's talk about the closures. So I'm going to use the same nested function example which I have shown you earlier. So this is the nested function. Now in order to convert this nested function into a closure, what we need to do here is we need to return the inner function without the parentheses. So the thing to note here is we don't need to return this inner function with the parentheses. We need to return this inner function without any parentheses. And this is the simplest example of the closure. So what is a closure? So a closure is a function whose return value depends on the value of one or more variable which are declared outside the function. So in this example, this text variable is declared outside the inner function, and the value of this inner function depends on this text variable which is declared outside this inner function, and that makes it a closure. And closure have a special property that this closure function object remembers the value in the enclosing scope even if they are not present in the memory. So I will explain you that, but let me just show you how to use this outer function which now uses the closure. So I'm going to declare a variable a, which means because this outer function is returning the inner function, that means a contains now the inner function. So we can use this a as the function. So in order to use this a as the function, we can just call this a using the parentheses, because this function doesn't take any argument, so we are not passing any argument here, but we will just call it as a function because this outer function is just returning the inner function. So let's run the code and let's see what happens when we run this code. So you can see it prints hello, which is printed using this print statement whenever we call this a function. So if I just call this a function without the print method also, it's going to print the hello, because here we are just using the print to print the text which is passed using the outer function. Now, as I said, closure is a function object that remembers the value in the enclosing scope even if they are not present in the memory. So our enclosing scope is the outer function. So even if we delete the outer function after declaring this statement, and if the a contains this inner function, and now let's say I'm going to just delete the outer function. So this statement is going to delete the outer function, and let me call this outer function once again after the deletion of this function. That means it's going to throw us an error which will say that this function is already deleted, so we cannot call this function. And now let's see the magic of the closure. So even if we deleted the outer function and we cannot call the outer function, but before deleting we have created a variable which contains the value of inner function, and now I'm just calling the inner function with these parentheses, and let's see what happens. So I'm going to just run this code and it's going to print hello even after we have deleted the outer function. So this means that this variable a is storing some kind of state of inner function even if the outer function is deleted. And that is the magic of the closures. So a closure function is able to remember the values which are declared outside the function also. So this is our closure function, and it's able to remember the value which are declared, which is text outside the function. And that's the beauty of closures. Now let me give you one more example of the closure so we will be able to understand it in a better way. So here I have defined a function called nth power, and I pass one argument here which is an exponent. And inside this nth power function I have defined a local function which also takes one argument, and then what it returns is the power of whatever argument we pass here, and this exponent is coming from the outer scope, which is as an argument of the outer function, which is nth power. So base is coming from the inner local function and the exponent is coming from the outer scope, and we are just returning this power of which is a local function without any parenthesis once again. So this is very important. You return the function without the parenthesis. Now I can declare some variable. First of all, I'm going to declare a variable called square, and then we will call this nth power function, and we will just pass the value 2. So now this exponent becomes 2 here, which is also passed to the inner function or the local function. So here the value of 2 is saved. That means whenever we call the square function, it's going to give us the square of whatever number we are going to pass as an argument to this square. So let's try it once and let's see what happens. So I'm going to just print and then call this square function which takes an argument, and I'm going to first of all find out the square of 2, and I'm going to run this program, and you can see it's going to give us the square of this 2, because now the square function is going to give us the square of the number which we will pass as an argument here. So this 2 is passed to the inner function because this nth power gives us the inner function because it returns the inner function. So now this 2 which we are passing in the square is passed as the base of this inner function, and that's why we are getting the square of the number which we pass here. So let's find out the square of some more numbers. So I'm going to just pass 3, 4 and 5 here, and I'm going to run the code once again, and you will see that it's going to give us the square of 2, 3, 4 and 5. So once again we have seen that the closure function is remembering the value which is declared outside the scope, which is exponent. Now whenever I use this function once again, so let me declare one more variable, and this time I want to declare a cube here, and once again I'm going to use the nth power to find out the cube of numbers. So now this 3 is passed as an exponent here, and this exponent is going to be passed inside the inner function. So exponent value is 3 here. That's why we are going to get the cube of the number which we are passing as the base argument of this inner function. So now this is the inner function, and we can once again call the print to call the cube method. This should be cube, not cure. So cube, and then we can find out the cube of 2, and let's find out the cube of 3, 4 and 5 also. So let's run the code once again, and now you will see here the cube of the numbers are printed, whatever numbers we are passing as an argument of this cube function. So in a way, this cube or this square variable is holding the status of the inner function. And that's something we have also seen in the case of classes. The classes are able to remember the state of the variables and the methods which are declared inside the classes. So closures are sometimes used in place of the classes which only have usually one method inside them, because this one method we can already define in the closure also, and it's able to remember the state. So closures can be used in place of the classes which have fewer method, generally one method inside them. The closures are also used heavily in the case of decorators in Python. So decorators we are going to learn in the next video, and I'm going to show you why decorator use closures and how to use closures with the decorators. And the third advantage of closures are they are sometimes more efficient than the normal functions. So the closures are sometimes also used for the code efficiency and the faster working of code. So this is how you can use closures in Python. In this video, I'm going to show you what are decorators in Python, and also I'm going to show you how to use decorators in Python. But before starting with this video, I will suggest you to watch the last two videos in which I have talked about the basics of functional programming in Python. So let's get started with the decorators. So first of all, what are decorators? So decorators wraps a function and modify its behavior in one way or the another without changing the source code of the actual function. So let's see in practice how to declare and use decorators. So first of all, what I'm going to do is I'm going to define a very simple method, and I'm going to name it as say hello, for example, which doesn't take any argument and it just prints hello world, let's say. Now let's say I want to decorate this function say hello, and I want to print some kind of string before and after the printing of hello world without changing the code of the function. So here we can declare the decorators. So I'm going to declare a decorator function for this, and I'm going to name it as decorator underscore func. And this decorator function is going to take one argument, and this argument will be a function. Now we have seen in the last video that we can return a function from a function, or we can pass the function as an argument of another function. So inside this function, I'm going to declare one more function, and I'm going to name it as wrapper function, which takes no argument. And inside this wrapper function, what I want to do is I want to call a function which is passed as an argument of the decorator function, and then at last I just want to return this function. So I'm going to just call return, and I'm going to return the wrapper function without the parentheses. So in the case of closures, we have seen that we can return the inner function without the parentheses, and that makes them the closures. Now let's say we are going to pass this say hello function as an argument of this decorator function, and this function will be called here. So in order to print something before and after this string hello world, we can print something here also. So here we can just write, let's say we want to print x, and we want to print this x 20 times, let's say. So we can just write this kind of notation, and after the execution of function, I want to print, let's say, y 20 times. So this is the simplest form of decorator, which takes function as an argument. Now in order to call this say hello function with the decorator, I'm going to declare one variable, and I'm going to name it as hello, and then I'm going to call the decorator function. And I told you that this decorator function takes the function as an argument, so we can pass the say hello function as an argument to this decorator function, which will be passed here, and it will be called here. Now in the last video, in case of closures, we have seen that because this decorator function is returning the inner function, that means this variable will contain the inner function. So we can call this hello with these parentheses, and because this wrapper function doesn't take any argument, so we can call it like this. And let's run the code and let's see what happens. So when we run the code, you can see before the hello world string, we have printed x 20 times, and after the hello world, we have printed y 20 times. So this is a simple form of decorator, and this is how you can use decorators in Python. But Python also provides the simple way of declaring this kind of notation. So instead of using this line of code, I'm going to comment this line of code and also this line of code, because instead of doing this, you can use this kind of notation. So just above your function in which you want to apply the decorator, you use @ symbol and then the name of the decorator which you want to apply to the function. And this notation above the function is equivalent to this kind of notation. And now we can directly use this function say hello without the use of these two lines of code. So let me run the code once again and let's see what happens. And the result is the same. So this is how the decorator works. So let's go through the definition once again. So decorators wraps the function and modify its behavior in one way or another without changing the actual code of the function. So this decorator have changed the behavior of this function without even changing the actual code of this function. Now one question which may arise here is, can we use more than one decorator with the same function? So let's try to declare two decorator functions. So we are going to declare two decorator functions, and this decorator function I'm going to name it as decorator x, and the second function I'm going to name it as decorator y. So the first decorator function is going to decorate your function with the x value, and the second decorator is going to decorate your function with the value y. So we are going to replace this by y. Now here above your function, you can use the decorator x, and then also you can use the decorator y above it. So I'm going to just write @decorator y, and this notation is perfectly fine. So you can use one or more decorators with a single function. So let me run the code and let's see what happens. So I'm going to run this code and you can see what happens. So first of all, the y decorator has wrapped the function with y's, and then after that comes the x decorator which have decorated the function with x values, and then your actual string is printed which is hello world. Now one thing to note here is the order of the decorator in which they are used. So now we will try to just exchange the places of the decorator x and y. And now let's run the code and let's see what happens. So before it was printing y first and then the x when this decorator was used at the top, and then the x decorator was used. And now when we run the code, the opposite of that will happen. Now if you want to see the equivalent notation of this using decorators, so I'm going to just comment these decorators from here, and let's try to use this kind of notation with our decorators. So I'm going to just uncomment this code, and this time what I'm going to do is I'm going to use this decorator x with the say hello, and I'm going to enclose this notation inside the decorator y. So I can use this kind of notation which is equivalent to this kind of notation also. So I'm going to run the code, and you can see because decorator y is the outermost decorator here, it's going to just print the value of y, and then we have the decorator x, which is going to print the value of x, and then our actual string. If we exchange the places of decorator x and decorator y, then the order of the printing will also change. So now this was the very basic decorator example. So let me remove this example and let me give you one more example. So instead of using this function, let me give you one more example. So I'm going to declare a function called divide, which is going to take two arguments, let's say x and y, and what it's going to do is it's going to return the value of the division of x divided by y. And let me remove these decorators from here. So in the last say hello example, our say hello function was not taking any argument, and now we are giving our divide function two arguments. That means we need to change the wrapper function here also. So I'm going to name my decorator as decorator divide, which takes a function, and I'm going to change the wrapper function, and now this wrapper function is going to take two values, which is the value of x and y. You can also write a and b, it doesn't matter, it just takes two values. And instead of this kind of notation, let me print the values of a and b first of all. So inside this print function, I'm going to just write divide, and then we are going to pass the value of a, comma, and comma b. So we are going to print the value of a and b, and then we are going to check if the value of b is 0 or not. So I'm going to just say if b is equal to 0, then we are going to print the message that division with 0 is not allowed, and also we are going to return immediately from this function. Otherwise, if the value of b is not equal to 0, then we are going to return the division of a by b. So once again, without changing the actual function, which is divide, we have changed the behavior of this function, which is divide, using this decorator function. And the last thing which we need to do here is to call our decorator function above our normal divide function. And now I can use this divide function normally. So I am going to just use this divide function inside the print, and I'm going to pass two values here, let's say 15 and 5, and let's run the code. And it's going to print first of all this line, which is printed using this statement, which says divide a and b, which is divide 15 and 5. And then because the value of b is not equal to 0, that means this value is returned with the result 3, which is the division of 15 by 5. Now let's change the value of b, and we are going to just give 0 as the value of b or y here. And I'm going to run the program once again. And now you can see that this statement is printed, which says division with 0 is not allowed. And because this function is not returning anything, or you can return a 0 from here, it doesn't matter. And I'm going to run the code, it prints 0 here. So this is how you can use decorators with the function which takes some arguments and return some values. Now let me give you one more real world example which we can use with decorators. So instead of our divide function now, let's say what I want to do is I want to declare a function. I'm going to just name it as myfunc, which takes one argument, a number. So this will be a number, and then this function calculates the sum of the number from 1 to the number which we provide here. So let's say we provide 10 here. So this function is going to give us the sum of the first 10 numbers. And now I'm going to declare a variable called sum, which I initialize it with 0. And in the next line, I'm going to use for I in some range. And this range will be the number which is provided plus 1. Because range starts from 0 and not from 1, that's why I'm adding 1 here in the range. If I want to calculate the sum of first 10 numbers, let's say, and if I provide 10 here, then range will give you until 9. That's why I'm adding 1 here. And then inside this for loop, I'm going to just do sum plus equals I, and at last I'm going to just return the value of the sum. Now till now we have seen how to create decorator functions for the functions which takes no argument or for the function which takes some argument, and we want to use these argument inside the wrapper function. But at times you need to write a decorator function which will be a generic decorator function, which means the decorator function which I'm going to create here will be used with not only this function but the other function which can take this argument or multiple number of argument or no argument. So let's see how we can write a generic decorator function. So let's say I want to measure the timing of this function, how much time this function takes in order to execute this code. And timings we can measure with any function, so it doesn't matter that we need to use this function to calculate the timing. You can also use the decorator function which I'm going to create with the other functions also to measure the timing of those functions. So because it's a timing decorator, so I'm going to name it as timing, and it takes once again the function as an argument. And because we don't know which argument the function is going to take, right now this function takes one argument, but it doesn't matter. You need to measure the time of the function which takes one argument or two argument or three argument or no argument. So that's why in that case we can use this kind of notation, asterisk args here and then comma double asterisk kw args here. And these two arguments makes your wrapper function independent of the number of argument which will be provided with this function. And in order to calculate the timing of the function, we need to import a module. So let's import a module. So I'm going to just write from time import time. So there is an inbuilt time function which we can use to get the time. And now under this wrapper, what I'm going to do is I'm going to just declare a variable called start, and I'm going to save the value of current time here. So whenever you call this time with the parenthesis, it's going to give you the current time. Now in the next line, what I want to do is I want to just create a new variable which I will call it as result, and I am going to assign the result of this function. So let's call this function with the variables which we have provided into the wrapper function. So because we don't know which argument comes with this function, so we are going to just pass these argument as it is into the function argument which is passed as an argument of your decorator. Let's provide the indent here, so this will be satisfied. And then in the next line, we are going to just print the time elapsed. So I'm going to just say elapsed time and then this curly bracket, and you already know we can call a format method on the string, and here as an argument we just want to give the result of the start time and the end time. So let's declare the end time also. After the function execution is completed, we are going to measure the current time once again, and then we are going to just say end time, which is stored in the end variable, minus the start time, and it's going to give us the time elapsed in the execution of this function. And at last, because this function or the other function can also return some value, at last we are going to return the result which we have calculated. So I'm going to just write return this result. So this is the generic timing function which you can use with any function whichever you like. So I'm going to just decorate my function using the timing decorator, and then I'm going to call this my function inside the print method. So print my function, and let's say I want to calculate the sum of first 20,000 values, and I'm going to run the code, and here in the result you will see 0.0 in the elapsed time, because this value is very small and elapsed time is approximately equal to 0 for the smaller values, because we are just iterating over the smaller value, but the sum is the exact sum. So let's increase this value by 2 zeros, and let's also print the value of start time and end time here. So I'm going to just print the value of the end time and the start time, so we know that what is the starting time and what is the ending time. And I'm going to run the program once again, and now you will be able to see that this is the starting time and this is the ending time, and you will be able to see some time elapsed in the execution of this function. And when I increase 1 0 here, so you will be able to see 2 seconds is taken now for the calculation of the sum of this number. So you can use this timing decorator in order to calculate the time of execution of any other function other than this also. So this is how you can use decorators in Python. In this video, we will talk about operator overloading in Python. Now you might already know that everything is an object in Python. So when I want to know the type of this number 2, it's going to show this kind of output. And this means that 2 is an object of the class int. Now when I once again want to know the type of, let's say 2.0, it's an object of class float. When I want to do the same operation with the string, this string is an object of class string. So everything is an object in Python. Now have you ever wondered that when you do 2 plus 2, it's going to give us the addition of two numbers, and when I add two strings, let's say 2, and then I'm going to use the same operator, which is plus operator, with the other string, it's going to give me the concatenation of these two string values. So the same operator plus is working differently with different type of objects. The same you might have observed with the multiplication operator, which is this asterisk. So when I use this asterisk or multiplication operator with a string, and let's say I write 3 here, it's going to print this given string 3 times. But the same operator, when I will use with the two numbers, it's going to give me the different behavior, which is the multiplication of these two numbers. So the same operator asterisk is functioning differently with different kind of data. Or in other words, we can say that this asterisk operator or this plus operator are overloaded for different kind of objects. So whenever this plus operator is used with two numbers, it's going to give us the sum of these two numbers, and whenever this operator is used with the string, it's going to give us the concatenation of these two strings. So both these operators are overloaded for handling different kind of data. So this is the overloading of the built-in operators. Now we might also think that if this is possible, can we overload the operators by our custom classes? So let me create a class, and I'm going to name it as the number class, which is going to take one argument. So let me define a constructor here. So underscore underscore init underscore underscore, and this is going to take one argument, which is the number, and I'm going to just write self.num is equal to num. So this is the simple class which we have created, and now I'm going to create two instances of this same class. So number, and I'm going to give the number 1, let's say here, and then I'm going to create a second object of this class, and this time I'm going to give the number 2 here. So is it possible that we can use, let's say, n1 plus n2? So let's try this, and it's going to give us this error which says unsupported operand type for plus number and number. So because Python doesn't know how to use this plus operator with your class objects, it's going to give us this error, which is unsupported operand type and whatever is the operator you are using. So it turns out that we can overload these kind of operators in Python by implementing some inbuilt methods in our class. So we already know that whenever we want to implement a constructor in Python, we use this init method. So I'm going to create a very simple class and I'm going to name it as A, and this will be a blank class. So this is a very simple class in Python, and when I use a dir function, which is a built-in function with this class, let's see what happens. So I'm going to just press enter, and it's going to print some methods here which are inbuilt method. So here not all methods are visible, so I'm going to assign this value of dir a to a variable a, and then we will see in the right hand side in this inspector here, and this is the a variable, and you will see the list of all the inbuilt methods which are associated or which you can implement them. So for example, we have implemented the init method in order to have the functionality similar to constructor, but there are other methods here too. So there is a str method or le method, which is less than method, or ne method, which is not equal to method, and many other methods which we can implement here in our class. So now I have given enough theory to you, and let's try to see with an example how to overload an operator in Python. So here I have created a class which I call circle, and this takes one argument, which is the radius of the circle. And I have created the setter and getter method for this radius variable, and in the third method I'm just calculating the area of the circle using the radius, and I have also used an inbuilt module which is math in order to get the value of pi. So using this expression, I'm just calculating the area of the circle. Now I have created two objects of this class with two different radiuses. So in the first object I have given the radius 2, and in the second object I have given the radius 3. And from the theory which we have learned till now, we already know that this expression will not work with these two objects. So when I run this code, it's going to give me the error which says unsupported operand error. So now we are going to overload this plus operator in this circle class. Now in order to overload a particular operator, let's say plus, you need to implement an associated method in your class. So with this plus operator, there is a special method which we need to implement in our class, and I have given the list of all the methods which is associated with the operators. So with the plus operator, you need to implement this special method which is underscore underscore add underscore underscore. In order to overload minus, you use this method. In order to overload the multiplication, you use this method. So here is the operator which we want to overload, and here I have given the method name which you need to implement in your class in order to overload this operator in Python. So there is this list which you can use with all these operators. So you can overload the mathematical operators in Python. You can also overload the bitwise operators in Python like and, or bitwise right shift or bitwise left shift. And also you can overload the comparison operators in Python using these associated methods with these operators. So now we want to overload this plus operator, so we will implement this add method into our class. So let's implement this add method into our class, and implementing this method is really simple. You just need to define a special method which is underscore underscore add underscore underscore, and this add method is going to take two arguments. One is self, you already know, and the other is the object of the other instance. So this second argument is the object of the circle class. And now inside this method, I'm going to just return. First of all, I will just use this circle as the constructor. And what I want to do, I want to add, let's say, the radius of the two objects which are provided. One is the self object and other is the object which is provided using this argument. So I'm going to just say self dot underscore underscore radius plus the circle object radius. So let's use this circle object and then dot and then underscore underscore radius. So basically I'm adding the radius of the two objects. One is this circle object and other is the radius of the self, which is the current class. So as soon as you implement this method add using these two arguments, then this operation is going to work in Python. So because we have overloaded the plus operator using this add method, now this operation is going to work. So let me just assign the addition of these two objects into a third variable, and this variable I'm going to name it as C3. And using this C3, let's say I want to print the radius of the circle. So I'm going to just use the print method and then I'm going to use the C3 object and I'm going to call a get radius method from this object. And let's print the radius of C1 and C2 also. So here I'm going to just write C1 and here I'm going to just write C2. So we are printing the radius of all these three objects. And I'm going to run the program now. And you can see here the radius of the first object is 2 because we have provided 2 as an argument here. The second is 3 because we have provided 3 as an argument here. And because we have created this third object using the overloading of this plus operator where we were just adding the radius of both the objects, that's why we got 5 here. So 2 plus 3 is equal to 5. And this addition we have done using this expression. So we have added the radius of the current class and the object which is passed using this argument. So this is how you can overload the operators in Python by implementing the associated methods which are available in Python. So let's say now we want to overload the less than and the greater than operator. So for the less than operator, we use this LT method, and for the greater than operator, we use this method called GT. So let's implement these two methods inside our classes. So I'm going to just copy this add method 2 times. And first of all, I'm going to replace this by LT, which is less than. And the second method I'm going to replace by GT, which is greater than. And we want to see if the radius of the circle is greater than the second radius which is provided using this object or not. So first is less than, so we are going to provide this operator, and second is greater than, so we are going to provide the other operator which is greater than operator. And now this less than and greater than function is going to give us the Boolean value. If this radius is less than this radius, then it's going to return us true, otherwise it's going to return us the false. So I already have the two instances of two classes, and if I want to compare these two classes, I can just write C1 and I will use the less than operator here and then C2, and also I'm going to use the greater than operator here. And let's run the code and let's see what happens. So now it's going to give us this value, which is the constructor of the circle. So how can we get the Boolean value? You just need to remove this constructor from here. So you just need to remove the name of the class. And now I'm going to run the code once again. And now you will see true and false. So we were checking if C1 radius is less than C2 and it gives us true. And once again, we were checking if C1 radius is greater than C2 and it has given false to us. Also, we can check the third object for example, C3 here, if C3 is greater than C2 or not, and most probably it's going to give us true, and it's correct here. So you can see it's that simple to overload any operator in Python using these built-in methods. So you just need to find out the associated method related to that operator, and then you just need to implement that method related to that operator. In addition, you can also implement some other methods which are available with the class. So once again, when I'm going to print the dir with any of the object, let's say C1, and I'm going to run this program, and you can see the list of the functions which you can implement inside your class. So add is already there, but you can also implement this dict method or dir method or any of these methods which are available here. So repr method or str method, any method you can implement inside your class in order to avail the functionality associated with that method. So at last, let's try to implement one of the method which are associated with the class. So let's say we want to implement this method, which is the str method. So I'm going to just minimize this, and I'm going to just copy this function and once again paste here, and instead of greater than, I'm going to just implement now the str method. Now this str method only takes one argument, which is self. So I'm going to just remove the second argument, and here in the return value I can just return some string, for example. So I can just say circle area, and I'm going to return the area of the circle. So I'm going to use this concatenation operator, and then I'm going to convert the area into the string, and then I'm going to just use self dot area, which is going to give us the area of that circle. So once you have implemented this str method in your class, you can simply use it like this dir method. So I can just write str and then the name of your object which you have created, and let's run the code and let's see what happens. So I'm going to just see the result now, and it prints circle area, and it's going to print the area of the circle. I just need to provide equals to symbol here, so we will be able to see it in a prettier way. So you can see the area of the circle is printed. Similarly, you can print the area of the other two circle, which is circle 2 and circle 3, and let's run the code once again. It's going to print us the area of all these circles. So this is how you can use operator overloading in Python. In this video, we will talk about a command line tool which is called PDB, which we use to debug our Python script. Now PDB stands for Python debugger, and it is already installed whenever you install Python on your operating system. So you don't need to install PDB separately. If you have Python installed, it will work on your terminal. Now you might wonder why I'm using PDB if I already have the PyCharm IDE and I can debug my code on the PyCharm IDE. Now in real life situations, most probably you will run your Python script on some kind of a server. Now generally on these servers, you don't have the luxury of using an IDE. You will have to use the terminal in order to debug your Python script. And that's why I wanted to show you how to debug your Python script using the command line tool, which is PDB. Now to start with, I have this simple Python script which asks the user to input two numbers, and these numbers will be saved in these two variables, which is x and y. Now we are using a function called add to add these two values, and then we are just transferring the result into this z variable, and we are just printing the value of z. Now in order to open the terminal in the PyCharm IDE, you just need to click on this option which says terminal. And if you don't want to use this terminal, you can also use a Windows command prompt or Linux terminal, or if you are working on Mac OS, you can also work on the Mac terminal. So what you need to do is you just need to copy the path of your file where you are working, and then you just need to cd to the directory in which you are working in. So I'm going to just cd to the directory in which my Python script is there, and then the command will be same to run and use pdb on your terminal. So you can use the Windows command prompt or this terminal which is available in the PyCharm, or any other terminal which is available on your operating system. So I'm going to use this terminal which is available in the PyCharm. Now I'm going to move this terminal to the right hand side, so we will be able to see the code and the command terminal at the same time. Now in order to run your script, you already know that you just need to give this command which is Python and the name of your script. In my case, the name of my script is debugging.py. So I'm going to just press enter, and then it's asked me to provide the first number. I'm going to provide the first number, and then I'm going to provide the second number, which is going to give me the sum of these two numbers. So here it prints 3344, which is not the addition of these two numbers. Now some of you might already know what is the problem with this code and how to solve it, but we will use the debugger to find out what is the problem and how to solve this problem, so that whenever we enter two numbers, it's going to give us the proper sum of these two numbers and not the other answer. Now in order to start the debugging on your Python script, you can provide this command. So you can give python -m pdb and the name of your script. So my script name is debugging.py, and then I'm going to press enter. And now you will be able to see this kind of interface, and you will be able to see pdb printed here, and there is a cursor blinking here. And this Python debugger, which is Python pdb, starts from the first line of code which you have on your script. So we are on this line, which is this line in our script, which is the declaration of this add function. Now the first thing you need to know in order to work with this pdb interface is the help command. So you can give this help command here, or you can give the h keyword, which means the help command. So I'm going to give the full help keyword here and then press enter, which is going to give us the list of each and every command which you can use with the pdb. So these are all the commands which you can use with pdb. The most important command which we will be using frequently is the next command, or shortcut of the next is n, or we will be using the step command or the s keyword for the step command. Otherwise, we will be using the c keyword or the continue command. These are the three most frequently used command to work with the pdb. Now you can see, you can type help and the name of the command in order to know more about that command. So I'm going to just write help here and the name of the command. Let's say I want to just know more about the next command. So the next command continue execution until the next line in the current function is reached or it returns. So in this way you can get the help about each and every command which you have here. Now once again we are going to find out at which position pdb is right now. We already know that pdb is on this line, but there is a command called where, or you can also write w to find out where right now your pdb is. So I'm going to just write where, and it's going to show on which line your pdb is currently standing. So now I'm going to give the n keyword. You can also give the next command here, and I'm going to press enter, and it's going to go to the next line, which is this line, which is the if name is equal to main. So now we are on this line, right? Once again, when I press enter, it's going to execute the last executed command. So we have executed last this next command. So if you press enter directly without entering any command, it's going to execute the last executed command. So now we are on this line, which is this one, which takes the input from the user, and you will also be able to see on which line this code is. So this line is at the 7th line. Now once again, I'm going to press help here and then press enter, and now I want to use this continue command. So this continue command is used to continue the execution of your script from the point where you are right now. So we are right now at this line, which is line number 7, and if I press C or if I type continue, which is this keyword, and I press enter, then my program is going to execute and it will ask me the first number. So I'm going to provide the first number, let's say 2, and then I'm going to provide the second number, which is 3, and then when I press enter, it's going to execute the program and it's going to print the result, which is 23 in this case, which is wrong. And after the script is finished, the PDB is going to restart the execution from the top. So you can see this line, the program is finished and will be restarted. So once your program is finished, the PDB is going to restart it from the starting point from where it has started. So I'm going to quickly provide the N command for next, and once again next, and I'm going to once again press next and provide the number, which is 3 this time. So now we are on this line, which is the line number 8, which is this line. So the execution of this line is finished. Now there is a print command in PDB, so you can just write print and the name of the variable. So I'm going to just write X here because this line is already finished, and it's going to give me the value of X. So when I press enter, it's going to print 3, which is the value of X. Once again, I'm going to press the N command or the next command, and then I'm going to provide the second number, which is 4 this time, and I'm going to print the value of the Y now. So till now, nothing seems to be wrong with this code. So let me just press H for the help once again, and we are going to see the list of commands once again. And now I want to use this command, which is what is. So I'm going to just write what is and the name of the variable, which is X. Okay, so earlier we have printed the value of X, which is 3, and now I'm writing what is X. So we want to know what type of value is inside X. So I'm going to just press enter now. And once you do that, you will see that X is an instance of class string, and we wanted to enter the number, right? So now we know what is the problem. So because input function is going to return the string value, and this add function is just concatenate these two string values, and it's not adding the two numbers. So what is command is going to give you the information about the variable or the function. But we will continue our debugging. So you can see here, right now we are on this line, which is this line. So now I want to go inside the add function in order to inspect if it's working fine or not. So we are on this line where add function is called. So I can use this command, which is the step command, or I can use the shortcut, which is S, in order to step into the function where we are right now. So I'm going to just type step here and then press enter, and you will see we are here on the declaration of add function once again. And if we type N or next once again, we will go to the next line of this function, which is this line, which we use to add the value of X and Y. So this command step or this letter S can be used to step into your function or step into your class. If you are using class, it's going to step into or inside that function. So now I'm going to just press N to go to the next line, and this is the return sum line. And now we already know what's the problem, so we can press C or continue in order to continue the execution of this program. So I'm going to press C and then press enter, which is going to continue the execution of the program, and it has printed the result, and also it has restarted the PDB once again from the starting of the script. So now let's correct this code, and in order to convert the input into int or the float, you can just typecast the string to int using this int function. So I'm going to just use this int function in front of both the input values. So now we know that our script is most probably going to run fine. So let's try to set the breakpoint at this line, because both the values will be available at this point and we will know the values of x and y at this point. So we will be able to see the type of both the values. So first of all, what is a breakpoint? So when you set a breakpoint at some line, the program is going to stop exactly at this line. So generally we have seen that if you start the PDB, it's going to start from the beginning of your script. But if you set the breakpoint, the execution will only stop at the line where you have set the breakpoint. So once again, I'm going to press H to get the help, and I will see which command can I use to set the breakpoint. So there is this command called break, which I can use to set the breakpoint. So let me get the help about the break, and it's going to give us the description about the break command. So you can use the break keyword or the B letter in order to set the breakpoint. So you can see it takes these arguments. So in order to set the breakpoint, you just need to write break and then the line number on which you want to set the breakpoint. So let's say I want to set the breakpoint on the line number 9. So I can just write break and then 9 and then press enter, which is going to set the breakpoint on line number 9. Now I can give the continue command in order to continue the execution of the script. And now when I press continue, it's going to first ask for these two values. So I'm going to quickly give the value of first number and the second number. And then when I press enter, it's going to stop at this line where we have set the breakpoint, right? So right now we are on this line, which is line number 9. And now I can give this command, which is what is x. And once again, it says that the type of this x is string. So what might be the problem? The problem is after changing our script, we haven't restarted the PDB. We haven't exited the PDB and restarted the PDB. So this script is not loaded after we have edited the code, right? So in order to quit the PDB, you give the quit command or the Q letter. So just press Q and then press enter, which will allow you to come out of PDB. And let me run the debugging once again. So you can once again give this command python -m pdb debugging.py and then press enter, which is going to restart the debugging. And now this script is loaded once again with the correct code, which is int. So now let me just put the breakpoint on the line number 10, which is this line. And now I'm going to press C to continue, and I'm going to give these two numbers, let's say. And you can see the program is halted on the line on which we have set the breakpoint on. So once again, I'm going to give the what is command and the name of the variable, which is x, and then press enter. And now you will see the type of x is now int, and we have solved the problem. So we can simply press C to continue and see the result. And you can see it prints the result, which is 8, which is the addition of 3 and 5. So our debugging was successful, and we are now seeing the expected result which we wanted to see. So this is how you can use PDB to debug your Python script. Now there are few more ways of using PDB with your Python script. So let's see those other ways in which we can use the command PDB with our Python script. So I'm going to press Q in order to exit out of the debugging. So the second way of using PDB is to import the PDB inside your script. So I can just import the PDB library inside our script, and then in order to set the breakpoint, I can use PDB dot set trace. So this will set the breakpoint on the next line after this line. So I'm going to just clear the terminal by right clicking and then pressing clear buffer. And once again, to start the debugging, I just need to give this Python command and the name of my script. So once you have this import inside your script and you have this code inside your script, you don't need to give the pdb command. You just need to run your script normally with the Python command. So my program execution is here, which is running the program normally. So I'm going to just give the value of x and y, which is 3 and 4. And it's going to stop the execution at this line, which is just after the set trace code. Okay. So because we have set the breakpoint on this line using this line of code, it's going to stop at this point. And once again, I'm going to use, for example, what is command, and I want to see the value of x, and it's going to show us the type of x, which is int. So this is the other way of using pdb in your script. Some people also like to use pdb directly at the point where they want to set the breakpoint. And the benefit of using this type of code is, if you are using any linting tool, it's going to warn you on the same line, so the developer will know that he needs to remove this line because linting will fail because there is a semicolon here and we are using 2 lines of code in the same line. So it's going to give us the warning, and that's how the developer will know that he needs to remove this line. So he is going to remove this line after the script is working fine. So this was the second way. I'm going to quit out of the pdb once again, and let me show you the last way of debugging your code with the pdb command. So I'm going to clear the terminal, and now I'm going to just give this Python command, which is going to open the Python shell. And here you just need to import the script which you are working with. So I'm working with the debugging script, and then import the pdb. And once you have imported your script and the pdb module, you can just use pdb in order to start the debugging of your script. So pdb.run, and under the brackets or under these parentheses, you just need to give the name of your script. So my script name is debugging, and then you need to provide at which point you need to start the debugging. So let me enclose this code inside a new function. So let me define a new function, and I'm going to name it as main, and this is going to be my main function. And inside the main function, I'm going to execute all this script, and I'm going to just call this main function inside this if condition. And here on the Python shell, I can just write debugging dot the function which I want to call. So I'm going to just call the main function, and then I'm going to press enter. And once again, it shows me that debugging doesn't have this main method because after saving, I haven't restarted the pdb once again. So let me just quit once again quickly, and let me just quickly close this terminal and restart this terminal. And once again, I'm going to give the Python command, which is going to start the Python shell, and I'm going to import the pdb and the script once again. And now I can just give the pdb.run command and then give the name of the script on which I want to work on, which is debugging. And then I'm going to call the main method inside the debugging and then press enter. And once again, give the n command, which is for the next, which is going to start the debugging of your code. So this is how you can use the pdb command in order to debug your Python script. In the last video, we have seen how to debug our Python script using Python debugger or pdb. Now in this video, I'm going to show you how you can debug your Python script using PyCharm IDE. So to start with, I have this Python script which takes 2 user input, both numbers, and I have created this add function which just add these 2 numbers and return the sum. And using this print function, I'm just printing the sum of these 2 numbers. Now let's run this code normally without any debugging. And I'm going to just give 2 numbers here, 44 and 55. And it's going to give me this kind of output, which is wrong because the sum of 44 and 55 is not obviously 4455. Now some of you might already know the problem with this code, but let's debug it with the help of the Python debugger. So in order to start the debugging in PyCharm IDE, you just need to click this icon which looks like a bug, and when you hover over it, it will say debug. So I'm going to click on this debug button, which is going to start the debugging of my program. So you can see here this debugging window is opened, and this debugging window have two sections. One is console section and other is debugger section. So right now we are in the console section where we can provide the user inputs and see the output of our Python script just like the normal output. Now there is also a debugger window where you will be able to analyze the variables and all the frames of your program. So I'm going to go to the console window, and here I'm going to provide the first number and the second number, and I'm going to press enter, and it prints the sum of these two numbers, which is not correct, but our Python script is finished executing. Now in order to debug this Python script, we need to set the breakpoint at which the execution of the program will stop, and we will go step by step after this point. So I'm going to set the breakpoint at this line, which is line number 13, at which my main function is called, and then click on this line where you want to set the set point, and you will be able to see this red circle logo, which means that we have set the breakpoint at this point. So let's start the debugging once again, and you will see because we have set the breakpoint here, the program execution is stopped at the line number 13. And how you know that the execution is stopped at line number 13? You will be able to see under frames this line which is highlighted, and you can see the line number is 13. So at this point the program execution is on the line number 13. Also you will be able to see these kind of icon on top of this window. So the first icon here is the step over icon, which you can click to step over your code. The second icon is step into icon, using which you can step inside your function or a class on which you are currently on. The third icon is step into my code. So generally if you use this option, which is step into, and your program contains some inbuilt or built-in functions, then it's going to go into those built-in function. And this other option which says step into my code is going to only step inside your code and not into the built-in functions or the classes. There are few more icons here. One is force step into, and other is step out, which we are going to see later. Also under this variables section, you will be able to see the values of your variables. So first of all, I'm going to click this button which says step over. You can also press F8 to step over. So I'm going to click this button, and because my program asked the user to provide some input, I will go to the console and provide those inputs. So I'm going to just give 33 as the first number and 55 as the second number, and then once again I'm going to press enter, which is going to print the output, and we come out of the debugging. So now you know that this breakpoint is not helping us. So we are going to remove this breakpoint, and we are going to set our breakpoint here on the line number 9. So here we will be able to see the values inside the variable x and y, so that we know what's the problem inside our code. So let me start the debugging once again. And once again, I'm going to give these two inputs, 33 and 44, let's say. And then you can see our program execution is stopped at this breakpoint, and you will be able to see the values of your x variable and the y variable. Now immediately you will see that this x value is the string, and also this y value is the string. And whenever we use this plus operator with two strings, it's going to give us the concatenation of those two strings. Also in the variables, you will be able to see the list of variables and the type of those variables and the values inside those variables. So you can see x has string type and the value is 33, and y has also the type string and the value is 44. Now I told you that you can use this button to step into your code. So I'm going to click on this button which says step into my code, which is going to step inside this function. So our program execution was on this line. This was the breakpoint we have set. And when I clicked this step into my code, it has stepped into the function add. If I would have pressed the step over button, then my program execution will go to the next line and not inside this add function. So because I have pressed this button which says step into my code, that's why it goes inside the function. So here also you will be able to see the values of your x variable and y variable, and also you will be able to see the value of the sum when you just click the step over button. And here you will be able to see the value of sum, which is 3344, which is the concatenation of these two numbers. So immediately you will know that you are not adding these two numbers, you are just concatenating two strings, which gives you this kind of result. So once you have pointed out the problem in your code, we are going to stop our debugging. So there is this red button here, which is a square button. I'm going to click on this, which is going to stop the debugging. Now in order to fix this code, I can just typecast this input, which is a string, into the integer, and with the second variable also I'm going to do the same. And now let's start the debugging once again. And once again I'm going to give the two numbers 33 and 44 and press enter, and the program execution will stop at the breakpoint. And now you will be able to see the values here, which is 33 and 44. And under variables, you will be able to see the type of these two numbers, which is now int. So both are int values. I'm going to step over now. So last time we have stepped into the function, which is the add function. This time I'm going to just press the step over button, which is going to not go inside the add function, but just step over to the next line. And you will be able to see the value of z here, which is 77, which is the correct sum of these two numbers. So this is how you can use PyCharm to debug your Python script. In this video, we will talk about a special tool called Python pip. So we are going to see what is Python pip and how to use Python pip. So let's get started. So first of all, what is Python pip? So pip is a command line tool for installing and managing Python packages, which are generally found on a special index called Python package index. Now, if you want to know more about Python package index, you can visit on a website called pypi.org, pypi.org, and you will be able to get more information about Python package index on this website. So what is Python package index? Python package index, or PyPy, is a repository of software for Python programming language. Now PyPy helps you to find and install software developed and shared by the Python community. You can get more details about PyPy by clicking on this link or this link, which are shown on the home page of PyPy. And you can see at the time of making this video, there are almost more than 150,000 projects available on this index. And if you want to search for any special project, you can search it using this search text box. So let's see how we can use Python pip using command line. So generally, whenever you have installed Python on your Windows or any other operating system, pip will be installed with the same installation of Python. So if you have installed Python 3.4 or above, most probably the Python pip will be already installed on your operating system. Now to check which version of pip is installed on your system, you can give this command python -version and then press enter, and it's going to show you the version of pip installed on your system. So you can see pip 10.0.1 is installed on my Windows operating system, and the Python version which it supports is 3.7. Now the first thing which you need to know about this tool called pip is how to use this tool. So to know more about this tool, you can give this command python -help, and it's going to show you the commands which you can use with this command line tool. So here you can see the usage. You give the pip command and then one of these commands, either install, download, uninstall, list, show, and all these other commands in order to install a package or uninstall a package or get to know more about a particular package. Also, there are some general options here which you can read. So for example, if you want to get help, you give these options, or if you want to print the verbose output, you can use these options, and if you want to know the version, you can use these options, and all these other options are available with this command line tool, which is pip. So let me clear this command prompt with the command called cls, and I'm going to first of all go into the Python shell using Python command, and in here I'm going to import a special package called Flask, and I'm trying to see if it's already there or not. So I'm going to press enter, and it's going to show me this error which says module not found error. So this module Flask is not right now recognized by my Python interpreter. So let me just exit from this interpreter by just pressing exit, and now I'm going to just give cls. So in order to know more about a particular package, you give this command python search and the name of the package. So in my case, I want to just search for a package called Flask, and I'm going to press enter, and it's going to give me a big list of packages which are related to Flask. So because Flask is a popular package on Python package index, that's why you can see so many options for the Flask package. So I'm going to once again clear the terminal, and I'm going to install this package which is Flask. So in order to install the package, you give this command pip install and the name of the package, and then press enter, and it's going to start downloading this package. So now you can see this package is successfully installed on my system, and you can see the version which is installed is Flask 1.0.2. Now in order to know more about a particular package which you have already installed, you can give this command. So in order to know more about the package which you have already installed, you give pip show and the package name. And when I give this command, you can see the name of the package is Flask, the version which is installed is 1.0.2, and there is a brief summary of this package also which is available here, and the home page for this project is also available here, who is the author, and all the other details about this package which you may find useful are given here using this command, which is pip show and the package name. Now after installing a package, I'm going to verify if this package is available using the Python shell or not. And once again, I'm going to try to import this package which is Flask, and then press enter, and you will be able to see now I don't see any error. So if you don't see any error, this means that this package is successfully installed, and in future you will be able to import this package to use it on any of your Python script which you create after installing this package. So let me once again exit from the Python shell, and let me clear the command prompt once again. Now in order to list out all the packages which are installed on your system, you can give this command, which is pip list, which is going to print the list of all the packages which is already installed on your system. Now in order to uninstall any package, you just need to give this command pip uninstall and the name of the package. For example, I want to uninstall this package which we have installed, which is Flask, and I'm going to press enter, and you can see it says uninstalling Flask, and it will ask you whether you want to proceed or not. So you just need to press Y in order to proceed, and once you press Y, it's going to just uninstall that package from your system. And at the end, you will see this message which says successfully uninstalled and the package name which you have uninstalled. You can once again give this command pip list, and now you can see Flask is no more in the list of installed packages. So this is how you can use Python pip in order to install and manage your Python packages. In the last video, I have shown you how you can install and manage your packages using Python pip. Now in this video, I'm going to show you how you can install and manage your pip packages using PyCharm IDE. So here I have a very simple OpenCV Python script which I use to load this image, which is pythonlogo.png file. Now in order to run this script, I need to import this package which is called cv2, and this package is available on Python package index. So let me just open the pypy.org website and let me search for OpenCV here. And when I search for OpenCV, you will be able to see multiple OpenCV related packages, but the one I want to install is this one, which is OpenCV-Python. So I'm going to click on this package to see more details about this package. So you can see the latest version of this package at the time of making this video is 3.4.3.18, and in order to install this package with pip, you just need to run this command, which is pip install OpenCV-Python. Now in order to import this OpenCV-Python on your PyCharm IDE, what you need to do is just create your project and write your code, and then go to the file and then go to the settings. So just choose the settings option here, and once the settings option is open, you will be able to see different categories here. You need to choose this category which says project : the name of your project, and then click on project interpreter. Now by default, some packages are already available here, which is pip and setup tools, and we want to install a special package which is OpenCV-Python. So in order to add this package, you just need to click on this plus button. So I'm going to click on this plus button, and you will be able to see this search bar here. So here you just need to search for the package you are looking for. So I have just entered OpenCV-Python here, and the first option which is available here, I have just selected it, and you can see this is the same package which we have seen on the Python package index website. So let's match this once again. So here you can see the latest version is 3.4.3.18, and here also the latest version is the same, and the description is also same. So wrapper package for OpenCV Python bindings, and here also the description is same. So this is the package we want to install. If you want to see the GitHub repository also, I'm going to just scroll here, and then I'm going to open the GitHub page from the PyPy website for this OpenCV-Python, and this GitHub URL is also same which we are seeing on the PyCharm IDE. So now we know that we need to install this package which is OpenCV-Python. So we just need to click on this button which says install package, which is going to install this package for your project. And after some time, you will be able to see this message which says package OpenCV-Python installed successfully. So I'm going to just close this window, and after closing this window, you will be able to see that this OpenCV is now visible in your project interpreter. And now we are going to click once again OK, and once you click OK, you will be able to see here at the bottom some processes are running, which is the process of importing this library into your project. And after some time, you will see that this red squiggly line for the error has disappeared from the import CV line. So now we will be able to run this code. So let's run this code and let's verify if everything is working fine. So I'm going to just right click and then click on run the project name or the file name, and it has opened the picture which I want to open, which is this Python logo picture. So this is how you can install and manage your pip packages using PyCharm IDE. In this video, we will talk about global variables, local variables, and non-local variables. So let's get started. So to start with, I have a very simple function which is func, and here it has one print statement which is printing the value of x. But you can see here x is not defined locally inside the function. Instead, I have declared x outside the function, and I am just assigning the value to x just before calling the function here. So what do you think will happen? So let's run the code and let's see what happens. So because this x is declared globally and it's in the global scope, so first of all, your function will search for the value of x inside the function in the local scope, and if it doesn't find the value x inside the local scope, it's going to see outside the local scope in the global scope for the value of x. And we have defined this value of x outside the function in the global scope. So this print statement will take the value of x from the global scope, and that's why it's printing global using this print statement. Now let's modify this function a little bit. So I'm going to define a local x inside the function, and I'm going to assign a new string to it. So let's say this is a local value, so I am going to assign the string to the x. So now we have x variable inside the local scope of the function, and also we have another x variable outside the function in the global scope. So what do you think now will happen? So let's run the code and let's see what happens. So you can see here it's going to print local because the variable will take the local value, or local value have more priority than the global value. So whatever variable is declared nearer to the use of this variable, that variable value will be used, and that's why the local is printed, because it's declared nearer to the use of this x, which is inside the local scope of this function. Now let's print the value of x outside the function. So in the global scope, I want to print the value of x once again, and let's run the code and let's see what happens. So this local is printed using this print statement, and the global is printed using the print statement which is outside the function. So right now things are easy to understand. When you declare this value x outside a function in the global scope and call the value of x using print, then it's going to print the global, and whenever you use the variable inside the function in the local scope, it's going to print the local variable value which is local to the function. So this means variable x which you have declared inside the function is the local variable, and this variable x which you have declared outside the function is the global variable. Now let's make things a little bit interesting, and I want to just print the value of x before even assigning the value local to it. So right now I want to do something like this. So until this print statement, I haven't declared the value of x locally. So using this print statement, the value of x is supposed to be taken from the global variable, which is this variable. And then once we have declared the value of x locally, then this print statement is going to print the value of x using the local variable. But when we run the code, it's going to give us the error, and it's going to say that this is unbound local error, which is local variable x referenced before the assignment. So right now what we are trying to do is we are trying to mix the global and the local variables, and Python is not able to understand whether x is a local variable or x is a global variable. So to solve this problem, we need to state explicitly that this x which we want to call using this print statement is the global value, right? So x here we want to take from the global value. So to state that, we can use a keyword called global and then the variable name. So by writing this kind of expression, we are telling Python that x is declared globally outside the function and we want to take the value of x globally. So using this statement, we are just stating that use the value of x using the global scope. Now when we run the code, it's going to run fine. So now you can see it has printed global here. So let me just change this print statement so we will be able to understand what's happening really here. So I'm going to just assign some number to the print statement. Let's say this is number 1 print statement and then this is number 2 print statement and this is number 3 print statement. So we are going to know which value is printed using which print statement. So I'm going to run the code once again and now you can see first print statement, which is this one, is going to print global because until here the value of x is taken from the global scope. So it's going to print the value of x which is global, which is defined here. Now you can see here we are reassigning the value of x and we are just saying that now we want to assign local to this x variable. But still this variable is the global variable because we have explicitly stated here that take the value of x from the global variable. So this global variable value will be reassigned and now this global variable value is local because we have reassigned the new value inside the global variable x. And in the third print statement, because we have already changed the value of x here, now the new value of x will be local and it will be accessible from the global scope also. So this also prints local. So once again, when you use this expression, you are telling your local function that use the value of x from the global scope. So now whenever you reassign some other value to x, this is not the local declaration. You are just reassigning the value to the global variable which is x here. Okay, so once you have changed the value of x to local, it will stay there. That's why here also it has printed the value of x is equal to local. Now let's talk about the non-local variables. So non-local variables behave almost similar to global variables, but they have some differences. So let's say I will define, instead of saying that this is a global variable, I'm going to say that this is a non-local variable. And when I run the code, it's going to complain and this is going to say that this is a syntax error and no binding for non-local variable is found. So non-local variable bindings you can only do inside the nested function. So generally you use non-local variables inside the nested function. You cannot use this non-local keyword instead of the global keyword. So let's see how we can use the non-local variables inside the nested function. So what I'm going to do here is, let's say I'm going to define the value and let's say this time I want to just use the value of x as numbers. So here I'm going to assign x is equal to 20. So this x is in the global scope and I'm assigning 20 to it. And then I'm going to once again inside the function, I'm going to declare a local x and I'm going to assign 50 to it. And then I'm going to define one more function inside this function and I'm going to name it as, let's say, inner function, and let me just add the def keyword. And then inside this inner function, what I'm going to do is I'm going to define a non-local variable, once again x, and then what I'm going to do is I'm going to reassign the value of x is equal to 100. So what I have done, I have declared this x global variable and assigned 20 to it, and inside the function also I have declared one local x variable and I have assigned 50 to it, And inside the inner function of this function, I have defined a non-local variable which is x, and I have assigned the value 100 to it. So now what we are going to do here is we are going to call this inner function inside our outer function, which is the func function. Okay, so this is the inner function, and we are calling this inner function inside this function which we have declared. So now what do you think will happen? So let's run the code and let's see what happens. So this first print statement, which is this one, it's going to print 50, because until now, before calling the inner function, the value of x will be taken from the local scope, because we haven't stated here explicitly that x is a global variable. So the value of x will be taken from the local scope, right? So we haven't written here that value of x is a global variable x value, right? So that's why the value of x will be taken from the local scope, and that's why it's printing 50 here using the first print statement. Now here we have called the inner function. That means the value of non-local variable is assigned to 100, and once again we are calling the value of x. So here inside the inner function we have defined the non-local variable. That means it's not a global variable, so it's not changing the value of the global variable, or it's not using x from the global scope, but this x will be taken from the local scope. So this x will be overwritten by 100 values. This is the new value we are assigning to our local variable, which is x, right? So that's why it's just giving us 100 using this print statement. So this non-local keyword you generally define inside the nested functions to state that we want to take the value of x from the local scope of the outer function, not the global scope. So this x is essentially this x which is defined inside this function, and we are just reassigning the value of x to 100, and that's why it's printing 100 here. And also you can see this print statement which is printing the value of global x, which is this one. That's why it's printing 20. So because we are not using this global x inside the functions, because we have just used the local variable x inside the function, and then we have reassigned the value of 100 to this local variable, this x is not going to change, and that's why it's printing 20 here. Now let's see what will happen when we change this keyword non-local to global. And once again I'm going to run the code. So now let's go to the function, and here we have defined the local x, which is different from the global scope. So until here the value of x will be taken from the local scope. So this print statement, because we haven't called the inner function before this, so the value of x will be taken from the local scope. So here it's going to print 50. Now after this print statement we are just calling the inner function, and inside this inner function we are just saying that take the value of x from the global scope, not the local scope. So using this expression we are saying that take the value of x from the global scope. So this value will not be affected by this reassignment, because now we are changing the value of the global x and not the local x. So that's why when you call this print statement, the value of x will be taken from the local scope. So using this print statement, when you call x, it's going to take the local value of x, because this inner function has no effect on this value of the local x, and that's why it's printing 50 once again using this print statements. So this x value will come from the local x and not from the global x. And the last print statement is going to print 100, because this is the global x we are talking about, and we have already changed the value of global x to 100 using this expression. That's why it's printing 100 here. So there is a difference between non-local and the global variables. If you write here non-local, then here this value will be treated as the local variable. So here we are changing the value of the local variable of x. If you declare this as the global variable, then we are changing this value which is in the global scope. So this is how you can use global variables, local variables and non-local variables in Python. I hope you have enjoyed this video. I will see you in the next video.